Thank you. Good morning, everyone. I think we will start still very early for Bangalore standards, but we'll start at the paucity of time. So my name is Ahmed. I'm part of the organizing team here at Zak. I'll take a couple of minutes to introduce the Zak World of Façades conference series, and then we'll get straight into the action. So we've been organizing the Zak World of Façades conference series since 2012. This is our ninth edition actually here in Bangalore. So Bangalore was the place we did our first event back in 2012, 27th July. And that's taken us all across the world. Right now, executed this event in 47 countries. We went to some exotic locations such as Georgia, Uzbekistan earlier this year, which were very unique places. There's lots of constructions happening, but not too many dialogues on the building envelope and the facade. So we keep exploring different countries, and then we learn a lot from different countries. The way facades are designed, engineered, installed in different regions are completely different. I think in Europe, in the US, most part of the Western world, it's about carbon reduction. Especially in Europe, the new build projects are very less. So there's an emphasis on adaptive reuse or renovating the existing building with a new facade with better energy efficient materials and design. So it's very different, the content over there. And then you have the Middle East Asia, which is predominantly new build. And then in new build, you have different set of challenges. So today's program is completely on new build. That's what our market caters for. And we've got people from India and from overseas who are designing and engineering facades, actually speaking their experiences on the same. These events are courtesy our event partners. I'd like to start off by thanking our presenting partner, Schuko. So Schuko is a German company. They're a global leader in aluminum door, window, and curtain wall systems. They are now pretty popular in the Indian market and are taking the leadership on the aluminum systems product range. Then our powered by partner is Aluplex. Aluplex is a leading facade engineering contractor here doing projects all across India. Asablo is a Swedish company. This is their automatic door division, entrance control and access control division, which is participating. Blick is a Polish company, so they've got some stone cladding systems and other products for the podium and the building envelope. Cotswold from the UK, they've got hardware for doors, windows, and facades. Dow from the US is a global leader in silicon and sealing solutions, formerly known as Dow Corning. So they are global leaders in their segment. FG Glass is one of the leading glass processors based out of Mumbai, operating nationally. FunderMax, Austrian company, again, very popular products. High pressure laminate has picked up a lot, I think, Bangalore based, and they've really developed this segment of high pressure laminate as an alternative to other existing cladding materials. GE Silicons, again, a big global player in silicon solutions. They are represented with their local partner, Diamond Engineering Cooperation. GU is from Germany, another hardware provider for doors, windows, and facades. Janssen is a Swiss company. They've got steel profiles which are used for doors, windows, and curtain wall. Jotun, they are again a global European player into powder coating solutions. Kinlong, again a leading Chinese player. They've got several products, glass hardware, fittings, tools. Every year they seem to be buying a company, so their product range is extensive. Curare is the mother company of the laminated glass interiors, Throsipol and Sentry Glass. So of course, laminated glass, all of you know, and they are the leaders in providing interiors for the same. Qtone is a ceramic manufacturer from India. Initially started off with the floors and walls segment, and now they've engineered the product to the external facade as a cladding material. Viva, again, started off as an aluminum composite panel manufacturer, but now have evolved into other metal composites. They've got a wide range of finishes which they claim, and they're exporting globally. A proud Indian company exporting globally. Of course, just in the wider region, our next event is not here in India, but in East Africa and Kenya. So we've got our third edition happening over there on the 2nd of October. And of course, our largest in the series in India is Mumbai. That's on the 10th of October at the Zak World Convention Center. So every event, we curate different topics. We have storytelling, which I'd like to say that's what our presenters do. They have a story which they'd like to share, and then our storytelling varies from city to city, country to country. And just before we conclude, I think the basis of these shows are our exhibitions on glass processing, doors, windows, facades, and aluminum extrusion, which is the one we started off in this industry back in 2003. So we've got our 23rd edition of the glass event happening on the 4th to 7th of December in Bombay this year. We've recorded today's event, so those speakers who have given us presentation to share their recording with you, you will see their presentation on a YouTube link, which will be given to you a week from now, so you can watch the recordings in case you miss anything. Of course, we've got our 17 tabletop displays outside, so please meet our sponsors during the networking break or throughout the course of the day. Would be very helpful because these are the manufacturers who help us with these events. So, without taking much of time, I'd like to call upon our event host and convener, Ms. Lolita Almeida. She's worked with leading architectural firms, developers across the globe and in town. So she is an associate director in Rathi and Associates. She'd be taking you through until the end of the day. I hope you enjoyed today's edition. I look forward to getting your feedbacks at the end of the day. Thank you so much.
Thank you very much, Ahmed, for an energizing start to our day. Good morning, ladies and gentlemen, and welcome to Zak World of Façades for its 10th edition in Bangalore and its 190th global edition. First of all, thank you very much for being here with us this conference. It's great to see each and every one of you this morning. As Ahmed already mentioned, I'm an architect, so I wouldn't dwell too much on myself, but I'm currently working at Rathi Associates as an associate director. We have today an exciting lineup of speakers as well as an interesting panel discussion later on in the day. Before we start, can I request you all to keep your phones on silent throughout the session? So, good to go. Ladies and gentlemen, before we proceed with the program, may I inform you all that we will not be taking questions for speakers during or after their presentations, but the speakers will be around in the networking area where you will have an opportunity to speak with them. All right, we are now ready to welcome our first speaker of the day. Please give a big round of applause to Ashish Jauhri, Director at DSP Design Associates.
Good morning, everybody can hear me here. It is great to be here. Thank you, Zak, for calling us to share whatever we have learned over the last 20-25 years of my professional life. It is amazing to see that Zak has gone from a very small organization to where they are today and going across the world to wonderful cities, hopefully taking Indian architects and contractors to all those cities as well, which is nice to know. When they had approached me and they said that you can speak on any topic, I was wondering what to talk about. And I thought that facade has always been very close to me, and how it performs, it behaves, how it has become from just a skin into a very adaptable, responsive envelope method to design our buildings together. Of course, the buildings of the, of all typologies and the facade are some sort of intertwined with each other. And hence, it is very important to understand that from various aspects of how a facade can respond. And hence, I chose this topic about beyond the skin. And you will see in some examples that I have been showing here, the work that I have been inspired. So it's mostly my personal reflection of what I have learned over the last 20-25 years. I have been fortunate to work in India now for the last 12 years, and before that, 6 years in Europe. And before that, another 6 years in Singapore when I left to do a master's from India. So let me quickly, can I have that? Thank you. I like to start from this little basic diagram, which talks about Marcus Vitruvius long time ago, where they said that the three basic principles of a building while designing is its strength, which is the firmitas, the functionality, which is the utilitas, and the venustus, which is the beauty. Now, this beauty is something which is amazing because it can change everything, the way it is looked upon. And everybody, whether they have the knowledge, skill, would always have an opinion about that part. Over the last few years, the contemporary facade, I would say a few decades, had developed itself into another virtue, which is called the mobilitas. It is by the name, it means kinetics, which means something that is moving. But if you look at it from the perspective of facade, it also talks about dynamicity of the facade. It talks about adaptiveness of the facade. It talks about responsiveness to the environment, to the context it is built. And of course, we are talking about smart facades, intelligent buildings, and all those things. One of the first examples on the kinetic part of the mobilitas, which is one of my favorite projects by Calatrava, is the Milwaukee Art Museum, which was built in 2001. This is, of course, 25 years old now. But the building was amazing. It was a statement. It was a functional museum. It had the ability to move. It could stand as a building, as a sculpture, a bird which is about to fly on Lake Michigan. Then I go back 200 years old and understand the Indian context, the responsiveness. Now, this building has been standing like it was built yesterday. Even today, it has taught all of us how a facade should be looked into. The hot and dry climate of our country towards the west is something that we have to all deal with, and everybody in the world have to deal with sun which is falling in terms of cutting the glare, air which should be brought into the building, which is the way it has done, and also respond to the culture. Now, it did multiple things by doing just one type of facade. It brought the air into smaller holes through the building, thereby cooling the environment inside. The color of the building and multiple buildings have made the city called the Pink City, as we know. The small little holes stop all the glare that cuts inside and bring diffused light inside. Also, on the cultural aspect, all the processions which were going in on the street in front, the ladies could stand behind and look down easily without people looking back into them. So the kind of things that it could solve, we are still learning from facades like this, primarily. I will quickly take you through some more examples. This was one of my ex-firms, Morphogenesis. I've done a project in Jaipur, where a modern interpretation of that same screen idea, which is a double skin facade, has come into place, where the sun is cut from the screen on the outside. It allows a space of buffer that probably helps in aspects of cooling down the building, and the impact on the second wall, which is the second layer of the facade, is now need to do less work as compared to being on the outer skin primarily. A similar example, which another contemporary architect have done in Bhubaneswar, is the Krushi Bhavan. Now, they have gone one step ahead in understanding how the cultural aspect, the art and craft can be representing into the building, and at the same time do all the buildings, all the things that the building should do. For example, bringing in air, bringing in light in a diffused manner, taking in cool air through the facade vents and through the floor up to allow the hot air to collapse with night purging ideas. All these are great, ideas. Similar concept, another very famous architect, Dr. Mr. Mehrotra, has done in Hyderabad. He has gone one step ahead while defining the facade. Similar double skin concept. As we know that we are just building and not really taking care of the environment. It was amazing to see how greens can be brought onto the top of the building. And he also took one more dimension forward. It was about social inequality. You can see the picture here, whereby the people who are working at the same time inside the office, the staff who are maintaining are also on the same floor. So that was the idea. It was booted by the architect to say that the facade can also be designed to allow equality in the workplace primarily. I will go back 25 years ago, back to Paris, where the screen that you saw is interpreted in a manner which is most well represented in the Institut des Mondes Arabes in Paris, the very famous architect called Jean Nouvel, whereby this screen was put behind the glass to allow the heat to come inside the building. We are here in India trying to stop the heat outside of the skin of the building, but the heat was brought into the building while the glare was stopped. And he managed to think of it in a very interesting manner, whereby the camera aperture kind of a technology was utilized. There was sun which was cut because of the screen, and these apertures were able to become bigger in size or smaller as and when the sun came in front of it primarily. Unfortunately, when I visited, I came to know that a lot of sensors were not working. So the technology was still catching up with the thought the architect proposed. But that was resolved a few years later in another building in Abu Dhabi. This is the Al Bahar Towers in Abu Dhabi in 2012, completed. Here, because of the way the weather is, you have to stop the heat outside and you don't have to bring them inside the building. And that's what this architect managed to do quite well. ADAS was the architects, I know them, I've worked with them together on multiple projects. So here what you see is that the screen cuts the sun on the outside of the glass, opens it up, even closes depending upon the sensors, and managed to do a building which is very, very responsive to the kind of harsh environment where it is built. Let me take you through Sydney now to another building, which is the ENY headquarters in Australia. Here again, the temperature can vary from minus 10 degrees to plus 35 degrees, and the facade has to perform all functions because inside the temperature must remain plus minus 24, here and there. So what they did is they did a dual skin facade. They put a double glazed entity on the inside. They put a pressurized cavity in the middle and a single skin facade on the outside with a fill the inside cavity, which is filled with solar cutting mechanism, which is the blinds that you see. And the buildings looks beautiful from any side that you see at any time of the day. Part of this facade that you see is open windows, while when the sun is coming, it is closed windows towards this side. But the way it was conceived, it is like a monolith primarily. Amazing project. Another interesting project, I think everybody knows about the Apple headquarters. You may not know a few things about it, which I may tell you. One is that there was no vertical support in the glass that is there. Second is the size of the panel was 45 feet by 10 feet, each of them. The windows don't open, but 9 months of the year, this is naturally ventilated building. They did one more thing. Amazing. Foster is always pushing the boundary. I don't know about the cost part because India is a very cost-sensitive market, but this is an experience center where all their new iPhones are launched. If you see the first picture, this is like a UFO standing. Why is it a UFO? Because it is the glass which is supporting the structure. There is not a single mullion in this. This is what the building is, basically. Amazing the kind of things that are happening onto the facade. I found this very interesting. This is in Iceland. The architect thought of a module which has a 12 side to it, small metal frame, put glass on all sides of it, put it on anywhere because it's a self-supporting structure, nothing around, and you get magic. It looks like crystal. This is a self-supporting system of facade which has no structure by itself. This is in Iceland, as I mentioned to you. Another interesting project on similar lines on a little more low cost base, but this facade cleans your air. What it does, it has titanium dioxide coated onto the facade, and all the pollutants, which is your nitrous oxide, is brought down and broken down into less toxic gases primarily. And it is actually a hospital. As a result, it cleans up. They say that it can clean up the air pollutants of 1,000 cars in one day. That's what the facade does. So look at the way the facade has been evolving with the kind of things that we can define in terms of energy consciousness, cutting solar radiations, increasing the workability of the facade. This is another very, very interesting project in Hamburg. This was also done about 10, 12 years ago. It is called the BIQ house. It generates electricity. The microalgae, which is trapped between the two layers of glass with the sun and the UV rays falling on it, creates heat and biomass. The heat using a mechanical system is utilized to heat up the building, while the biomass is converted into biogas and bring off-site to some other place to be used. I will quickly now take you through a couple of projects that I have been involved or the firms that I have worked upon. This was the first project. I was invited back to India by the French government, and this is the campus of theirs in New Delhi. This is a very beautifully done project by an architect called Shemetov, and our very famous Raj Rival was a collaborative architect for him. They had a Mughal garden in between the main embassy building and the residence, and they wanted me to propose a temporary building, but you had to respect the context. So we found a place where we could do, of course it is on top of a garden, but we didn't touch the garden. We lifted the building up. We used the sensibilities of what I showed you earlier in the Hyderabad project, where the greens are brought up without disturbing what it is, and the red sandstone was brought up. And the building was designed in such a way that it is part of the garden, and you don't see anybody working, but people inside see all the Mughal garden on the outside. Another project recently, when I was heading another firm called Morphogenesis, Infosys approached us and they wanted to, I don't want to go about why this building was done the way it was done, but there were major issues. I'm sure at the time when this building was conceived by a very famous RPs, sir, I respect him quite a lot, and Narayan Murthy sir, who's the owner of Infosys, when they did, but there were major issues. I have had instances where they told me that people come with sunglasses sitting into this office. There have been incidences where somebody has put an umbrella into an office working because of the glare that is coming. Now, what we did was we were to bring a sensitive, eco-sensitive building, and Infosys has a mandate with us not to do any blinds. And we have done that on 2 buildings, which I'll show you right away. So what we did is we said, don't break this down. Let's just remove the skin. The form of the building was like an egg. What we did is we straightened it out by extending the slab. So it's called adaptive reuse of the thing. And we designed the facade in such a manner that there is a cavity between the outside and the inside. The glass is set into the facade, into the inside the building to cut the glare. And we use the concept of the light shelves. And that's the new building. Exactly the same slabs continue, just remove the skin and remodel. This is called adaptive reuse. Another building that I was involved in Morphogenesis was in Nagpur, their campus again. Same concept. They don't want any blinds onto the building. It is strange to see so many glass buildings with a lot of blinds come into the picture. We have to be sensitive towards the urban environment as well. So this is what we designed. The red and the oranges that you see are the hues of the area of Nagpur. You can think about oranges, you can think about tigers, you can think about the notes of the music. But primarily the idea is to create a contextual facade while dealing with the nuances of the heat that needs to be stopped while the natural light needs to be brought inside. Another interesting project that DSB recently done for Bagmane here in Bangalore, you would know the Ananda new campus for Google. Now, what is interesting in this thing is the sage glass that has been used. If you have traveled in any of the new airlines, you will realize that when the sun hits the glass, it tints. It is exactly the same glass that is here. It does not require any shading. Your quality of natural light is still very, very conducive for working. The glass tints itself, stops the heat and allows a very comfortable environment without putting a single blind onto the building. And the connect to the nature which is outside, you are not disturbed with that. Not a single blind or shade has been used on this. Another project that I was involved after coming to India after about 4 or 5 years. This is a project initially designed by Foster and Partners. There were multiple issues on this project. Number one, when the project was designed initially, can I go back? When the project was designed initially, in Bombay, I don't know, any of you knows or most of you would know that there is no space available. It is chawls all around. So what do you have to do? It is called slum rehabilitation project. You have to move those people into this G+20 buildings. Thereby the builder gets the land and he has to build this building to make money for himself. When this building was done, it was before RERA. So they did a 310 meter building and then sold it off nicely to multiple clients. I have the contractor and the facade consultant in this room sitting, whom we have worked together. The challenge was different. The challenge was the building cost was unviable because it was designed by Foster & Partners, of course, to be anywhere in the world. When I say anywhere in the world means they have a certain set of specification. The facade is designed in a manner that it can withstand minus 20 degrees, like in Chicago or London, or plus 40 degrees. However, in the context of Bombay, the temperature never goes below 10 degrees. So do you need it? Do you need to over-design the facade for that matter? That was one challenge. The second was when finally they built the rehab and they got the new height, it was curtailed to the neck, 267 against 310. So all the fun part on the top was completely gone and the clients was wondering what to do. So we ended up redesigning the building from the perspective of saving the cost and saving the face. Let me put it like this. What is more important is that we realized that the glass of the building was set inside, which means direct sun was not coming because of the deep balconies. Hence, we could reduce, I would not say reduce, we could optimize the glass to suit the environment. So fit for purpose is what we have to do. And in this process of doing all that, in terms of responding to the local context and the weather of Mumbai, we managed to save about 150 crores. It's a big number for any project to become viable. And finally, the facade came out to be like that. The building on the right is what we designed. It's got built. Unfortunately, the third tower is still waiting for an investor. Right. Another project where I was with Morphogenesis, I did on similar lines of creating a new kind of residential environment whereby you have to cut the sun again. So the idea of bringing a continuous balcony helps in doing that, to cut the sun. And you manage to do a beautiful picture of the building, a new statement. If I go back again, sorry, the idea was to, this is on the river, Musi River in Hyderabad. And we thought that we can take the ripples of the water onto the building to showcase. That's the context of the building. You must be wondering why it is, the way it is primarily. All right. This is a project we did in Pune. This is for capital land. This got built. It was massive floor plate, about 1.5 lakh square feet each on every floor. Total built up area was about 3 million square feet. We created 2 courtyards. If you see, one in the shade and one in shadow, whether it is morning or evening, you will always have 2 courtyards with the sun and without the sun. We, of course, did a lot of shadow analysis, understanding how the sun is coming onto the buildings. We did CFD analysis in terms of understanding how the wind affects the facade. When you have larger floor plates, taller building, you must go through that CFD analysis or a wind tunnel test, at least the 2 of them. And then we came up with an idea. The other problem was that when you start to design buildings, a lot of buildings must look the same all around. Actually, it's not required. You need to respond to the facade where it is needed. So the western side and the southern side primarily. There was another issue of the cost, because a lot of people are very worried about the amount of cost and the maintenance of these. So we came up with this idea that we will find the cheapest way to build the sun shading devices outside. We took a 500 mm by 20 mm extrusion of aluminium, broke it down, took the lengths along the glazing, took the widths in the same fashion, cut it into half at 45 degrees and used the top, above and bottom below of that. This building could have been like that, believe me, and it took a lot of effort to convince them to do a building like that. And finally, when it got built, we were very satisfied, as a result of the building. I'll take just one more project and I'm done almost here. This is a competition that we did for Infosys. Mr. Narayan Murthy wanted a statement to tell how Infosys is going to be in the new world order. And he wanted, of course, a building to tell the world, this is a very good statement. You must have seen multiple buildings, like the Louvre or otherwise. So we thought we could do, instead of a bigger floor plate, 2 towers to allow natural light to come inside. Those towers should talk to each other, hence the form making happened as an expression. We learned from biomimetics, from how the structure of the leaf works in terms of structure. And that's the structure I'm talking of the building. This is how it came about. There was no column in the building. It was one core, which is in concrete. The slabs and all the beams were on the external periphery, which you see. It also helped to reduce the cost. This looks like a very expensive thing, but it is not. The facade was not a curtain wall going out from top to bottom. It was in between these rhombuses that you see. So it's like a normal window facade now, finally, right? We also thought how can we push the envelope and learn from whatever we have done? So we thought of looking at a glass which is transparent and generates electricity. We thought of another idea, which is a research which is still going on, but we thought since it's a competition, might as well propose a silk leaf. What it does is, it's a handmade material and it uses photosynthesis to work like the leaf in the trees. So when light falls on it, it gives oxygen out. Now imagine sitting on the 25th floor, not having a tree, but you could imitate that feeling by putting certain kind of silk leaf onto the facade and be in the garden at various floors and have that same effect of what is next to the tree. It's a theoretical idea, but right now the research is there and you can actually use this in a couple of buildings. It is yet to be used in a building of this scale and nature. We hope it gets done. Now it became about the point of cutting the sun. So the building was 26 floors tall, quite a big building. We had to find a way how to do that. We knew that we could not afford to have the opening and closing umbrella that you saw in the Al Bahar building. So what we did is we found the correct sun shading devices. We put them together and we used computer program to understand what sun shading of what depth will go on which kind of facade onto the building. And it gives us a very nice output as a software thing. And we knew exactly what sun shading to put on the outside. And we did some modeling. And finally, the building came about like that. Yeah. This was a concerted effort from all the team members to understand how the structure, the facade, the intelligence of the new technology which is coming into picture can come together and respond to the external envelope. And that brings me to the end, and I think time is up as well. So thank you very much. Yeah.
Thank you very much, Ashish. That was a very enlightening presentation. Can you imagine how responsive facades have become today? It takes care of climatic conditions. It ensures it stays firm, stable, strong. And like Ashish said, beauty is also everything. So it's good to know facades have had so much of research in the recent past, and they're very interactive and adaptable to our environment. Okay, so moving forward, I would like to invite our next speaker to the stage. That's Ashwanii Khanna from FunderMax, India.
Good morning, everyone. Before I get into my presentation topic, I want to interact with each one of you. So I request everyone to please open menti.com from your mobile. And the moment you open menti.com, you will get a code. And the code is 3507-7510. I request everyone to participate, please, because this would be interesting to get the results here. Yeah, it's 3507-7510. It's also written on the top of the screen. I can see 24 people have already logged in, but I can see more people in the room. So I encourage everyone to please participate. Okay, people are curious. They are excited. Pumped up. Yes, really, the very first presentation pumped us all. Thank you, Ashish sir. It was very good presentation. Very good takeaways, actually. Great, happy, good, wow, excited is getting bolder. In interest of time, I don't want to hear the bell. In interest of time, I'll move to the next question. The next question is related to facade. How important is the facade while designing the building? Extremely critical. Yes, it's very critical. Critical is getting bolder. Very urgent, very much beautiful. Yeah, we are talking about aesthetics as well for the facade, because facade is nothing but face of a building. It has to be unique. sustainable. Someone is talking about sustainable as well. I'm happy to see the word sustainable here. And that's what we learned from the previous presentation as well. In terms of double skin facade, how we, make the buildings visually and thermally comfortable for the occupants. Yeah, thank you. This is very important message that facade is playing a very critical role. What is your expectation from facade material? Because I represent FunderMax. So what is your expectation from facade material while making the unique design? High performance, yeah. Along with aesthetics, it should have some functionality, durable, it should be long lasting, less maintenance, cost effective. Or should we link cost effective to some kind of payback over the years? Robust. Yeah, there are a lot of points. I will like to share this presentation back to you all. I'm moving on to the next question now. What role does facade material play in ensuring the fire safety of the building? We know many cases like Grenfell Tower. So how facade can, help us in protecting the building from fire accidents? Or if the fire is breaking out, how material should behave? It should be fire resistant. Someone is saying it's a matter of security. Yes, it plays a major role ensuring people's safety. Fire resistant is getting bigger and bigger, and thank God, this is the topic of my presentation today. Thank you for making it bigger. Now I'll come to my presentation. Thanks for your participation. Yeah, so we are going to talk about fire behavior, Class A and Class B material, which are fire retardant, rear ventilated facade system, and double skin facade. Now, we know what is fire. Fire is rapid oxidation of a material, thereby heat and light is produced. Now, depending on the source of fire, we have classification of fire as A, B, C, D, and K. For example, I'll just take one example. If the fire is coming out of ordinary material like wood or combustible material, normal water is good enough to extinguish the fire, and we look for A logo on the fire extinguishers. Similarly, if the source of fire is through some liquid, we look for B. This is how C and D and K is defined. K is mainly domestic fire, what breaks out in the homes or kitchens. Then we have a classification for the material. Let's say if we talk about concrete or brick, stone, rock wool, they are classified as A1, which means they are non-combustible material. If we talk about the flashover point for this material, they will not cross the flashover point in case of fire. Similarly, A2 class materials are there. And then we have Class B material. Class B material are fire retardant material, which means they will also not cross the flashover point. I will explain the flashover point in later part of my presentation. C, D, E, and F, these kind of materials are not suitable for cladding because they will cross the flashover point, which means they will develop into a full-fledged fire in case of a fire. Now, FunderMax is offering both A2 class material and Class B material. So this is how the fire, starts. The moment material reaches the ignition temperature, there is a fire. When we are talking about A2 class material, which is MLUC in our case, this material will stay at ignition temperature. It will not cross that. And when we talk about Class B material, this material will not cross the flashover point, which means it will not develop into a full-fledged fire. So both the material from FunderMax will not cross the flashover point and will not develop into a full-fledged fire. We will understand this material in detail now. Class B material is max exterior, which is normally used in the buildings. Our 95% of sales is coming from this particular material. M-Look is a new material which we have recently launched. It is A2 class material and it is also having the same decorative surface like our class B material. For M-Look, the classification is A2 S1 D0. When I say A2, I have explained it. It is non-combustible. When I say S1 on the scale of 1 to 5, the smoke index is only 1. Normally when fire is breaking out, if the smoke is very dense, it becomes very difficult for fire extinguishers to understand the source of fire, and extinguishing the fire becomes very difficult. We all remember Upahar cinema tragedy from our childhood. That happened because of the casualties happened because of the dense smoke rather than the burns. So in case of max exterior panel, the classification is BS2D0. Here the smoke index is 2 instead of 1, which is also a very low smoke. And the smoke which comes out of these panels is non-toxic at all, because the raw materials which we are using are sourced very responsibly and are not having any harmful chemicals in that. The most important point is when we talk about cladding the high-rise building is nothing should fall out from the building when there is a fire. So droplets. There are no droplets in both the panels when it is burning. So droplet is 0. So it is very safe material to be used in high-rise buildings. Now, as per the fire standards, we comply to ASTM E84, BS47 Part 7, BS476 Part 7. EN standards, I explained it already in detail, BS2D0 and A1S2D0. And we also comply to NBC 2017. We also have NFPA test with us. This is a small case study actually. This was a residential project. Fire broke out because of short circuit in the air condition and there were wallpapers on the walls. The whole house was burning from inside within minutes. We don't have, this was very emotional topic. We don't have NOC to show the complete picture, but this is a small picture we wanted to show. The burnt panel is FunderMax panel and the brick wall. At this junction, there was a glass. With due respect to the glass as a material, we don't know what was the quality of the glass, but glass bursted. When the glass bursted because of the intensity of fire and pressure inside the house, FunderMax panel came in touch with the fire. The moment it came in touch with the fire, if you see extreme left side, the fire did not spread there. This part, the fire did not spread here and this part is exactly intact. It is brown in color. And even the integrity of the panel, if we see, none of the rivet failed. The entire system is intact. So this is how our Class B material will react to the fire, and this is the behavior of the panel. Now, when we clad high-rise building, we recommend it should be cladded in the form of rear ventilated facade system. Rear ventilated facade is creating a cavity between the wall and the cladding, thereby allowing continuous airflow, giving heat insulation and sound insulation to the building. It also acts as a rain screen facade system. The common question can come, fire can propagate from the cavity and it can go from one floor to the other floor. So we recommend a fire stop along the length and breadth of a building, thereby creating the compartments. The moment fire stop comes in contact with the fire stop will expand, blocking the fire in that particular cavity and not spreading the fire to the rest of the building. So these are some of the projects we have done in Bangalore. Left side is Jain Heights in Bangalore, right side BC project in Chennai, Mantri Lithios in Bangalore, Jain Heights. These are all high-rise buildings which we have cladded. This is in Mumbai. This is ONGC project. Again, Vasant Kunj in Mumbai and residential tower, SBI residential tower in Noida. This was very interesting project for us, Mahindra Luminaire. This was through morphogenesis. Here up to certain height, we have used 6 mm and then we, after certain height, after the upper floors, we used 8 mm panel to optimize the wind load conditions. right side, we know this is the Antilia project in Mumbai. This is Phoenix project in Hyderabad. Now, double skin facade. Our panels can be perforated and used as a screen in front of glass. This can, optimize the light and glare inside the building, thereby giving thermal and visual comfort to the occupants. These are horizontal louvers. This project we have done in Raichur. Again, the angle of louver can be decided based on the sun path analysis. This is a vertical louver, same concept. If we look at the extreme right building, this is facing the tropical sun throughout the day. This is project from Kerala. And the angle of louver is decided based on the sun path analysis. And the inspiration was traditional Jali concept. Again, some shading in front of the glass. And this is also international project, some perforation in front of the glass. That's it from our side. Thank you. And we are able to save 1.5 minutes.
Thank you, Ashwanii. That was good to know that fire and safety, which is actually paramount in our buildings, is being considered in a more intense way. Less smoke, less toxic during a fire, no droplets during fire. I think it speaks of a very good quality of facade that is coming up from FunderMax. Thank you. We now have our next speaker of the day. So, ladies and gentlemen, let's give a round of applause to welcome Rohan Keswani from Aluplex.
Good morning, ladies and gentlemen. Thank you very much for giving me the opportunity to speak here today in front of this lovely, pleasant crowd we have here. So what I'm talking about today is smart skins, talking about the growing demands and challenges of IT and commercial campuses and the kind of facades that we need that are needed today. So a bit about us. We're Aluplex. Aluplex is one of the we've been around for more than 45 years, almost. 1981 is when we started. We've done more than 500 projects, 10 super tall towers, some of them with Ashish over here, some of them Mr. Rajan Govind over here, who are in the front row. And 10 super tall towers of more than 250 meters in height, then various other commercial and IT parks all across the country. So today what I'm talking about is the need for what is the need in today's modern demand today from terms of IT campuses and commercial campuses. What we have here is we want sustainable materials. As Ashish said, nobody wants a glass box, the simple glass box again and again to be replanted everywhere. The building needs to have layers. It has to be aesthetically pleasing. It has to be pleasing for the inhabitants who are working in there. It has to have less glare. Has to have the right amount of passive ventilation, active ventilation. So based on that, I'm just going to talk about a few of the case studies that, some of the projects that we worked on and how we've tried to achieve that. So what is important, as I mentioned to you, is that there are new materials that also people are looking at. There's bamboo, there's wood, there's stone, and various other elements as well that we're incorporating. The idea is that using materials that can be locally sourced, we want sustainability in the sense that we want the less operational carbon in a building, of course. You want the right shading, the right sustainability in terms of having the less operational carbon, but also less embodied carbon. Use materials which can be locally sourced and easily available. First project I'm going to talk about is a project that we've done in Mumbai's Bandra Kurla complex. Very interesting project over here. We used curved glass right at the corner. The building comes at a corner. But what's very interesting, it has a double skin, but it's not just a passive solar shading device. It's actually an active solar shading device. So what happens is, depending on the angle of incident of the sun, is you have this louver system that we have over here, the shading device. The angle changes depending on the angle of incidence in the sun. And this was achieved, using a very interesting bespoke design system that we incorporated, indigenously designed. So we had a particular sun shading device that was connected by means to an actuator, this mechanism was indigenously designed where they were all interconnected. So depending on the angle of incidence of the sun, you could see how it could have had a manual override in there as well. you can see how the solar aerofoil shading system to reduce the glare and to, so then you wouldn't need to have those particular internal blinds, etc. So we used the system and we were able to achieve this. The other project I'd like to talk about is Godrej One. Godrej One is the headquarters of the Godrej Group in Mumbai. And a very interesting building. We worked very closely with Pelli Clark, Pelli Architects in New York to develop this project. Various elements here. As you can see, it's a block which has an external element. So you have stone sunshades, 1.2 meter cantilevered stone sunshades acting as, besides sunshades, also acting as a light shelf to reduce glare. Which is incorporated onto the unitized panel. That's one aspect of it. Second of all, it has an atrium, a very large atrium, approximately 60 meters in height. And, we have unitized glazing incorporated over there as well on the internal perimeter. And we have to reduce the sound echo in that particular atrium. We've incorporated sound absorbing perforated panels along with these wooden slats in the spandrel to give you that sound absorbing property which reduces the echo in the particular building. So we developed a unitized curtain wall system. The unitized curtain wall system was designed such that it could withstand the load or the weight of a 300 kilogram stone sunshade. These particular stone sunshades were 1.2 meter in depth, 1.5 meter in width. And this sunshade system was fixed onto the mullions without any direct connection back to the structure of the building. It was just the loads were transferred from the sunshade onto the mullions and then the mullions to the bracketry system which goes on to the structure of the building. So this is how it looks. As you can see, as you have these stone sunshades right across the perimeter of the building on each and every level. Nice interplay of stone and glass to give you that effect. Not only sort of improving the inhabitants, the glare, reducing the glare, ensuring there's no direct sunlight shining on it, whilst also giving you the feeling of a natural environment which it is on the trees environment. The other element I spoke about is the internal, there's a unitized panel glazing system on the internal side of the building in the atrium. So what we incorporated also, as you can see, is these particular sound absorbing panels that we put in there. We had perforated screens. Now when you have these perforated screens, they have a particular felt fleece that is put on the inside of it. And depending on the diameter of those perforations, which we modeled, we were able to see what is the noise reducing coefficient that those panels had. On top of those noise reducing coefficient sound absorbing panels, we incorporated wooden slats. We used Burma teak wood, and we incorporated these wooden slats that were fixed in our factory in the spandrel panels. So we had these complete unitized panels. Each unitized panel had a vision glass, which is a clear DGU glass, and the spandrel panel, which had these wooden slat spandrel panels. So that's how the atrium looks. Nice 50-meter atrium with these spandrels, which have these sound reducing coefficient wooden slats, as well as a vision panel with the clear glass. The other project I'm going to talk about is Wave Rock Phase 2 in Hyderabad. Worked very closely with the consultant who's sitting over here on the right, Mr. Rajan Govind, as well as Dow Corning on the left, where we did a lot of trials and a lot of experimentation a lot of R&D to sort of develop this system. It was one of the first projects in the country where we have incorporated stone within the unitized panel itself as an infill panel. So the idea was that it's easy to sort of do a typical granite. You have a structure. On the structure, you put scaffolding across the entire building, and on the entire building, you put a gridwork system, and then you have stones and you have masons carrying the stone up and putting it onto the building. So we didn't do that in this case. We incorporated the stone in the unitized panel system itself. The idea was that, you wouldn't have in a unitized panel system, typically it incorporates glass, but we designed the system such that we were able to have the right clamping mechanism that was within the same unitized panel system, and those clamps could accordingly hold the glass in position. Also, whilst doing that we also had a particular structural silicon and structural bond, which was incorporated so that, we had to choose the right product to ensure there's no staining of the granite, there's no staining of the stone. So we had a combination of a clamping system along with a structural bond, a structural silicon bond between the aluminium and the stone. So as you can see, eventually we have a sort of a pattern where you have glass and glass panels, glass and granite panels, as well as pure granite panels. The idea was that while the civil structure was going up, we could start off with the installation of these particular granite and glass on the building, so there could be a faster turnaround time for the developer to get his building on lease. And today this building is occupied by Apple. Apple's first store outside of, first office outside of the US. It was first over here in this. Now I think now they have more offices, but the first office outside of the US was in this particular project, Wave Rock Phase 2. The other project I'm going to talk to you today is about a project called My Home Grava. This is a very, very large campus in Hyderabad. It has 8 towers. Each tower is about 35 stories. It has various elements. It's predominantly a unitized curtain wall building, but it has different elements of fins, very, very large fins. The idea was to reduce the solar glare. It has large glass panels. It has approximately, each glass is about 3.5 meters in height. Each vision panel is 3.5 meters in height. And we have different types of sunshades that we have incorporated. We have aerofoil fins, which are approximately 450 meter in depth. We have vertical fins, which are 500 mm in depth, half a meter in depth. And then you have other types of L-type fin in different elements of the buildings as well. One interesting feature that we adopted in the design of this mullion was that we had a particular, is there a laser here? I don't know. Stop. So basically we have this interesting system in the mullion where, as you can see in this mullion as well over here, for those technical geeks, the idea is that we had a system where we had a bracket system which was sliding through the mullion. We did not have to puncture the mullion at the location of the fin because we had fins at multiple different locations. So the bracket was a sliding bracket that was sliding through the mullion, and that bracket was then bolted, and the mullion design was such that we had a particular friction when the bolt was tightened. We had friction pulling in that particular sliding bracket, which allowed us to then clamp the bracket and the fin location in position. So the idea was that the positions of the fins could be accordingly manipulated and changed at site itself without having to have any prefabrication for the same. So this is a typical methodology of the different type of fin types. It's a small little video. So this is the building under execution. Different types of fins. Vertical, just you have the horizontal aerofoil fins, you have the vertical interacting with the horizontal fin, as well as the L-type fins. And this is how we're installing the panels. We started installation in middle of January, and today we are in, I think, July, and we're already 70% through. As such, by end of October, we're looking at completing the start of one building of the first tower. Another aspect of this particular project is that we had all the design and development done in BIM. Besides, working in the model of the architect, the Revit model, and then developing it further, we got it in LOD 250, developed it further, submitted details in LOD 450, they were reviewed. But then after that model was approved and the details were approved, the MU was done, etc., mock-ups were done, we moved forward and we converted the LOD 450 model, imported the entire model into Inventor. And in that Inventor model, as you can see, is that we had every glass tag that was numbered. We had every panel that was individually coded out. Accordingly, then, right off the Inventor model, we could extract directly the glass sizes. We could extract the glass sizes. We could extract the panel sizes, the various panel assemblies directly off the Inventor model. That made it very seamless for us in terms of tracking which glass is where, what panel is where, what fin typology is where, as well as on a real-time basis, that particular model is then used to track what has been installed. And there's a, post-completion, there's a digital twin, as you can see, to track what is installed where on the building. So, key takeaways is that, various projects that we've done, different elements we've used, newer types of materials have been incorporated, not just simple glass across the building, different layers, different textures, sunshades, stone sunshades, fins, etc. And today, in today's day and age, we are using technology to ensure that everything is recorded and everything is put in place in terms of using digital technologies as far as possible. So I think I've run out of time, but thank you very much. I hope that was informative. Thank you very much.
Thank you, Rohan. That was interesting to understand how detailing, which matters to every designer, helps us to bring in interesting combinations of materials that we can use. Very good to know that we can integrate wood into the spandrels, stone onto the sunshades, and aluminum fins with excellent detailing with options to take in tolerances and sliding brackets, as well as we all know, best software that helps you to improve your efficiency in production and in the assembly. So, ladies and gentlemen, we have one more speaker before our first networking session, before our networking break for the day. I'd like to invite Rajan Govind, who is the director at BES Consultants.
Thank you. Morning to all of you. Thank you for Zak and all the key sponsors. It's wonderful to be here, the good crowd. So my topic, I'll run through about our design efficiency. So we all know we are in a booming economy, luckily. So we have passed some challenges. So at this stage, we are in a fast-moving and economy where people don't talk about cost money. So it's only delivery matter. Delivery, good building, quality, does matter. So we are in a good cycle of passing through a lot of previous generations. So efficiency, time is money means that's what efficiency comes in. So especially the facades, if architects in this room knows they been dealing with so many different rounds of design discussions. So we can see some points of how do we improve the efficiency. Once we improve the efficiency, a contractor has more time to execute the project. We don't have to spend too much time on designs. Yeah. So what we do facades is we do projects from Far East, Singapore, India, and we do some projects in Africa. So I'm going through the end of the slide, few projects, the things we have been talking about in terms of real projects. The overview of this session will be how efficiently the design can be. Design for construction, so not just for a concept and outline, design for construction. Be on the implementation side. So as a consultant, we should always be on the contractor side. So we don't want to sit on the other side of the table. How it makes a huge positive impact on the project, because consultant, architect, they are in the project maybe for years and months. They know the project better. So once they hand over to the contractor, they have to give as much as information better so the contractor can execute much better. So how it's worked. So we all know, especially the facades. So as for I'm in this industry for many years, facade we run design many times. So one time with the architect, pre-tender, post-tender, so many rounds, at least 3 rounds we run the design. Because different people coming in, different ideas. So that's inefficient design. So the design, what is efficient, what is inefficient is better you give something engineered, resolved, detail, pass to the contractor. So it is not fair we just dump the design to the contractor. So there's a big difference what is outline, what you get. So we expect to see something like this on the right. So contractors spend more time on the project. So the key process of doing this, what brings efficiencies better is you can see all the star ones are good one, where the whole team is available when we are doing a pre-construction. It is not just a consultant. You have architects, engineers, structural engineers, client. Everybody is available. The great minds are available when we are in a pre-construction design. So that's the best time you resolve all the problem with the pre-construction. And you can see in terms of when we go to the site, the design is efficiently engineered, so there's less time for designing. There's no surprises. So if you don't do this, there's a short-term decision on the site. So we don't have much time to take a decision. And if you do a lot of engineering on the site phase, it is just relying on the contractor design capabilities. So they have some limitation on the designers. So it's just relying on 1-2 professionals' inputs. So time is money now. In this cycle, what we have is time is money, where we do as much as at the pre-construction stage. So you spend less time on the construction, as we know, when especially on your implementation side, you don't have a time to do a lot of designs. So I just put some graphs in terms of how do we visualize this time lost. If you see so this vertical is basically a pre-construction and this is the construction stage. So I just put from my assumption the time is not spent. So the unspent time is so much time supposed to be spent by either consultant or architect. Someone has to spend the time. So if you don't spend the time, there's too much time spent on the construction. So then the contractor will have too much pressure on finishing the job on time with a reasonable quality. So what we need is a design. We are not lawyers. We don't need too much of paper documents. So if the design is better, design means engineer something, drawing, sketches, and that's what the design. It is not just a copy of report. You read the report, you implement. So it's too difficult to rely too much. Of course, we need just a specification, but focus more on design. So how do we convert the architectural design that better so contractor to understand is, as we work very closely with the architect, we are translating the architect to a little bit of engineering, where even the smallest thing on the building is captured in a better way. Building entrance, it may be a very small elements on the facade, but it has a huge impact. How do we translate architectural to the something buildable? When we deal with a lot of triple story height lobbies, we have an issue with the secondary structure, primary structure, how is interacting, where there are a lot of simplified design is done, just 12 meter height, you design something, but there's no interaction discussed with the primary structure. So if the primary structure is moving, especially this is critical, like a project like airport glazing, where you have a huge steel work, we are supporting the facades where the steel work is going to move. So there's no time for given enough thoughts. And how well we detail sometimes the smallest thing as per the functional requirement from the owner's point of view or architectural point of view, how good these functionals has been captured in drawings. So we don't have to think in a post construction or post tender stage where how many doors, where are these doors? There are some buildings, especially have a large development, the entrance you may have a project like 20 different doors on the entrance because the lobby is huge lobbies. So then a joint line. So the joint line is so important for the contractor because that is what he's pricing for it. If you move the joint, this has a huge impact on the cost. So we can't just take the architectural elevation and pass to the contractor, you resolve it. The joint line has to be dimensioned. So we know the cladding sheet has some limitation, so they can optimize the things which greatly help the contractor to price it better. So some essential information I would say for a decent level of drawings or design which is going for a contractor or pricing it, you should have a modulation. It is a major cost driven. A function, so you should add as much as functional requirements, where to be open, what is the functional requirement of the space from the architect or from the owner's perspective. Materials, so we have a lot of different materials, high, low performance. You have also emerging thing is coming, low carbon material. And then finishes. So you have a finishes ranging from 10 years warranty to 30 years warranties. So the essential information on the elevation as we work closely with the architect is setting out. So most of the time this setting out is not clear when we go for a tender. They typically do one partial section in elevation which is not enough for contractor to price it. So it should be done, at least the whole floor setting out is done. So that panel is dimensions shown, where is the openable, where is the cladding, where is the joint dimension, how the corners were detailed. So for contractor, it's easy to price it. The things which is mostly the engineering, there are a lot of time we do a steel engineering as part of the facades, where the steel structure most of the time is not clearly given to the contractor. So the contractor will always have a surprises of there is a steel they have to use for supporting, which maybe sometimes they don't price for it. So we can always better to show where it is connecting to the structure, how is it interfaced to the structure, not just to showing a glass section and cladding. So a supporting structure, there should be careful attention to be given. The same thing, structural arrangements, we call steel GA in a 3D, so it's better show that in a general arrangement overall, so the contractor can see where is the primary structure, secondary, how is it supporting, there is information is given there. So the more information is better. Even the smallest element is just like a door portal. Sometimes we have a problem with the entrances not detailed properly, whether the something is coming out. The steel is big, so you have to enlarge the portal, so it's not a good design in terms of architecture. Secondary steel structure. So the major technical things which we most of the time we face challenges is the secondary steel structures, where contractor will just see the section and he will assume there is a beam is given, but the beam is quite far. So he need to price all of this in his contract. So same cladding. So we may have a cladding of like is coming from 1 to 2 meters away from the facade, but how is it holding that cladding? Is not just enough just show the outline of the cladding. How is it going back to the structure and supporting system? So all the highlighted elements is a cost elements which contractor has to price it. Sometimes it's just they do a typical section, typical. So this typical only work, maybe sometime you have a project where non-typical as a major element, where the double height, triple height, penthouses on a high-rise residential is not captured. So they're always missing with the steel elements. In the construction stage only they will identify, they will say there's a beam needed, especially the penthouse is sensitive. The architect will not allow to put anything big structures. So we spend too much time on discussing that. Then the interfacing key detail. The details can be high performance, medium performance, or what is really essential is you may put a flashing on both sides, or you can put a flashing on one side. So this all, the detail only can give a better design intent. Otherwise, contractor will just price for one layer of waterproofing. He will not do the inner layer. So the more detail is he can implement is in the as per the design intent. Smallest detail, sometime a coping, all the buildings, most of the building we see there's a problem coming from the coping is not resolved. The detail is just given in a two-dimensional detail. It doesn't take care of concrete, poor concrete quality. Concrete is misaligned, so it's not given thought. So it's better to detail properly in a more practical ways. Construction tolerance. So it's a big issue with the construction tolerances where concrete buildings going for a high-rise, there is something design assumed and what we ended up on the site is different. So the contractor should have given a fair detail about what is a building tolerance. If there is a design is done for this, and finally he may ended up dealing with this kind of a very huge tolerance. So there should be a solution given in the design intent. So when we do the detail, we always give the detail for two scenarios. If this is the tolerance, this detail. If the tolerance is bigger, the detail is different, because then this detail he needs to put a flashing membrane. There are more additional work is involved. So the glass, I'm just switching quickly to the glass. Glass is a big topic where we can talk hours on the glass. Now the modern trend is using different complex glasses coming. You have a jumbo glass, curved glass. That's the latest architectural trend is pushing the glass envelope. We have a laminated glass mostly used, IGUs, fabrication tolerances. special glasses. Fabrication tolerances vary from supplier to supplier. So if you have a A-grade supplier, they can give a much better tolerance. So as I said, the latest trend is everything's going extra large jumbo glass, where there is some limitation. Some glasses, if you have a curved glass on the building, not all the glass can be curved. We have a project where the curved glass issue came only at the later stage. The project got delayed because of the building corners as a curved glass. We may have to change the curved glass. So curved glasses, they may say everything bendable glass, but there are a serious limitation on a curved glass. The glass, sometimes it varies on the supplier. So it is always good to have some basic definition in the tender documents so that the contractor is again priced properly, where 3 supplier can give the glass cost very different. Somebody just reduce the glass thickness and he will increase the PVB. So the various different, there is no inconsistent. So it is good this exercise done at the design stage. We are not doing this at the construction stage or during the pricing stage. The pricing contractor will have maybe just 3-4 weeks time to fill up the price. So it's very difficult for him to understand all this technicality. So just to show some of the projects, what we have done is Pan Pacific in Singapore. We closely work with architect Rohan on this project from design to implementing. So we got a lot of experience on implementation side. It has very well integrated with the roller blinds, where the hotel, they open the door, the roller blinds is coming down. It's a sliding door, and it's a very tight space, about 300 rooms hotel, 5-star hotel, where the rooms integrated with the sliding door on the unitized curtain wall. And it has a lot of mesh and Voha. They do very detailed design and extensive facade. So you can see lots of complexity on the building geometry. So when we are in the design stage, this building is nothing about those balcony details. You have 4 different balconies and very tight space. The things are curving, all the corners are curved. And when you have a curve, you have a detail which is different from the drawings. So we have to deal with the balconies and detail of the junctions. So that's all done at the pre-construction stage. So what we have done is during the pre-construction stage is very well integrated with the, from internal flow finish. They won't have a flush detail, everything integrated. You can see a small tiny, this is actually gutter detail. So what you see in the design, so this is a gutter channel here. So exactly what was design has been achieved. Acoustics. So when we deal with a 5-star hotel, especially the acoustic, room to room acoustics, we need a very high performance acoustics. So these are the detail achieved, like 50 dB STC they have tested for achieving this acoustics. So we have to think about detail during the construction stage. And if you see this acoustic detail there, if this is just one detail is missing, is going to cost huge for the contractor. So that one detail have 2 layers of flashing acoustic sills, so expensive that detail.
Yeah.
So it's done for acoustic. This is a sliding door. With this, it has achieved highest like 50 dB STC has been achieved with that sliding door. So some other projects in Cambodia were active with some projects where this use extensive media facade, where is corner and is main central business district, where they also have done with the 2 huge media screens, about 16-meter LED screen onto the parking level facades. And this facade has a curved band of cladding. So we have done some detail where the contractor is not scared about the panel is too much of non-typical panel. So when something is different for contractor is good. If they see the models in a 3-dimensional, they can understand, they don't overestimate or put contingency on the facades. It's doable. This entrance, about 10-meter height entrance, is only vertical. There is no horizontals. The lighting integration. These days the lightings are so slim. What you see in this fin element, it is just about 15 mm light strips. Another interesting project is nearly completion is Atrium Place in Gurgaon. I didn't manage to get the area. The area is about 150 square meters, very large facade, and it has a 200-meter long atrium. The challenge is in that 150,000 square meter is a huge. So we need to standardize it and fast for installations. There's no special detail is needed. So where we have done extensive level of documentation where the panelization is done, the ATM space is modeled, everything in a 3D. So the contractor can understand a lot of secondary work and steel work is involved on this project, what you can see here. And very challenging area where the atrium is going narrow down is about 11 meter tall atrium is fully integrated with the MEP. You can see also those fans also detailed here. So those is a fans for exhausting. Everything is integrated in terms of primary, secondary firefighting. This is what it completed. There is a lot of focus given on details. What the detail is given here is the same is achieved here. Is 450 mm sill detail. And you can see there are very tight space. The main steel work is done by the main contractors. All the steel work is done by the main contractor. The glazing for the wall and skylight is part of the facade works. This is the last project I will like to show you is use the jumbo glass. So 5.2 meter is a single pane of glass used a project in Ethiopia, nearly finishing it. It's about a whole building, about 20,000 square meters the building, everything is a jumbo glass. Where the detail has been done so the contractor can understand when you have a curtain wall panel, no intermediate mullion, it is just 5.2 meters, the mullion has to be robust in terms of engineering. That's what detailed before it goes for pricing it. There are a lot of exercise done before it goes for pricing. And there are also detailed done. It is not on the same plane. Wherever the cladding has an offset of about 50 millimeter outside, that's what is done like this. So this type of project we do try to help the contractor in terms of engineering, detail, bracket. It is not just throwing some concept to the industry. The skylight, it has some nice skylight where it's used a structural framing where all of these glasses used faceted glass. It's not curved glass. So what you see on the actual built on the right side is using just one unique panel used. Usually this type of geometry you ended up like 1,000 different panel types, but one panel is used. It's not curved, it is segmented. So just a concluding remark is key to efficiency is good design. So it helps a contractor make the contractor life much easier. Procurement, so the client can focus more on timely delivery, not just the costs, beyond the cost. Design validation, where the site phase we just checking the things. There's no design we are doing it actually. Implementing, so the contractor has much more quality time on implementing. Thank you.
Thank you, Rajan. As we all know, every architect knows God is in the details. And Rajan really stressed on the fact that if our detailing is well thought through and we put more time and effort and focus in the design development, there's definitely cost savings, accurate estimates, and less stress on our contractors. We will now head for a 20-minute break where you can take this opportunity to visit the booths and speak with our sponsors and partners. Welcome back, ladies and gentlemen. I hope you had a nice break, a fruitful networking session, and that you have fueled your system with sufficient caffeine, as we have quite a few sessions coming up for the rest of the day. So now let's welcome our next speakers from Dubai, Susanna, Noureddine, and Omar Fakih from WSP.
Hi everyone, it's me again, for those who have seen me earlier this year in Dubai. Very pleased to be in Bengaluru, probably my most favorite Indian city, not just because our office is here and the team is here today, but yeah, me and Omar, who is our construction delivery team lead in the Middle East, are going to show you today a little bit of a horror show, not to scare you, but to give you the importance on how important building envelopes and facades are, for not just for us, for developers, architects, and contractors. So I will give you a little bit of a brief in, also where's the clicker? In who we are. I'll do like the marketing and then he will give you like the bad news. So yeah, WSP, I think a lot of you may know us by now. We are worldwide more than 70,000 engineers leading not just construction, but also bridges. We have advisory services, and part of it where we are from in the Middle East, so we have the biggest engineering team under specialist services where building enclosures, this is how we call ourselves now, and the building access and maintenance is led by myself in the Middle East, and these are like all our different services under specialist. This is the entire facade professionals of WSP all over the world, our headquarters in Canada, and obviously with the region, I always say the Middle East is the playground for architects. We are forming with a team here in Bangalore, with the biggest engineering team serving the wider region. And a little bit to our capabilities and how we are helping serving our clients and the buildings. Obviously, thermal analysis, structural engineering, all of the typical engineering task. With it, lately we have expanded on parametric modeling and a computational design team, which we are very proud of, doing like all the solar studies and optimization when it comes to thermal and wind CFD, concept studies, all of that expertise in our team. And lately, and this is why Omar is today with me, we are talking about like supervision and refurbishment. Good for us. It's in my team, I think, the biggest revenue stream in fixing buildings and instead of like building new ones. And then the facade access and maintenance, equally important. Roofing and terraces, hence building enclosures. So we're looking after the 5th elevation, not just doing facades, so also expanded on that. Block work, where and when are we stopping, what kind of block work are we using, is also handled by the team. And what we are like recently also invested in and we are very proud of is our 3D printing capabilities and the research team we have, where we are, in that case, have developed our little small models and showcasing to the client and also helping a lot of contractors to understand what it actually means when you detail, how high it is in proportion, etc., and doing like our own little studies. And with that as well, our VR experience, especially architects and developers, investors are enjoying that little tool quite heavily. Helps to understand, helps to like really perceive what it means, how big the ballast, how high the balustrade is, what is the surroundings. This is in our client experience room, where we also have the acoustics playing a big role on the VR. It really helped us to get like a couple of decisions pushed through once they understand where it's coming from. The CFD services, what we are doing on a couple of projects at the moment in Abu Dhabi, where we are doing the preliminary. We all know how much time it takes until the wind tunnel test is out. So we are like always a step ahead and trying like to do it in-house. And net zero, as I think like the biggest buzzword lately, kind of replaced sustainability. We started talking about it. It's not there yet, but the discussions have enrolled and developed our tool. And we actually do have a future-ready team. This is what we call, so preparing ourselves and what's coming, and have developed like our tool in calculating the carbon footprint of different facade systems. With that, importing all of this into the BIM and Revit capabilities and the modeling, which is always very well received by our architectural clients. Here a little bit of playing around in what we can do in terms of research and development, helping together with a contractor, building mock-ups and seeing what's possible with different materials and where sitting the limitations of construction methods. And lately, special engineering process in Aswani is our studies we are doing in helping glass suppliers and or owners of yachts to realize their concept. So we went like, instead of just facades on the ground, we went like onto the sea. It's a very niche, but also like a very exciting market we're looking at. So, facade engineering, what it actually is, and why is it so important to us? Why do we have nearly 50 employees to look after? As in, you may already all know that we are spending more than 90% of our time in buildings, indoors, where 20 to 30%, I would say more 30% nowadays, the construction cost of the entire project hangs really on the facade. And if you don't do it right, you probably have to pay more than that. So it's a very big topic. It's important, not just architecturally or design-wise, so also human comfort and resources. This is then where we come into play in looking after the materials. What is the complexity? Where can we adapt to climate conditions, indoor and outdoors? The performance obviously is like a big cost impact, and how can we protect the environment and the humans indoors from environmental conditions. And this is then pretty much what we design for. So whenever we start a project, we're really looking and analyzing where is the building, what are our design parameters and design criteria, and putting all of that onto a building envelope and understanding that what a facade actually has to carry, and what is the importance of that, with all of that impact on a little bit of glass and aluminium, if you want. So we always wonder, how do we win the race, and what can we do to make it a long-lasting, high-performing, comfortable for humans and cost-effective facade, is to see where we are actually building. What is it we are designing for? This is also what Omar is going to go through with you guys. And also, I want to say, one of our biggest challenges with, as I said, the Middle East thing is one of the biggest playground for architects from all over the world. And starting really at by zero in what it means to design a tower in Dubai, and what it means to have like the right materials. Someone from New York, the Central Europe, they probably have never done like something in the Middle East, and the struggle when it goes into operations. This is what it usually looks like. Well, I don't want to say usually, but pretty much all over the year in Dubai, morning, evening, and especially in summertime, we do have like a lot of humidity coming up. You can either use it or make use of it, or protect yourself from it. And this is like the kind of images of where architects usually don't know how to deal with, and that's a little bit of a horror show is what we, unfortunately, well, for our clients, but again, good for us, because it's really the biggest revenue stream in the team at the moment. In failure on construction and all of that is happening really because of air infiltration through the building envelope into the rooms, especially with what has been designed over the past 5 to 7 years. With the speed of construction, a lot of quality has been compromised. And I'll give it to Omar now to explain where and what and what's best not to do. There you go, Omar.
Thank you, Susanna. Hi, everyone. As you saw on the slides, the facades and the building envelope is very important. Protect space, protect people. It also helps on energy efficiency. And of course, it gives your building the look, the good look. What happens if the facade system fails? That's cost. Most of the cases, very big cost. Problems, most of the cases, series of problems. Fix, problem, fix, problem. And unfortunately, sometimes it's dangerous. It's a safety hazard. So There is many types of failures. We'll not be able to put them all in one presentation. However, the failure is not only on glass, not glass system. Majority is glass, and it's a big concern, but it's in every system or material in the facade. GRC, metal, GRG, stone, artificial stone or natural stone, a lot. We'll take you through some of the failure investigation we had. Some of them is like repeated in many projects. Most of you know this IGU, failures of the IGU when the moisture get into the insulated glass panel, and that cause or result on condensation or fogs like this. So if you are an owner of a hotel, you don't want to look like 5 or 6 rooms because the guests complaining they don't have the sea view or the city side view. Other type of failures is the spontaneous breakage due to nickel sulfide inclusions. So most of you heard about it. And this inclusions trapped in the glass during the glass production. So as a consultant, we always encourage, or like not encourage actually, we insist on having 100% heat soak testing for every single glass if it's fully timbered. And that's to eliminate any glass with these inclusions. Like this one story about tower 44 plus, where they start having this spontaneous breakage. Started with 2, 3, 4, and every time it's happened, there's a risk of having falling glass into a metro station or a busy pedestrian area. So the owner had to strip out the whole glass and bring in new glass. Imagine how costly it is. We're having heat soak testing, additional cost to the glass production or processing would save a lot later. Another example here we have like one of the recent projects, we have delamination. Does delamination happen most probably from the processor? Sometimes it's stuff like that. So you receive the panel with some bubbles, but unfortunately, in some cases it's developed. And when it's developed, it's risk, especially if you have inclined glass or even vertical glass. We always recommend to have either mechanical fixing, which may not be visually good to receive, however, safety first. And we end replacing a lot of glass, retaining this glass to the processor. Stone failures. So this is example of failures not as a result of the production or site application, it's the design. So some problems start from the design. Having this detail in a stone, especially natural stone, it's not really a good detail you can see here. And I have another example in a tower where the owner had to replace the whole stone because of this detail. GRC failure, similar to the stone, it could be the design. Not having the right design will cause a failure, structural failure. The panels simply fall off the building in a normal day, not even windy day. This is another example where it's not always design. Someone at site decide to grab one material from the box next to him, made some holes in the GRC and decide to use grout. The engagement of the bolt is less, so you have shorter bolt. A big panel, maybe 300 kg, fold out of a big tower, So again, it's the quality is important at construction. anchor failures. Also, there is 100 types of anchors, chemical, post-fixing, pre-fixing. So this is example only. Cast and channel, we call it a system. We don't call it a material. Because it's not material, it's a system. There is a lot of engineering behind this channel. Engineering by the suppliers, engineering by the consultant, by the contractor. But the application, if the application is wrong, like this photo here, we have a big failure. So we as a consultant always encourage the contractor to call the supplier, ask them to witness, train the people for every project, like project specific, till they maintain that level of trust, Corrosion, it's a big topic also, especially where we came from in the Middle East, many types of corrosion. Bimetallic corrosion for a contractor using stainless steel bracket with aluminium shims with the mild steel or galvanized bolt. And most of you know what is the bimetallic corrosion and how it's affects, especially when you have like a noble material as a bracket and lower grade is the bolts. That's a big risk. Also, we had to change the bolts in one of the projects because they are using less grade than the bracket itself. And by time, the bracket will start eat from the threads of the bolts, and later the bolt will fail. Yeah? One funny story is like one of the contractors in Riyadh, which is very dry environment in the desert, and like Jeddah, had the approval from the consultant to use level of corrosion. That level of corrosion is C3 or C4. And for the aluminum, we use AMA 2604, which is a level of corrosion protection or level of coating. And he decided with other projects in Jeddah, which is a city in the same country, to use the same level of corrosion protection, but doesn't work. There you have a sea, humid air with salts, and it doesn't work like that. So they had the problem, and they had a corrosion which, using the same material, same source, same suppliers, but different environment. So that's another lesson to learn. Molds, where I started, there was a big photo for a hotel, 5-star hotel room with these molds. Sometimes you don't see it, but you inhale it, and it's not good for our health, no? And we pay a lot to stay in a 5-star hotel. We don't want to inhale mold. So in this project, they use proprietary system, tested, known. They did all the performance mock-up, and it passed. But they have this air infiltration. This is another evidence of the poor workmanship at site. Someone applied sealant, went to the lunch. When he came back, he forgot to hear where he stopped. Then he went to another joint. Someone has short gasket, he stretched it, fill it, and then later it shrank. So we have a failure. With all the money spent on the system, tested, it's failed because of the poor workmanship. I'm afraid that I'm running out of the time, so I will go faster. Water leakage could be a design issue. Most of the engineers that say focus on the typical areas where you have normal transom, mullion, or unitized system, but they don't pay attention really. And I'm glad that we have a lot of system suppliers here. They don't pay attention for the accessories. The accessories for 90 degrees is not the accessories for the 30 or 60 degree. As a result of that, windy day, rain, heavy rain, all the water will ingress the system. And of course, the water will not stay. It will go somewhere, so it will go inside. So that's design issue, but sometimes it's not design. It's like the workmanship at site. some installers not really educated or trained by the system suppliers. We saw a lot of cases where people, instead of having a backer road and structural weather sealant, they apply weather sealant, excessive one, they block the internal drainage, no way to discharge the water. We saw some funny stories, where someone saw the whip holes and thought it's a mistake and decided to inject weather sealant everywhere, block the drainage system, and we end with such results. So minimize the risk, and this is my last slide. As a facade consultant, it is our role and responsibility to minimize the risk. No one can eliminate, but we can minimize the risk by early engagement in the design, by having or conducting a peer review for someone design, by ensuring quality assurance, quality check at every stage of production, and also supervise construction for the standard material or the high standard material and good quality. And of course, and lastly, is raise the awareness upon of the, I would say, developer, clients, contractor, architects, and consultants to have the right facade system.
So, just a little outtake of what we deal with every day. And this is, I think the worst case we ever had, other than panels falling off the building. But, one of our biggest job is really to educate, to raise the awareness, and to be the balance in between all involved parties. And I hope you enjoyed the little show. And just on a side note, if you want to see it on real life, you may want to pay attention to the stone wall, which is installed at the security gate down here. Just if you want to. Thank you very much.
Thank you.
Thank you, Susanna and Omar. That was a very insightful presentation on the risks that are very, very much part and parcel of our facade design, and causes of failure are several, from, like you mentioned, from workmanship, lack of proper supervision, not getting time on your specific, detailing and using the right materials. Thank you for that presentation. Next, ladies and gentlemen, please join me in welcoming to the stage Erasmus Eller, who is the principal Eller and Eller Architekten, having traveled across continents from Germany to share his insights with us on the upcoming Siemens Healthineers Innovation Campus.
Good morning. My name is Erasmus Eller. And just listening to Susanna and Omar talking about all the risks, Susanna, we will never stop dreaming as architects and designers. So we are an office based in Germany in the second generation. And today I want to talk about the Siemens Healthineers Global Innovation Campus. But before that, I just want to explain a bit about our office structure. Me and 4 partners are working on big scale projects for big clients in Europe and with those clients throughout the world. And this is the team working on the Siemens project here in Bengaluru. This is our internal team. And of course, we are working with partners. Partners because we are a general planner, so single contract with us and Siemens Healthineers. And we are happy that we have founded those partners, and specifically VA architects here from Bengaluru. Subramania is joining us here. Please stand up, Subramania, because he is the responsible guy from VA Architects running with us through the risky project, let's say. And besides Subramania and VA, of course, we have Design Tree and we have Facade for the facade topics, and Friedemann from Germany. And we are happy that after a long tender process, we found Aluplex as our contract partner. Just to show some samples, we have delivered some icon projects, apartment building in Germany, in Düsseldorf, high-rise buildings for BASF, the big global chemical company, or a legal company, Bayer, you all know those names and brands, and WPP, hospitality, and some very nice museums in Germany, German Historical Museum with IMP, and the Chocolate Museum in Cologne. But today I want to talk about the Siemens Healthineers project. So when we were invited to the competition, beside Gensler architects from New York, GP from Singapore, Henning Larsen from Copenhagen, and some more, we got the brief. And the Siemens board said, we would like to see the campus on the same level like Google or Apple campus in Silicon Valley. We said, wow, it's amazing. Are they really tough enough to fulfill that imagination? And then we said, okay, we go in and we will develop a nice design, and either we will win or we will lose. And then we have chosen a typology which is like a university campus. So we are talking about 175,000 square meters, so very huge. And it's for more than 500,000 people. And just imagine if you put all the square meters on one level, we would have a high-rise building from about 350 meters. But then we said, no, it's all about connectivity. It's all about human-centered design. And then we put around amphitheater in the center part, 8 buildings next to each other. So from the point of the people working inside, it should look like smaller buildings. We even cut the height on half level and implement sky gardens. As you can see, we connect them in between so that the people can easily go on the balconies, on the lodges, on the sky garden, and can relax after they are working. At the beginning, we take into consideration all the guidelines we get usually from clients. The brands, the design guidelines, look and feels, way of working, strategies. And then we put everything together and would like to create a specific answer on those requirements. And then afterwards, we split it into different streams. So it's called in our office, like the shell and core building, the interior, the programming, the way of working, so that we can really concentrate on every stream. At the beginning, we thought, how can we find an answer in that context? When I arrived first time in India, this was 1999. We traveled a lot through India with my wife, and we were so excited about the Indian culture. Really from north to south, from east to west. And then we said, we will not find an answer just for Siemens Healthineers, an international brand. We want to find a solution for the people working here in Bengaluru for that company. And then we said, let's start with the idea of having a lotus flower as a base, and on the top we put the buildings. On the other side, Siemens has a brand element like innovation, technology, long-lasting architecture. And then we said, we have to bring in the natural aspect. And therefore, we put the greenery on every part of the building. Of course, the landscape around the building, on the base, we have underneath of the buildings, and then we have greeneries, balconies around the facades. Then usually you would put the building parallel to the street, but then we analyzed that the sun part is a bit different, and then we shifted the geometry of the building to the south and to the north, just to get a better understanding about the solar energy and some other aspects. So in the morning and in the afternoon, when the sun is on the lower level, we put the smaller facades to the east and south, and the longer to the sun when the sun is on the higher level. And therefore, we could reduce the sun radiation into the building. The human-centric idea means we would like to see floor-to-ceiling glazing. But when we started, we recognized that most buildings here in Bengaluru, due to the close distance to the I forgot the English name. I'm sorry about that. Because of the high energy, most projects have a very high performance glass in front of the building itself. And the mirror effect is that strong that you can't really look inside. You can't see the people working in the building. On the other side, working inside, you can't look outside because the clearness of the glass is not that good. Therefore, we said we want to install the so-called judgers, so the canopies in front of the facade. This was one topic to reduce sun energy, and the other one is we want to put greenery on the canopies, on the cantilevers. And what you see here in the section is the sky garden levels in between, so that the people can really walk outside. On that level, we have all the gym area. We have about 2,000 square meters gym area and work cafe, so that the people can relax. And then we analyzed together with our partners how can we optimize right now the building envelope. Here you see the connectivity. So through all the buildings, we set through atriums from the base, from the ground floor to the penthouse level, and in between on the sky gardens, so that the people easily can work together. It's all about collaboration. It's all about connectivity. And then the biophilic design means to invest a lot of greenery into the building, to merge with the building. Natural ventilation, so that the people, that the project and the envelopes can cool down naturally. We bring in controlled light into the building. And just imagine this is the judgers with the green landscape. And if you put all elements together, the length of all facade elements, it's nearly 12 kilometers. It's huge. At that point, the client, Siemens Healthineers, was a bit worrying about how can we maintain that? How can we react on wind pressure and all the weather conditions, specifically under the aspect of climate change? And then we had to go into details. The renderings, it's not finished, the project is under construction. This is the image, the atmosphere we would like to create. So the people are all working hard, they're working concentrated. But in between, they should get the possibility to step out on the skywalk. They should step out on the lodgers we have on every floor so that they can recover. So this is the main facade from the street. You see all the 8 buildings connected to each other. On the base, we have the labs. So they are really testing all the products they are developing upstairs. The lobby itself, the so-called boulevard, it's 9 meters high. So on the boulevard, who is connecting all buildings, we have a big town hall, we have the work cafes, the experience center, auditorium on 3 levels, we have restaurant areas. And bringing that idea to reality, we need a lot of further steps. This is the restaurant area. Then we try to get with the help of a modularization, how can we bring that in an efficient way through the planning process with our partners. So therefore, we share the process into one package is so-called shell and core, and on the other package is the interior. We all know that after pandemic, the working method is changing, so digitalization is everywhere. So that means that we have to find new ways of working. And therefore we said we need more time to get the real understanding or clear understanding how the interior should work and look like. Talking about the envelope, we have here shown the regular linear facade elements. On the bottom you see the base with a 9-meter high podium level. And then we had to deliver and develop a regular system just to get a better structure into the process. At that time, we were supported by Facade Engineering, a local-based, very experienced partner who helped us beside Friedemann. And then we developed all the regular systems. Here you see that we have the lodgers, so it's not just a linear facade. So we have the round, the curved ones at the corners and the curved ones to the lodgers. The lobby itself, the podium with the 9 to 11 meter height boulevard, where we have to find not just the construction but the suppliers as well. And at the end, we had jumbo glazing elements, which was not easy to find, and today they are coming from China. So coming back to the regular office levels, you see the judges and the fin in between, and you see just from the yellow color list, how can we protect the energy on the one hand, and how can we optimize that the people can look outside and they can even see then the greenery in front of the facade. This was quite complicated, and we had to test a lot, and this was requirements by Siemens saying, we like it, we want to invest it, but we want to see it in a mock-up, build first, and we have to test it. This is then with the mock-up, we tested all those different sun protection, the glass elements from Pilkington, Saint-Gobain, and coming out from China. And this is just the shop drawing by Alufit, and you see how complicated it is. Specifically with the water, and we don't want to see the results Susanna and Omar showed, that we have the problems afterwards. The same on the lower levels, and the fin is put on the mullins. Just went through. This was quite complicated, Supermania, and we were happy that we had partners to fulfill those promises to Siemens. And then we started with the mock-up. Before tendering even, we contracted Alufit at the beginning for tender process, and we developed the mock-up. On the mock-up, we tested all color questions, because when we won the competition and we won it with the reddish, for me, typical Indian color, after we won the competition, Siemens came to us saying, yeah, it's nice, Erasmus, but you see, we are an international company. We cannot give to every country a specific color. We would like to see it in either silver or whitish color. And then we said, no way. In this fight, you really half a year. At the end, they were convinced. Today, they are completely happy. When they see the result, they said, this is our commitment to India. This is our commitment to Indian culture, to Indian society. And all the people working on the project say, this is so typical Indian. So this is our commitment. And then, of course, mock-up test, performance test, this was very important because we could make some improvements on every detail. Then the early module installation. This was the first aha, wow effect when the client was standing in front saying, okay, that's it. And you see even on the model itself, we have 4 elements, 2 on the left, 2 on the right-hand side. This is even the specific balancing of finding the right color. The testing with all the water improvements, and then step-by-step glass installation. And this is just the smaller part. This is the factory itself. It's just, let's say, from the gross area 5%. But this is the first part we can and will realize. You see all the cladding is installed, the glazing, the fence, the corners. And this is really looking very nice. And you see on the right-hand side the clearness of the glass elements themselves. This is so important that you can really look inside and from inside looking outside. So this is the first phase. Will be finished within the next 3 months. And this is the rest of the construction site from different views. And we are still working hard to get the good result, Subramania. And besides talking about risk, it's all talking about imagination, and it's all about designing the future. And this is my giveaways. At the end, we have to convince people coming back to office. We all know balancing between working in the office or home office. It should not be a question about the contract. It should be to inspire people. So the company, the brand Siemens Healthiness has to inspire people that there might be a better solution working together on site. And the architecture is part of the brand itself. Thank you.
Thank you, Erasmus. That was very enlightening. I suppose as designers, we always try to keep our best design principles to ensure our buildings succeed. So the focus in the campus was on greening, using the concept of the lotus, and some of our traditional shading details like the chhajas in a model context with the facade. Thank you. Next, we move to welcome Harsharaj Shetty from Shubho.
Hello everyone, good day. So I'm here to present a very important topic, which is going to be ever-growing topic as we move on with our construction industry, which is how to handle the sustainability topic in facades. So we all are pretty much aware buildings are responsible for up to 50% of our energy and material consumptions worldwide, of which facades can be responsible for up to 20%. Like they add the embodied carbons into the buildings, because from the extraction of aluminium and the carbon is already added. And facades being a major envelope of all the buildings can add up to 20% of the embodied carbons in our buildings. So to explain more on how this is being considered, there is a case study where if there is a facade which component panel of 317 kg carbon dioxide that is there, the aluminium profiles themselves alone add up to 37% of the embodied carbon into the facade panel, rest aside all the other components. So how does Shuko as a system supplier, as a profile supplier, how do we take care of this embodied carbon and the amount of carbon emissions that we are adding into the facade? So Shuko takes a very direct approach with the cradle-to-cradle understanding of the entire whole carbon emissions in buildings, where it considers from the initial stage of extraction, fabrication of the product, construction can be the installation, and also on how the operation of the building has to be done, as well as towards the end life cycle of the building towards demolition, and as well as recycling or reusing the materials that has been taken out of the demolition. So Shuko is always through cradle-to-cradle approach. So in that aspect, how is, as a design, in aspects of design, in aspects of engineering, how are we considering to invest ourselves in developing a better offering to the buildings? So as shown here, the majority of the involvement where we are from the stages of A1 to A5, where there is a lot of materials, design, and transportation and construction apart, that is going to add into the entire cradle-to-cradle cycle. So this being, it has been gaining importance year on year, and there is a lot of requirement in involving a lot of engineering, looking into how the materials can be low carbon, how it can be redesigned for better optimized solutions. So this is where today I will be having most of my discussion on how we can make it better, make this part better, so that the rest of the things, which already Shuko is also involved in providing better lifetime surveys, providing BIPVs, which makes building operations better, and also we are into recycled aluminium. We have a full set of recycled aluminium solutions. But today I'll be talking more on how we are looking into the design. And to start off with that, first I'd like to explain on how we are taking this carbon control into our daily activity, into how Shuko does business globally. So what is Shuko Carbon Control? Shuko Carbon Control is a comprehensive modular framework with a complete intention to reduce carbon emissions throughout the entire life cycle of a building envelope. And also it is designed, or it is modeled in such a way that it is always ready to adapt to the ever-changing situations towards emissions and towards the environmental regulations that will be coming henceforth. Right? And to explain better on what actually carbon control is comprised of and what are the aspects, it is made up of 4 different areas. First would be the design to decarb, where we are enabling our customers at a very early stage in the construction of the building itself. We are putting we are laying the right foundations into the design of the envelope, into understanding what has to be planned, what is the material that has to be selected, how can we make it better. So that is where the design to decarb comes. Then there is build to decarb, where we are enabling our customers to have a lower carbon footprint. We are having a lower carbon footprint in building the construction of the buildings and to comply with the regulations. Then there is operate to decarb, where we are enabling customers with our own solutions of integrated photovoltaics, and then where we can reduce the overall operative carbon that comes from running the building, and that is how we are also providing solutions for this. And then, as I already mentioned, there is recycle to decarb, where we have a comprehensive system of once the building has been demolished after its life cycle, we enable them in recycling it, separating out aluminium, separating out all the plastics, all the EPDMs, recycle it in a right way so that it can be in a better reusable format. So this is majorly about just a quick view of how carbon control is looked into. So as I said, since the main aspect what I will be presenting here is on how design to decarb and what are the key aspects that we consider that is very related to what we do in our country as well, right? So in design to decarb, there are 3 parameters which are, first is the U value, which is basically how we can have the thermal efficiency of the building, or you can improve the thermal efficiency through our facade. Then there is air tightness, which acts a very important aspect in reducing the overall thermal load, improving the better ventilation in the through the building. And then the final one would be the material consumption, which is to have a very optimal solution, have a very, it's not just reducing material to reduce the cost, it's more about how we can optimize the design and provide the best solution, also meeting the performance parameters. So to explain more on the individual points, there are, I'll take 3 project examples. So this is one of the projects that we have done in Ahmedabad, which is Adani Energy House, where there was a U value requirement for about 1.9 watt per meter square Kelvin, which is usually the best in class of requirement for our country. So what was the intent? The intent was to have a reduced carbon footprint, because then when you reduce the when you improve the thermal efficiency, there is lesser heat loss, and there is the internal heating is controlled. You have better HVAC performance, which can be a result of having this. So how does Shuko address the requirement? So yes, we are doing insulated, we are doing non-insulated systems. So what Shuko offers is there are more than 5 options of unitized facade, where we can achieve the required value with better geometry. Like when you say geometry, we try to reduce the overall metal that is exposed to the heat, thereby reducing the thermal transfer that happens through the metal. And this is achieved also along with the use of ABS edge guards, better insulated bars within the system, and we are also able to achieve up to systems that are 1.2 watt per meter Kelvin also. So as an industry, we also need to push for better U values, because going by the way the climate keeps on changing, it will not be far that we will also be in a requirement where European countries are also looking for higher U value, higher performance of systems. So this is something that has to be put into the industry, so that all the buildings can move towards a better green approach. And along with to strengthen what have been just told, we also do this through a lot of software tools and analysis that we run. So this, whatever U value calculations that we are doing and whatever we put into the project, goes through a lot of analysis simulations, which can be applicable for most type of the geometry. It can be complex, it can be simple, but we do have our own internal checks that has to be done before we send it out, which is a very important aspect in this. So moving on to the second point, that is on how we can reduce the heat load in a building through better air tightness. So this is one more project in Noida, which is Fairfox, where the air tightness was around less than 3 meters, which is best in class requirement. So this, as I said, it reduces a lot of operational carbon, it reduces cooling demands, and also the better ventilation as and when it is required. So how do we approach this? Again, it's the same geometry plus material combination, because that's where the design aspect can actually be put in. So there are we have multi-barrier systems which can make the facade very efficient in air tightness, along with gasket and foam-based options. So we have been testing our systems for multiple projects, and there are possibilities where we can also achieve classes of up to class 4 where the requirement is 3 at 600 Pascal. Usually the requirement can be much lesser in our industry, but this is something that has to be looked upon, which can actually elevate the industry standards to higher air tightness, thereby creating a better sustainable solution. So this is just to understanding of how even with corner systems, even with corner millions, even with fins, even with projections, how we can still be able to achieve because of our multiple barrier systems that we have. So most of our systems go through a rigorous testing also, and we have been able to achieve the required air tightness as well. So the third point, and I think this might be the biggest, like the larger portion of what I am presenting today, is the material consumption. The material consumption usually the thing is reducing the material can help us get the project that's like you're reducing the aluminum, but that's not it. So optimizing the solution reduces the overall embodied carbon right from the design stage, as I explained earlier. And it can reduce the overall weight on the structure. It is better in. At the same time, we also make sure we are meeting the structural requirements, not that we are reducing material for the sake of it. So this particular project, there was a requirement of 1.8 kPa, and we were able to achieve it with a 25% reduction in the overall material. So how Shuko does this is we have a lot of we have a software where we can do a complete profile optimization, which gives you the best output, which I will just show the video in the next few slides. And applying the right standards, understanding the right design philosophy, reducing material wherever possible through right design aspects. This is how we are able to do it in able to optimize the material through the right manner. So how, as I said, we also have a range of modular systems which we have already been designing for a lot of projects, and this enables us to give the right solution for the right performance requirement. So it allows for more customization by not increasing the price also. So this is just a video of the software, how the overall profile is studied initially. So this is how it understands the nodes, and then this optimizes it. So it basically runs through a lot of iterations from combinations where it gives you the right design of the entire geometry of the profile, and thereby showing how much you're actually saving and how much you're increasing the overall strength of the profile. So this is one of the ways of how we are looking at optimizing materials. And moving on from this, there is a new topic which is pretty new into this material optimization, which is something called Shuko minimal wall. Now, this is something that we all know that we are at something around 30,000 kilotons is what aluminium is being used. That is the need of aluminium in the global industry. And in India, we are using up to 13% of aluminium in the construction industry. Of what 13% is what the share of the aluminium is in construction industry. And there is a 5 to 10% year-on-year increase in consumption of aluminium in our industry. So what this means is recycling is not enough. We have to also look into how we can further control the use of aluminium and still be able to do projects, still be able to make buildings that are going to live long and be a legacy. So what Shuko minimal wall has come up is, it is a innovative structural glazing concept where more than recycling, material optimization is being used, and it has been it is a highly engineered, tested system where the glass and the profile is being considered as a single unit to take structural load to a collaborative plan with one of the adhesive suppliers. So what it provides is, since the profile and the glass is considered as a single entity, the overall aluminium requirement in the profile can be reduced by up to 36%, and the overall facade can be optimized by up to 40% of a conventional unitized facade. So what the advantage of this reducing the overall facade depth to up to say 40%, what does it give you is it gives you reduced material over a conventional unitized facade, and it can give you a very minimal facade depth, thereby increasing your floor space area. At the same time, we are still meeting the structural requirement, we are still meeting the performance requirements of what is being expected from this particular solution. So this along with what Shuko is offering with its low carbon, ultra low carbon, can be a cornerstone in reducing the overall requirement of alu in the facade in a facade panel. So what it's been explained here is with the Shuko components, it can be profiles, gaskets, and components, we can straight away have a benchmark reduction of up to 70% compared to a conventional curtain wall when you are using it along with the ultra low carbon aluminum and Shuko minimal wall concept. And with the overall facade, there is a possible reduction of up to 35% when you are using it with ultra low carbon aluminum. Thereby, you are creating a lot of possibility to reduce the overall embodied carbon in the system. So this was pretty much my presentation for today. So the end of the presentation is #LiveItBetter. Thank you.
Thank you for your presentation, Harsharaj. Ladies and gentlemen, coming up next is another keynote speaker representing international expertise from Poland. Let's give a round of applause to welcome Marek Tryzybowicz from MTDI Group. He'll be presenting his perspective on international design today and in the near tomorrow.
Thank you very much. Good afternoon, everybody. I feel honored to be here. I'm no stranger to Bengaluru. I've been here many times. I enjoy the city, enjoy the energy, enjoy the future forward thinking in the current developments. So I just want to share some examples, some thoughts of what we are doing, not only in India, but also in the other parts of the world. My group, MTDI Group, is a group of international architects, designers, landscape architects, Europeans, Americans, but most importantly, Indian and also architects in the Middle East. So there are obviously many interesting projects going on. But I would try to lead this whole presentation, which I really thought about this today, into a little bit different track. We can obviously share the examples, we can share the experience, but that's really the experience of the past. We as professionals in the construction, design, has to really rethink how we approach our professional contribution to the societies, to the not saying so lovely to the planet, but to the well-being of us all and our children. So maybe let's start with the presentation. Here we have some interesting projects which we are involved in, mostly in Bengaluru. And that's all India, that's all Bengaluru, that's all the projects which are currently going on. Some of them are built already. And it's, I would say it's a lot of experimentation implemented. It's a lot of interesting programmatic aspects involved in the design, but there's one very important thing. We don't focus on the building itself. We slowly move into the notion of the environment rather than a building, rather than a garden, rather than a campus, rather than the. I think we really have to start to blend the different spaces which we so neatly and functionally separated in the past as the indoor spaces, outdoor spaces, as the, okay, this is my building, this is my beautiful garden, and so on. I think this all will have to start to merge. And the environment, what we should really look at is to how to make the well-being of humans more addressed not only from an indoor environment standpoint, but also what we do with the land, and with the land very broadly defined. Why this is so important? Because if we don't think about it, if we don't do it, if we don't really consider how our outdoor environment works, we will lose it. We will lose it because the detrimental climate implications are starting to affect us all sooner or later in every part of the world. And the quality of the public space very much will depend on us. Otherwise, it will be lost for use, it will be lost for activities, it will push us more and more into the indoor environment, where at the best we will be able to look at it closely from sheltered environments into manicured pieces, which we will have in front of our indoor spaces. So I think it's very important that we should start to think what is that blend of the outdoor and the indoor could look like. What do we do with the outdoor spaces? How do we mitigate the harsh climate conditions for the indoor things? I was quite impressed with what was shown in the first session presentation, and also in the Erasmus presentation, the way how the blend of the and really a strong push towards blending the outdoor indoor, making that environment a one, mitigated obviously technically and from engineering standpoint. I think this is a very good way to look at. I think we have a fantastic opportunity to look at the outdoor spaces around the buildings, to shelter them, to really make them comfortable, to make them mitigated temporarily during a day, during a season, and that's a huge opportunity. The second aspect, which I believe is a real one, is also when we talk about the green aspect, and we obviously have a very nice, elegant vocabulary, professional vocabulary of sustainability, of the green, there are a lot of words which define that very well, but we should not lose the very elementary aspect of it, what that green really means. And I think as we moving along the development process over I don't want to call how long periods of times historically, I think you agree that to a big extent we damage that green, that we reduce its value, we reduce its equilibrium, what was initially with the living and sheltered and living environment for people. So maybe we should add to that green aspect how we can actually recreate the greenery, how we can make it more balanced with the built environment, how we can bring it in as an equal partner for the environment that we are creating for people. I don't think it's enough to focus on the buildings per se. I don't think it's enough to focus on shelters, because these buildings are shelters for various activities, for work, for living, for residential, for name it, public functions. So how we can blend it? So as we are moving along in this process, we obviously look at many ways to address very practical aspects of today's commercial needs for the buildings, introducing this green aspects and the very good questions. Well, how to maintain it, how to sustain it, how to really the cost factor and all that. Obviously, it's a very typical question which comes in. But the fact is that our well-being, if you are really serious about it, for living environment, for work environment, for generally where we function, should to big extent depend on this equilibrium with the greenery. So in our vocabulary, that should be also a very strong professional task for us all, is to how to, in a practical sense, recreate the ecosystems, how to bring it into the environments, how to blend it, once again, blend it with the built structures. And all the fantastic achievements what we have available, and it's only made them happen in terms of the building technologies, into the engineering technologies, are an incredible asset and value. So if we could also think about it, how we can bring the green aspect into the green essence, which I described, into the solutions what we provide to the living environments, I think we will win. And that, once again, the recreation of the green, to bring it as an integral, sort of equal partner into the building technologies, may benefit us all. Obviously, I'm not today to put a long list of good reasons why we should do it. I think we are all aware of that. No matter where we end up with the results of the climate changes, it's our obligation to respond to it, the conditions where they are, what they are, and that's, I think, the one of the thoughts which I wanted to share with you. Just want to go now. The one interesting aspect which we are involved with is really more and more looking into the mixing functions in real terms. We know that from a development standpoint it's not easy, that the objectives of any development enterprises are sometimes very defined to one asset, two assets, that's it. But from a quality of the environments, that mixing the environments is obviously quite important. And I wouldn't also be afraid of to look a little bit more to the future. Today's technologies are quite advanced. Building technologies, construction technologies. So we have technology means to move forward with forms, with shapes, with prefabrication, with a lot of things which was not very feasible a couple of decades ago. And that can also help us to look at the things which were not within our reach in the past. From a technology standpoint, merging this with some energy aspects, with greenery, all these things could take a much more fluid shape, not only physically as the forms, but also metaphorically. That one of the very interesting potential which we are looking at as we go in this fascinating journey through the design over the decades is how to merge the life essentials in our technologies. And the life essentials are something which we are all very familiar with, which is water, how to get the water, desalinations techniques, how to really have a sustainable supply of water, energy and energy storage, food production, including the hydroponic food. All these things, imagine, I'll show you a short movie a second, are a very untapped opportunity for us all. We look at the buildings very much in isolation from the source of all these life essentials. We obviously consider where to get the energy from, where the water supply will be done. We try to get the energy as green as possible, but in fact, we should think it a little bit differently. Let me just get to this. My name is Marek Tryzybowicz. I'm an architect and I have over 35 years of it. Sorry for that. Just get the video going. Have over 35 years of experience. I was privileged to work on international projects throughout the world. I have a fantastic team of people who I work with for many years. We are very comfortable designing, doing things all over the world, large projects, all was great. But not anymore. We have to change the equation. We have to change our attitude. We have to really react to the real threats of the climate implications to our lives. This is our first priority. We have to come out of the comfort zone. There's no other way. And we cannot repeat the things what we've done in the past. We have to look for the solutions which are completely new. Don't you think that we have to do something about it, short of just saying that we have to stop the carbonization and so on? No, we have to really start to think how to offer a solution for life in a post-comfort time. Within that, there is a certain area of a physical protection of our lives, which today we call it a city, a village, a house. All this will have to have a completely different meaning in the light of this climate disastrous implications.
For the first time, life essentials, we call it the existential essentials, are going to be considered parametrically and in an integrated fashion. Life essentials such as water, food, hydroponic food, waste management, man-made and natural landscapes are going to be considered in an integrated fashion to provide the basis for people to exist safely in an otherwise degraded environment.
We have to secure the essentials. They all have to be together. We call it integrated living environment model. And then once they are all organized parametrically, we can start to think how to organize the human life around it, because we are assured that the essentials are secure. That's the key. Then the shapes of the actual physical environment will be projected as a result of that integration of the essentials. Once we do it, then we can organize the life around it in the areas which are completely degraded today and hopefully stop the massive migration of people who are seeking normal life. Our solution, proposed solution of integrated living environment model, you can compare to the metaphor of an ark. An ark for the very uncertain life we are going to face in a context of very harsh negative consequences of climate change. So, obviously, the main topic for us is the building, is the facade, is how we can protect our living environments. But I think a paradigm of what we consider as living environments, what we consider environments for our comfort, is going to change. And it will depend very much on these key life essential factors. Maybe within our reach, engineering, architectural designers' reach, is the thinking of these integrated life essentials, like a brain and the heart of everything what we do. And once this is secured, once this is organized, once this is parametrically balanced, we can think what this physical surroundings for living could be. So instead of pushing these issues on a side and say, well, okay, we'll buy energy in another place for a cheaper rate, that energy is going to be green. Yes, there will be a pipe to get us water from there. Yes, there will be an electrical line which will run zillions of kilometers to get us energy in. We can think how we can start to isolate these life essentials locally. And then our environments should be in balance with what we can secure. And that's much more feasible, that's much more sustainable, that's much more attractive for the future than relying on the external sources, which, as we know, are going to be finite soon. So this is a thought. This is a thought for us, for engineers, for architects, for creative professionals, technical professionals, that these issues are going to be critical, and that they will impact the way how our buildings will look like. They will impact the geometries, they will impact the physical organization, and especially if you consider that offers an opportunity to bring back another life essentials, which is the recreated ecosystems, recreated greenery in a real literal sense. We believe that these living environments could be much more complete, much more holistically considered, and much more responsive to the real challenges of our time. Thank you very much.
Thank you, Marek. That was a very future-forward perspective in asking us to bring our attention to build with available local resources to be sensitive to the climate and limited natural resources available to us. We will now proceed to have lunch. Please do visit the sponsor booths. This is a great opportunity to obtain information from all the companies directly. Hi everyone, refreshed, ready to go? I hope everyone's feeling recharged after the break. So let's dive right back in and greet our next speakers. Please join me in welcoming Vikram and Harpreet from Architecture Dialogue.
Good afternoon. Should we wait for 2 minutes for everyone to come in? Or start? Okay. First of all, I'd like to thank Zak Façades for having us here to present at this platform. Let me give a brief introduction about Architecture Dialogue. We call ourselves Architecture Dialogue because we believe that design is an outcome of a dialogue between our stakeholders and a dialogue with the constantly changing context. We are an office of more than 40 architects spanning across 2 locations, Hyderabad and Bangalore. Today, we're not going to dwell into details of the facade. Our presentation rather going to be more of an imagery of our projects. So I will ask Harpreet to start the presentation.
Thank you, Vikram. And a quick thanks to Zak Façades for having us here. It's truly an honor to share the stage with such eminent speakers that are here today. Also, to just give a brief of how we're presenting, we'll be moving back and forth in the presentation, and because we only have 20 minutes and 10 minutes each, I'll be flipping through the slides very quickly. So the topic of our presentation is Inside Out, and you'll just see how it's an exploration of the boundaries that exist between what is outside and what is inside. This is the first project. It's a project for Loris Labs regional office in Visakhapatnam, or actually the outskirts of Visakhapatnam, set in an absolutely stunning context with hills on all sides and a lot of industrial buildings. What is interesting about the project is that we got this project from the client when the frame structure was already constructed and in place. This came during 2020. Considering the times we were in and the unpredictability of that year, we decided to keep the frame structure and very carefully introduce the functions within it. So it's an interesting project because it's limited by the existing conditions that we had at that time. But what we did was we fit the program very carefully internally. And what we tried to explore was the facade or the building envelope as a window. Each aspect of the region, from the outstanding views of the hills to the high industrial base, is open to the office. And equally, the outside gets to see the operations of what is happening internally as well. So as you can see, this is a very deliberate intent to have picture windows. Use of elements and cladding, etc. has been completely reduced because artwork is not required. You can just look out of the window. This is the view of the office with the hills beyond, the common spaces, the office spaces. And this is what happens in the evening. You start seeing the inner workings of the office, and you get an architecture that sits very humbly within the context, with sandstone cladding that ages very gracefully and creates a very humble and honest architecture, and that is what the client wanted from us.
So that was a project we saw where the architecture and the interiors kind of reflected back on each other, and where we did both architecture and interior. Now this project is called Ilan by Meenakshi, and this is in Hyderabad. So this project is located in the context of a high-rise building in Hyderabad, which are mostly residential building, and they are, I would say, more repetitive facades where you just have this small balconies projecting everywhere. And when we got this project, we wanted to make sure that we create this building very unique and which stands out in the context. Now this building has 3 towers of 45 story, and each tower got 2 apartments. Now when it comes to the facade design, obviously we looked at a very clean mass rather than having this projected balcony. We looked at a recessed balconies which ran sometimes almost 12 to 14 feet in these areas. The second thing what we did is this: we created a double-height balconies spaces within that, which allowed us to have a landscape growing into the facade. And the third thing what we look at, carefully placed glass and the solid based on the function inside. So if you look at this, where we have done the interiors as well for the project, this is the inside the building, and this is the deck space which is outside. So when it comes to the high-rise building, this kind of a large deck space really help in creating the transition between inside to outside when you don't have a connection to the ground. And these elements, what I talked about earlier, created a very interesting facade as it moves up 45 floors. We have this deep recessed balconies with the staggering double-height spaces, with solids and the glass elements moving through and through up to all 45 floors. Create a very interesting pattern on the facade. What you see on the left-hand side is in the clubhouse for the project, where a similar strategy on the clubhouse as well, but where the solid spaces came, we looked at a very interesting aluminum cladding, which create a very playful facade for the clubhouse. And this is how you see where the clubhouse is seen from outside, we got a playful element of the clubhouse and a very strong elements of the building, which is more of a vertical. And this is the project when you're going to see at night, and we included some bit of LED lights on the solid surfaces, which again makes the building strikingly interesting when you look at it at night.
This is a project in Chennai. It's called Arcus. It's a residential, it's an apartment. Here we've explored the facade as a narrative. We've introduced the use of an arch, a catenary arch, as an abstract form to symbolically represent the narrative of the prominent historic buildings in the area. Here you can see the view that our neighbors enjoy. The catenary arch is used as a contemporary interpretation of the historical narrative. And what is interesting is that in the building elevation itself, you see all the public functions. And these public functions are where the arches are shown. The building falls inside, outside, juxtaposes, has shadows, and it does that to allow for these trees with large canopies to expand into the building. This is a view of the lobby from inside, public function with an arch and a glazing looking towards the outside and creating that transparency. This is another view and shows the materiality that we've used, the use of brick, textured paint, metal, all of that creates a very homely appearance. So the building just completely merges within the landscape.
This project is called Spectra Reserve, and this project is on Palace Cross Road, Bengaluru. The property enjoys a great views of the reserve forest of the palace ground on the other side of the road, and being located in a very context of a very high-end housing complex around this, we had to look at something which reflect the luxury. So we looked at the facade element as more of a continuous balcony which were running around the whole building, and those balconies became the deck spaces which enjoyed the views of the reserve forest, and also became the buffer for the sound created by the road on the which was there in front of the site. Now the whole facade was getting a little bit more monotonous and boring of running those balconies all along. We look at connecting a diagonal connection across the whole facade, which became a double-eyed green spaces, and this green spaces became the reflection of the reserve forest which is there on the other side. And post our presentation to the client decided to name the project as Spectra Reserve because of the concept we came here. And these green spaces are not just contributing to the visual experience from the outside, this is also an experience for people staying inside, and these are an extension of the living spaces of the building. So you see, this is a view from the road. We got this kind of a very clean materiality. We looked at wooden cladding, we looked at the aluminium, and we looked at glass. But the beauty of this is not about the material, but the way three materials are coming together with a very fine finished detailing. And also the introduction of the stone wall, which is also running in the double-eyed space. And you see some of the views from the road. And this is where you see the double-eyed spaces kind of connected, and then we use the stone cladding which connects all that spaces together. And this is when you look from top down, also another view which you enjoy of the building.
This is another building that we've done in Bangalore. It explores the idea of using the facade as an experience, in this case, an emotional and a functional narrative. This is the Nirbhaya Center, adjacent to the Police Commissioner's office. It's a very bespoke project that has been done by Police Housing that has the command and control center, CCTV monitoring, dial 100, and safe temporary accommodation. This design is an attempt to convert the intangible value of safe design for women into a building design. As you can see, it's a very grounded design that almost feels like a house and is easy and open and approachable. What we've done here towards the northern side is create a transparent program where public spaces are there. So the cafeteria, offices, etc. open onto the road, creating a very safe space so that you can see what is happening outside. Maximum glazing has been considered on this side, considering it was the north. On the west and the south, we've been consciously restrained, and we have more of a solid look and feel. This is the central atrium, which makes navigation to all the functions easy. And again, all eyes are there on the public space, so you never feel disconnected from any function. This is looking to the building to the outside, and also the building view as you approach it from the gate. The connection has been kept very permeable so that you find it easy to go inside and it doesn't look intimidating. Just the last note to say that we are happy that we were able to create this within the limitations that we had of a government project and limited budgets.
This is a school building. It's more of a campus rather than a facade design. And this is called Bengaluru School, and this is located in Samshabad, Hyderabad. And this is done for the Akshay Patra Foundation, which belongs to ISKCON. And here we have looked at a whole design revolving around a central courtyard space, which you see in the diagram. And the central courtyard space becomes the hub of the social activities. You know, you see kids and the students coming out during the breaks time and enjoying that space. They're running around, they're playing, having fun. It's become a heart of the whole. This has become the heart of the whole school. When it comes to facade, on the external side, being located in Hyderabad, being in a very high temperature in summers, and also this is going to be a non-air conditioned building, we looked at very restricted windows on the outside, which was required to bring the natural light inside the classroom, so we don't have to depend on the artificial light. But the walls were made very solid, and these walls really helped us in reducing the heat gain inside the school classrooms. The similar facade was running into your courtyard as well, but here, rather than making it brick, we made it more colorful so that it's become a little bit softer towards the courtyard. And you can see this courtyard has this rising steps connecting from ground to first floor, which is almost kind of dissolving your facade of the ground floor area. And you look at the facade, it's very active and it's vibrant, not just because of the color of the building, also because of the kids playing around in the courtyard. So we introduced the elements of arches, which has also helped in scaling the spaces to the kids and also made the whole spaces a little bit playful around in the campus.
This is a resort project in Pumala, which is close proximity to Thrissur, Kerala. So here we are exploring the idea of facade as an experience. And this is not facade really, this is anti-facade. Where we're truly blurring the boundaries of what is outside and what is inside. So here you see the common space that is looking towards the rubber plantation. Just to give the idea of the site, that is the Pumala Dam that you see. And it's a sloping rubber plantation. We were very careful to build very lightly, tread very lightly because it's a sustainable construction. No cut and fill has been done. Functions have been done without glazing, without air conditioning where possible. Here you can appreciate how the building sits on the ground, very minimal connection to the ground, no disturbance. Very few trees were cut in the process. And the experience of the inside-outside is truly blurred. Because here, this is what we wanted to create, an experience of being just in the green, just in the outdoors, and connected to nature and the water beyond.
This is a multi-talented office building in Hyderabad, again high-tech city in Hyderabad for a developer called Hetero. And basically the whole building mass was quite big over here because the whole thing is like a 2 million square feet of area. So we looked at breaking into three components. The lower component is basically the retail hub, which we call as public hub. And the retail hub has a very distinct facade compared to the two blocks which are sitting on top, which are twin towers. And what we did here, interestingly, was that even the facades of the twin towers, rather than keeping its plain glass facades, we introduced vertical fins, which were equivalent to the size of the glass fins, and also looked at double-height spaces, which became a volume like urban voids in the building. Now look at this is the ground level space. This is the retail space which I'm talking about, lower 4 floors. The whole facade is very transparent at the lower level because it kind of connects with the courtyard space we have created and also connect with the extended green space of the site. So you see there's a little bit of difference between what it perceived in the ground to 5 floors and what is above the 5 floors. And in terms of the facade of the, this is again another image of the courtyard, how the retail is connecting to the courtyard. And in terms of the twin towers, we looked about creating these double-height spaces which could break the whole facade. And so this is how it looks from the street, very far from the building. So we got these vertical elements in the facade. Now these vertical elements are not vertical fins. Each of them are like 1.2 meter solid, wide kind of cladding material, which actually reduces the total glass surface on the building and helps in the heat reduction. And the second thing what we really done here interesting is those double-height spaces, which becomes the green spaces and the social spaces of the building, also get utilized as a fire refuge areas. And this is some of other views of the project from the main road. So idea was to, because in Hyderabad we see a lot of this glass building, just clad with glass, maybe very intelligent, smart facade, but we felt they were lacking in characters. So how to bring in a character to the building was very important, along with the technology of facade, which we are going to use. There is no compromise on that. But how do you architecturally make the building interesting was important for us.
This is a project very close to our heart. Here we are exploring skin to system, evolution of facade as a performative element. This project is in Kashmir. It's a silk factory and it's an industrial heritage site with about 28 buildings that are being reused for new use. What is interesting about this project is that the inventory of buildings that we have are very large scale that are converted into new use, but these are all non-inhabited spaces. So they have been converted for habitable use. So as you can see, this is one of the buildings, 100 meter long by 14 meter wide, but it was never designed for human use. As you can see the section, it has a lot of timber structure internally, and it's used for cocoon storage. There was a challenge to convert it for a new use, and what we did was we used the skin, or we introduced a glazing system, double glazing system, and a new roofing system with insulation to improve the performance of the building and to be able to convert it for air conditioning load, for heating load, and allow for new uses like markets and studios, galleries, etc. to be run from this space. This is a villager's building where the silk production actually took place. So the cocoons were changed into silk threads in this building. Again, a similar approach where we changed the roofing system. The glazing was opened up completely and a double glazing system was introduced. This is how it's on the inside. It's completely full of the machinery. This is the conversion. As you can see, the changes that have made the building usable don't really impact the aesthetics of it. It still looks how it looks now. This is the view of the plaza space between the historic buildings. This is a new introduction, a contemporary introduction that we did in the same site. It's an auditorium block. What is interesting here is we use the traditional Daji Diwali system or the vernacular style of architecture, and it uses the timber that is found inside the godown buildings. So the timber is reused for a new purpose here. You can see the view of the inside and you can see a very interesting shading device. This shading device is made from silk. So silk is a very strong material and it's used in parachute construction. So here we've used silk in the construction technology, whereby we've used it as a shading device and we've also introduced it as an internal partition system.
This project is in Bahrain on Manama Bay, and this building is for SIO. SIO is like an insurance company, like a LIC of India for Bahrain. And the two things, this building, we couldn't have the basement. So the component, the program of the whole building was to have 4 floors of parking and 4 floors of office space. So looking at rather than looking at the traditional approach of having this 4 floors of parking spaces and then having office on top, we look at cutting the whole mass diagonally. So once we cut mass diagonally, the lower part of the mass, which is becomes parking area, and the upper parts of the mass becomes the office space. And when it comes to this front space, which was looking into the Bay Area, that became a very transparent retail space connecting with the street. So you can see that the whole space in the front connected with a transparent glazing system, which was completely retail space, and connected with the space. On the other side, on the back side, the facade for the, you can see here, this is again another image of the retail space, and the facade for the parking area was derived from the traditional jali pattern of which you found in traditional architecture of Bahrain. So we did a bit of a study of what kind of jali pattern exists, and then derived certain pattern out of it, and then introduced that pattern into a more of a concrete jali, and then that was put onto the surfaces around the parking area. And this is the view from inside the office, and the office area we kept it mostly glass so that one could enjoy the views of the Bay Area. But even then we felt just leaving it a glass surface might not look great. So we look at creating a break on the top level by creating these terraces, which would have a greenery and also have the similar expression of jali wall, which you see in the parking was taken on the top of the building. So the parking space doesn't look ordinary, and they are look at the similar, both look of a similar system.
This looks at skin to system, evolution as facade as a performative element. It's an experience center for Bhasan developers in Chennai. Now, this is a structure where the skin, the structure, the roof, etc. are just one element. We've used the structure design to create interesting spaces architecturally. There's a diagonal axis here that is explored, and the diagonal axis has a shifting apex, which introduces a lot of north light into the space. So if you see here, what we've managed to achieve is we've managed to achieve this large span without the columns in between. So it's very hard to distinguish what element is what, because it's just one system that creates this architecture. This is views of the same thing from the outside. This is a bit more advanced now at the moment, but this is just when the structure was coming up on site.
I think the project is already complete. Shoot yet. So we couldn't show you much pictures on that. And this is the last project, and this is a very prestigious project for us and the city of Hyderabad, and this is called Hare Krishna Heritage Tower. This is a temple which is by ISKCON Bangalore, and basically this is not a regular temple typology, because as a ISKCON, the way some of us know, they have a lot of other activities happens along with the temple. So if you look at the overall building mass, the lower 5 floors would have that. Basically all the administrative area and the preaching areas and maybe the banquet halls will come at the lower floors. And the temple actually starts from the 6th floor onwards. And then the temple got this pyramidal roof made out of structural steel, glass and solid aluminum cladding. So if you look at the overall structure, this is quite a challenging structure. So we got these 4 cores which are running through the building from the basement. Which basically has lift staircases and also act as a fire escape route, and that ends on the 7th floor, and from there onwards we got this whole glass pyramid which is sitting on top of it. The height of the whole temple is 120 meter, and it's create a very iconic presence on the street from the outside. This is in Kokapet. The construction has already begun. Almost we are 5 floor up, and hopefully we are looking at this becoming an iconic structure of Hyderabad city. Thank you. Just 1 second. Just 1 second. We just wanted to finish it with 2 pictures. Basically, yeah. So we are a practice at present. We started by 3 people: myself, Harpreet, and Srinath. And we come from a very diverse background. Some of us have experience in working with conservation architecture. Me and Srinath has the experience of working in high-rise and master planning projects. And we are a team of 40 architects, and we span across 2 locations, Hyderabad and Bangalore.
And we just want to thank Zak Façades for the opportunity to share our projects with everyone. Thank you.
Thank you, Vikram and Harpreet. This is really, contextual architecture at its essence, with complete empathy to the natural environment, to the site, to proportion, scale, warmth, comfort, all the elements that really bind you to what we really do when we design. There's a lot of soul in projects. I think everyone enjoyed your presentation. Thank you for bringing conservation and our local materials like silk back into design. Next, please welcome on stage, straight from New Delhi, Govind from Eckersley O'Callaghan.
Good afternoon, everyone. First of all, thank you to all the fellow speakers for sharing your knowledge. And thank you very much to the Zak team for inviting EOC. Now, EOC or Eckersley O'Callaghan is a design consulting firm. Our business is split into 3 verticals: structures, facades, and glass. We have 11 offices worldwide with about 150 people working. The company was started in London in 2004 with 3 people, and Delhi office or the Noida office was set up in 2021. So I basically lead the Noida office. So the agenda of today's presentation for me is to give you a glimpse of our facade engineering work through 3 case studies or 3 projects that we have worked on. This is a render from Zahadid Architects for the Henderson building. It's a 200-meter tall tower in central Hong Kong. This is an actual picture of the completed tower. Now, EOC was approached by the client for certain specialist packages of the facade work in this tower. And one of them was, how do you realize a unique event space or a hall at the top of a 200-meter tower in Hong Kong? Again, some renders. This is the view of the banquet hall from outside. So this is basically 17-meter span from column to column of the portal frame. And we have 7.5-meter high glass panels. And again, the intent is that when someone is looking from inside, they should not see any mullions or vertical separation between inside and outside. So this is a render from inside. This is a picture that was taken while this was under construction. So you see those 7.5-meter tall panels, and those are 20-millimeter wide glass joints which have non-structural silicon in them. And along with that, you see the structural framing in steel, along with glass beams on the top, which are supporting the roof panels. This is also, this was still not over. It was not during construction, but before handover. Again, you see those 20-millimeter wide silicon joints. And this picture is a bit of a misrepresentation at the top, because these panels, you see those vertical lines in the longer direction, but those panels are single panels. So these are some wires which are on top of the panels. Maybe in the next picture it's more clear. So you see there, it's just those glass beams on which the panels are supported. There's nothing in this direction along the main steel beam. So different views. One thing which I would like to highlight here is that the steel beams or the steel framing is encased with cladding, and it has quite a thick appearance because there are a lot of systems embedded between the beam and the cladding. Hence the thickness or the bulky appearance of the framing. Otherwise, in one of the previous pictures, you would have seen when it was without the cladding, it was quite close to the render that we saw initially. Now, the design is governed by typhoonic wind loads in Hong Kong. As per the codes, at 185 meters height, design pressure is 3.15 for global facade, and for edges, it is coming to around -4.4 and 3.15. And similarly for the roof panels, globally it's 3.78, but locally it's 6.93 kPa. As is typical with the tall towers, a wind engineering study was done by CPP, and these were the final values that were used for the glass design. This is one of the proposal models that was made in Rhino, where we had this portal frame. It's about 600 square meters of space with the glass panels. Now, in all these projects, in early stages, a lot of optioneering is done to figure out what is the best layout of the framing and of the support system. So in this case, if you start from left top, we have the framing without the post and without the intermediate beams. So this is without the post, without the intermediate beams. Then on the next one, you see those two posts getting added, but still without intermediate beams. On this one, you don't have the posts. Posts are basically these members. So no posts, but intermediate beams. And the final option, which went into realization, you have the posts, the transverse beams, and the intermediate beams. Because that was giving the best output in terms of the design intent and the sizes and other performance criteria. Now, along with the framing optioneering, we also have to do support system optioneering, because ultimately this structure is going to get attached to an existing building or to a tall building which is getting constructed. So in some cases, there is a limitation on the amount of forces you can transfer through this new hall onto the main building. So again, with iterations, we can come up with a system where that constraint of limited support forces can be met. In this case, the entire frame is a moment frame so that we could minimize the deflections of the system. Finally, this is the system that we went ahead with. The red beams is the portal frame. Green is holding back the portal frame to the main building. Then we have the brown ones as the transverse beams. The yellow ones are the posts, and the purple ones are the glass beams. Now this is a sketch of that front window, the view window that I showed you earlier. And if we talk about the build-up of this glass, this is 6 lights. So this is GT24, 6 lights of glass together with sentry glass, SGP. And on the right side is the section at the joint. No mullion, just a 20 mm wide silicon joint in typhoonic wind loads in Hong Kong at a height of 200 meters. This is a sketch of the roof panel where the glass panel is held on all 4 sides. It's a plan view. So GT27 is the build-up of the glass beam, 4 lights with sentry glass, and GT26 is the build-up of the roof panel, 4 lights with the air gap. Now this sketch is trying to show the scheme of releases in the roof panels and the glass beams. Because the thing is that we don't want to tie the steel and the glass absolutely together, because then you don't know what the load path is. Maybe steel forces are shortcutting through the glass and that might damage the glass. So hence we have a scheme where the left end is a simple pin and the right side is a sliding pin in the glass beam and the roof panel. This is a mock-up of the glass beam, of a single glass beam, and the way we realize this intent of not transferring the steel forces through glass beams is through holes. So we have a normal pin on one end of the glass beam, and then we have, so one of them is here, normal hole, standard hole, and the other one is here, the slotted hole. So this allows us to detach the steel from the glass. Now, just diverting one slide, this is Apple Marina Bay Sands in Singapore, again done by EOC. In Henderson's case, we wanted to detach that behavior of steel and glass, But this is a rare example that where instead of using additional diagonal steel bracing or large movement connections at the joints of this framing, we designed the glass panels to brace and stiffen the structure. So glass is actually stiffening the structure, and this is a 17-meter diameter base and a 30-meter height dome. So glass is actively participating in this structure. It is not just a cladding element in this dome. So that was Henderson. Next, I have on my presentation is Apple BKC. This is the render from Foster & Partners. Just to give you an idea about dimensions involved, these mullions are 10 meters tall. The boundary is 37 meters, the edge of the store. And if you look at the main elements, it's the facade with the mullions, the timber soffit, and the staircase inside. So I'll just quickly take you through these three elements. This is the opening day picture with the Apple CEO, launching the store. Some more pictures of the entrance with the curved glass and the steel mullion, 10 meters tall. Now this is a typical section of the facade with those tall mullions. So we have a 260 by 50 mm solid mild steel bar, 10 meters long, with very tight tolerances. And on top of it, there is a stainless steel cladding, which is clamped to it. And then in front of it, we have this insulated glass with 4 lights. Another picture where the canopy is more prominent. So this is a 5-meter cantilever canopy. Now, just early stage design considerations or options, we are looking at something which is permeable. So the canopy is basically attached to the edge beam at one point. It's sloping outwards. So one option was that you have something permeable. The other option was that you have something impermeable, but you don't put a gutter on top. You let the water drip down. Third option was impermeable and you have a gutter on the top. That is the one which the architect finally went forward with. Now these sketches are trying to convey the site limitations, especially when you're trying to install a new structure to an existing building. Now in this case, this is the concrete at Apple BKC site, where so for the canopy, you need an edge beam which can take the torsion from the canopy and transfer it to the building. And that has to be a continuous edge beam. But in BKC case, this edge beam in RCC was not designed for that torsion because it was built earlier. So what we did was we put a steel collar on every column, shown in red. Then to this collar, we attached a bracket which was attached to the red collar with bolts, and it was just sitting against RCC at the bottom, so bearing against it. And then this blue bracket has a pocket. You see those 3 plates at the bottom. This brown beam with the plate in front of it goes and sits into it, and that is how the torsion from the canopy is getting transferred to the building. So the idea here is to convey that the existing building's constraints have to be managed in the design, and this is something which we regularly do in our projects because most of the times we are attaching something to an existing building. This is an extract from the structural model where different colors, so this is the canopy, purple is the edge beam, and different colors are basically indicating different member sizes or wall thicknesses as per the structural criteria. This sketch shows the installation sequence. So first you'll put the edge beam, then you'll put these scissor trusses, and then you'll put these intermediate members, the red and the blue ones. So some more pictures of the canopy. Now, the last part of Apple BKC is this staircase, which is 16 meters span. And now typically, and it has 2 landings. Typically, for such a staircase, you would have a very deep stringer if you're doing it in steel. Now, one design option could be that you have a truss on either side of the stair. Basically, the balustrade, which is a truss, acts as a deep member, and you can realize your staircase in this way. But probably you don't want to see a truss in Apple Store. So, Foster and Partners came up with this render where they said that we want a stringer which is 350 mm deep, and we want to keep the same staircase span, 2 landings, and a glass balustrade. This is just a technical sketch, span, balustrade, height. Now what we did was, to realize this intent, we combined glass balustrade and the stainless steel U bracket, which is 300 mm deep at the bottom. So this at the bottom. And the glass and the U bracket are connected together with bolts. So that makes this system as one structural system, and hence this staircase works or fulfills the structural criteria because it is acting as one unit. Now, important thing here is that glass behaves differently, steel behaves differently. So those behaviors have to be captured in the details, and we have to be very careful because if there is any uncertainty in the load path, then it might lead to breakage of the balustrade and subsequently the staircase because it needs the balustrade to support it. Extract of the structural model where a lot of complicated finite element analysis is involved with the landing plates, the balustrade glass, the stainless steel stringers, the U brackets, all connected together in one single model. A plot of the glass check with localized stresses, but these are within the limits. Then some deflection checks of the staircase, and some natural frequency checks where the intent was that the governing frequency should be higher than 9 Hz. This is a picture from Sealer factory where so the big holes on the right side are the ones which hold the glass and make this system act as one unit, and the 2 inclined holes are basically tread holes. And this is a U section, so it's not very clear, but you see this gap. So it's a U section, and both the arms of the U are unequal size. So the one which is towards the treads is thicker, the one on the outside is thinner, and this is 300 mm deep. Balustrade glass is 3 lights with sanitary glass interlayer. Again, a picture from Sealer factory. So this is how the staircase looks. One last point in BKC, this is the underside of the staircase treads where they put some reflecting SS plates. So it gives a nice look to the whole underside of the staircase with the stringers, with SS stringers. So the last project that I have here is Lolita jars in Bombay. This is a render from Make and UHA Architects. An architectural sketch wherein EOC was scoped with the facade engineering of this building, but I would like to focus on these 3 jars. So the central jar, 11 meters by 8 meters, and the 2 other jars, 6 meters by 11 meters. This is a design intent, triangulation. Basically, you're trying to achieve a curved surface with triangulation. So there's glass, there's framing behind it, and it's all faceted so that you can have non-curvy panels, straight panels. This is a sketch of showing the glass makeup on the outside. So this jar is actually also goes on the inside of the building. So on the outside we have insulated glass, on the inside we have laminated glass, and the section size that we were able to achieve here is 96 by 48 by 4.8 mm. Extract from the structural model and strand. Then usually in these structures, there's a lot of typical engineering involved, but these aspects like non-uniform loads or primary structure movements, if we are attaching to RCC, we need to be sure about interstory drifts. We need to be sure about long-term deflections or creep. So these two, and then the most important aspect of this structure are these nodes, the picture on the right side. So this is what eventually was picked from what is available. But I'll just show you quickly 3-4 options before I end the presentation. So this is Westfield, London. Sealey came up with this node which is a bolted node, but this option was rejected because to bolt the beams to the node, you need to put in a wrench for which you need the flanges to be wider. So the beams would have to be wider. They'll not fit in the beams that we have currently. So this node was ruled out. This is the FF system from Novum Structures. This again, a wrench needs to go into the beams from those access holes. So the flange width is defined by that. Hence this was also ruled out. This is Dali Museum in US. This is the Wagner Bureau node in the British Museum. In this, there is no bolting. You have this star node to which the beams come in and they get welded. But this was ruled out because of aesthetic issues or the quality of welding. So finally, the client went ahead, or the architect went ahead with this option. This is Borimol in Bratislava, where Metal Yapi had this kind of a node, which is basically made from a solid piece of steel, and it is welded to the tubes. This is an extract from Rhino. This is a 3D printed model or a mock-up to see how it looks. And this is the building just before handover. Thank you.
Thank you, Shashank. There were some very fine examples of, structural design complementing the finesse required in aesthetic of architecture, very evolved structural engineering to achieve these kind of details. So let's now give a round of applause to welcome Faisal Al-Dastagir, Head of Projects at Viva Metal Composite Panels.
Happy afternoon. I'm not going to leave you till you give me a response. Time is okay, I can manage. Happy afternoon. Come on, Bengaluru, show some energy, guys. Happy afternoon. Can I have a loud round of applause for all of you? For the speakers who've spoken, who speakers who are going to speak. That's it. Now you're all awake. You guys are all experts in the field we operate of facades. There is nothing new that I'm going to teach you. It's just that I'm going to be updating you of what we at Viva Metal Composites do. I'm Faisal, National Head Projects, Viva Composite Panel. As you see, the title is Innovation in Facade Cladding. It's a beautiful looking project which we just executed in the Kingdom of Saudi Arabia with our cotton steel finish here. So just a quick introduction about what we do at Viva. We are in this business for last 20 years and we started our plant in the year 2015. So we celebrated our 10th anniversary just now. In the last 10 years, God's grace, we've grown to an extent where today we have the largest metal composite plant in India and the 4th largest in Asia. We have actively 14 plus operating lines, out of which we have 4 coating lines and we have 8 lamination lines and peripheral lines as well. One of the biggest USPs of Viva has been the kind of innovation we've put out to the market. Our focus has always been on bringing new products, new technologies, and allowing you all the independence to source products from India. That's been the primary focus. Today, proudly but humbly, I can say we have presence in 20 plus countries. We've executed projects in the US. We've executed projects in the entire Middle East. Multiple projects in Africa. We have executed projects in the Asian continent as well. And we're opening our experience center very soon in Poland. So we are also entering the European market. One of the main reasons these markets have accepted our products is because of the kind of textures and feels we bring on our product. So the whole aim is that how can we bring natural products to a format that is into metal composite or into aluminum cladding? That's the whole concept that Viva revolves around, and to bring any natural material to this format and see how that can be easily installed in a facade. We have a robust network of distributors, dealers, company branches all over India and globally. As I talk about innovation, the first point on innovation that comes to my mind when I talk about Viva is that the kind of series we have, the kind of shades and textures. Now, what you see here is one of its kind stone texture with 15-year exterior warranty, available in fire retardant options. Now, the best part about Viva is that you can pick a shade and you can decide what format you want that to be in. Do you want a Class B FR grade? Do you want an A2 FR grade? You want an A2 plus corrugated core? You want a honeycomb panel? You want a solid sheet? So one shade can come in 6 different formats. Now that's a big versatility for a stakeholder to work on, because you have so many options at your hand. So you just select a shade and you say, I want it in honeycomb panel, it can be done. You select the same shade and say, I want it in solid sheet, we can do it. Apart from all this, we can also customize any piece of metal, RAL color, Pantone color, any stone, what you give us. We need is a physical sample. So this is one of a very popular series where we've been doing a lot of projects in India and abroad. It's really doing well because it's got a great texture on the surface. Wood is always perceived to be an interior product, but again, we have an exterior product with a tactile experience. And that's the whole point. How realistic can we make it look like wood? So this is a 15-year exterior product. You can use it in interiors, no doubt, but the thickness goes down, but it's primarily an exterior product with an exterior warranty of 15 years. Tarnished Metallum has now been a flagship product for us for the last, I should say, 4 years. We've done numerous projects. I'll be showing a few of them. Pan-India. This is inspired from metal, cotton steel, copper, steel, titanium finishes. It's purely a metal-inspired series. Natural stone. This is one of our series that has been with us for 7 years now. This is again stone, but not like Santa Fe. We have textures that are a little mellow. The Santa Fe has pretty real stone texture. So you have 2 options in stones at different budgets as well. We've also collaborated with world leaders to bring out new materials like zinc composite panel. So our collaboration in zinc is with Zinc Spain. We get the coils from Spain and we do the composite in different formats in our plant. And the biggest advantage with Zinc is that they have 12 shades which no other zinc manufacturer has. Second, they come with a width of 1220 and 1250 vis-a-vis other zinc manufacturers who have only 990. So that's a big advantage. You can have wider grids on your facade. This is a path-breaking product we got into India a year ago. This is a collaboration with Aloxide Germany. The brand is called O-Coil, and we get anodized coils. It is not coated, it is anodized. The coils come with a lifetime warranty. The product that we make comes with a 25-year warranty. So it's like you fix it and you forget it. That's going to be there for a lifetime. This is a path-breaking product. We're getting great responses on this product as well. Yes, our bread and butter comes from ACP. That's our core business. But now we are growing beyond ACP. We are going into future products that will also occupy a big space in the construction industry. One is pre-coated solid sheets. So first company in India to launch pre-coated solid sheets, 2mm and 3mm. The big advantage you have here is we can also make the panels for you. It's not only the sheet we'll give you ready-made panels, factory finished panels for different systems. Now, if you have a hook-on system, I'll give you a panel that would be for a hook-on system. So we can sit down, get the drawings together, and then we can make a tray for you so that you just have to get a factory finished panel and fix it. The small AV on solid sheet. It's not only that we're going to be now focusing on selling the product. We understand when we move towards modern products, we also need to come up with solutions. So we also are going to be suggesting system solutions to you. From our side, as a manufacturer, we would work hand in hand with all the stakeholders and see what best system can be offered so that we be a part of the solution and not just the supply. Again, a trend-setting product which is honeycomb panels. For the first time in India, we have FR A1 rated honeycomb panel. So there is no other manufacturer which has an A1 rating for honeycomb panels. So A1 is as good as the solid sheet. It is non-combustible. You all know very well that honeycomb panels are a performance cladding product. They give you thermal performance. They also give you an acoustic performance as well. So again, this also would be a ready-made finish. We would do the edge bending, edge sealing, and send the entire cassette to you, so you can just fix it. And we would also give you systems like the M-Plan system or the open hook system, where you can incorporate that into your installation. Our focus has been for the last 5 years, especially, we've put a lot of resources into making ACP as safe as possible, because we understand that safety is also a great factor that we need to put in when we make buildings. So basically, FR ACP, you very well know, is nothing but the core is of hydroxide. So when the core comes in contact with fire, the hydroxide releases the oxygen. What you're left with is the moisture. So moisture will not spread fire, not spread smoke. So we've been doing a lot of certification on fire retardant products. We've ensured that every fire retardant product of ours is certified. Please, careful attention here, it is not tested. It is certified. There's a huge difference between certifying a product and testing a product. Testing is I make a sample, I send it for testing, and I get a desired result. Certification means my product is under audit by the certifying agency, which in our case is Thomas Bellwright. So for each certification, there is 3 to 4 audits a year to see whether the process production is in line with the standard that we are adhering. So we have EN 13501 for classification of fire, which is a reaction to fire test. We have NFPA 285, which is a fire propagation test to see how well the ACP is behaving and not achieving certain heights to propagate fire. It's a very stringent test to pass, and all our products from Class B, A2, A2+, Honeycomb, all have NFPA 285 certificate. ASTM E84 again is a deep dive into fire propagation and smoke index, where we test the product to see how they perform specifically on a particular index of a standard that is prescribed. We also understand that sustainability is going to be a big factor in the future. We've just got our product certified. We are EPD verified for FR-A2 and FR-B. So we've taken care of the sustainability part as well. Not only that, we have the NFPA, EN and ASTM, but wherever we've gone into whichever market, we've ensured that we've done the local certification. For example, in Dubai, we are Civil Defense certified. In Saudi, we are SASO certified. We are entering the Australian market, we are going to get the AS certification. We are entering Malaysia, we're getting the Malaysian certification. So we've ensured every country we've gone in and certified ourselves, and that's a hallmark of and testimony of the quality that we provide. We all know that these certifications are pretty stringent, and when we work abroad, it is all about document, and if your document is okay, then you're okay. Their standards are very strict and they're very particular about what they use. We've also put a lot of impetus into coil coating, and we understand that any cladding material, the coating plays a very big role. So we have warranty starting from 10 years right up to 30 years. And we have different thicknesses of coating that we do to achieve these. So this is just a basic idea to give you how we achieve different warranties in terms of coating. So when we do a 25 micron, it's 10 years. When we do 28, it is 15 years. When we do 35 micron, it's 20 years, and 40 is 25 years. This is where the entire magic happens, and we've grown as an organization. We've grown our plant from 13 acres today to 65 acres of land, and we are expanding at a very rapid pace. That's our existing plant, and that's the new plant that is being developed, where we have the solid sheet line, coating line, machines. For the first time in India, we are the only one to make our A2 core. A2 core is still sourced from China by a lot of all the manufacturers. Even we were doing that 3 months ago. But today we make our own A2 core. We have our own paint mixing unit. So we mix whatever shades and textures you see are formulated in our plant. We work with all the major paint suppliers, Spectrum, Beckers, Nippon, PPG, AkzoNobel, and many more. And we buy components of paint to achieve whatever textures and shades you want. This is our coating line 1, a single coat, single bake. Coating line 2, and this is our coating line 3. So every 2 years we've added a coating line, and this is our one of its kind in India, solid sheet coating line, which is a 4-coat, 4-bake line. It's a pretty huge line, very advanced state-of-art machine. We have 2 FR lamination lines for A2. We have 4 for Class B. And I was mentioning the A2 core manufacturing line. So this is the A2 core manufacturing line. A few projects to sample the kind of work we've done. This is one of our oldest projects in Bangalore, Mall of Asia. 13,000 square meter. The consultant was Envelope Technique, and we've supplied 20-year warranty product. This is a Prestige Park Group. Babu sir is here, and we worked with him, FRA2, tarnished metal, cotton steel finish. This is again 4 years old. Just next to Mall of Asia, you have the L&T building, which we've done 7,000 square meter, again FR Class B, 20-year warranty. Some different projects in smaller cities like Nasik, where we've done some CNC work. We've done some 3D panels, strip kind of facade in Pune. We work with Phoenix. Phoenix is one of our largest accounts in India. We work with them in multiple projects. Mall of Asia, Wakad Mall. This is for Kirloskar Avanti. We've done 10,000 square meter of tarnished metal with consultant is Maynard, architect is Sandeep Shikre. This is a huge tower we did in Phoenix with Phoenix now in Pune, Wakad. 40,000 square meter. Beautiful project in Hyderabad for Raheja. Here Raheja, we almost do 1 lakh square meter per year. Convention centers in AP and Telangana. So we've done almost like 40 convention centers in AP and Telangana. Beautiful looking project in Kenya. Just executed, we just got the supply done. And a wonderful looking project in the city of Kuwait. This is with our stone series and our Traventine marble series. So this drone shot was done by the facade contractor. So he had picked up this great drone shot from him. A very interesting project where we did in Kingdom of Saudi Arabia, where we have a barcode design. This is a customized design that we developed for the project. It has got specific barcodes with the RAL colors being mentioned, the dimensions of the barcode being mentioned. This is a mall called the Icon Mall in Riyadh. A beautiful looking marina tower in Qatar, and one of our projects we executed in US for Hilton. We also are a great part of the branding business, where we work for branding of retail brands, automobile brands, petro brands. We work with all the major brands to create customized identity for their corporate showrooms, retail touch points. So that's one of our businesses which we are also growing into. And this is a testimony of the kind of clientele we work with today. At Viva, we strongly believe that we're ready for innovation, we're ready for pushing the anvil, and we look forward to your continued support. Thank you for being a great audience. and wishing you all a great day ahead. Thank you.
Thank you, Faisal, for this informative presentation. Let's give a round of applause now to welcome Deepak Parmeshwaran from Jotun Powder Coatings.
A very good afternoon to all. It's been always a pleasure to be here on the stage in front of the Bangalore crowd. Bangalore in many ways is the hub of architectural, where you have the best of the architects, the consultants, the developers, and not just that, even the manufacturing setups. So many ways, Bangalore is the hub of architectural, and that gives us great pleasure in being here and presenting to you. We would like to say, we would like to share with you what Jotun has to offer. We try to bring in something new every year, and this year also we have tried to bring in something new in cool shades and other products. So we would like to highlight these products here as well. We will be completing 100 years next year. We started off by supplying coatings to small southern visits going to the south of the southern hemisphere. But today we have grown to an organization which supplies products, paints and coating solutions, not just in marine, but in decorative, protective coatings, and also the powder coatings. We today have a 10,000 dedicated employees organization, and we are spread across 6 continents and have 40 factories and 7 R&D centers, mainly focusing on new product developments that we talk about these days. It is very important for us to ensure that we gain the trust of architects, developers, and consultants. And we actively ensure that we showcase the best in the technology in terms of how the products are manufactured, how the application is done, and how basically the installation aspects are also taken care of when it comes to powder coatings and other solutions. In this regard, we had basically arranged a knowledge series for the best of the consultants in India in the month of February, where we took them through the manufacturing process, the innovation lab, and not just the production of the powder, but also the application and the installation part as well. This was conducted in Dubai for a period of 3 days, and each and every consultant had something to take away from this entire series. This kind of knowledge series we conduct for our consultants, architects, developers across the globe, and this has resulted in the trust and confidence which has helped us create these kinds of landmarks. Today, out of the top 20 tall structures that dot the planet, 14 of them are being coated or are protected by Jotun paints and coating solutions. The one that is coming up in Kingdom Tower, which seems to be the tallest at this point in time, in the future, in the next 3 years, is also being coated by Jotun powders and coating solutions. What we meant to say is that these kinds of projects require a lot of scale of production planning, etc., in order to ensure that we are able to supply the kind of quantum of powder. Not just that, also to ensure that they are accomplished in the timelines that need to be accomplished. Today we are talking about, these are the kind of projects which need to be built for generations. And when we talk about built for generations, we are talking about 4 basic or 4 broad parameters. 1, powder coatings which are long lasting and durable. 2nd, powder coatings which makes your projects beautiful aesthetically. 3rd is powder coatings which are sustainable, and which seems to be the talk in the town when it comes to green solutions. And last but not the least, powder coatings which are safe and reliable. Jotun, through its European roots, ensures that most of the products that it supplies is safe. So that is a given and a taken for us. So mainly we will be focusing on the first 3 parameters, that is durability, aesthetics, and sustainability. First, we'll start off with the durability aspect. Under the durability aspect, we have 3 broad categories of powders. One is Jotun or brands in the powder coating segment. One is Jotun Facade, second is Jotun Super Durable, and the third one is Jotun Durosol. If we have to technically just delve into the subject, the powder coatings or the durability of aluminium is broadly classified through 3 specs: AMA 2603, AMA 2604, and AMA 2605. So Jotun Facade complies with AMA 2603, offering 15 years of guarantee. Jotun Super Durable, AMA 2604, offering 25 years of guarantee. And Jotun Durosol, which is the best in the class, AMA 2605 offering 30 years of guarantee. Nowadays, fire rating is also becoming an important category or an important parameter in deciding what powder coating should be used. Jotun Durasol is classified A1 as per EN 13501 standards, and projects like bullet train stations are specified with A1 category fire rating, which needs to be going into the on the aluminium. So this is also catching up a lot of traction. Durasol is rated A1, whereas Super Durable is rated A2, A1 being the best. I'm sure nobody requires an introduction. Now, this is theory. How do we basically perform on the ground? So we have been tracking some of the projects on the ground as to how the powder coatings have been performing over the years. And one of the projects on which we have used our powder coatings is Burj Al Arab. This is a project which requires no introduction, as I said. It is right in the middle of the ocean. I mean, it's in one of the most corrosive environments, and it has been standing since 1998. We started this project, or we supplied powders in 1998. So as a part of all these major projects, we have a retained sample which is maintained right at the beginning of the project, the approved panel, as we say. So we had the master panel, which was retained in 1998. And we made measurements on the profile on the site in the year 2017, and we can see there is very minimal difference in the shades between what was done and what was there in 1998 and what is there still standing today. This is a project which has completed 25 years. We offer 25 years guarantee for the Super Durable series, and this project has completed the complete tenure of 25 years and is still standing good. So we basically give guarantees on 3 parameters, which includes gloss retention, color retention, and the durability. On all 3 aspects, this project has stood out very well in a very, very highly corrosive condition. Another project not far away from here on the Palm Jumeirah is the Atlantis Hotel. Here we had used an even more exotic shade, which is a green shade, which are more prone to fading and other aspects. I mean, gloss, drop, flare, fading, etc. We had made the measurements. I mean, this was completed in 2007, the master panel which was retained, and when it was compared with the aluminum extrusions which are standing on the site in 2023 after 15 years, there is very minimal difference between the gloss, color, and the durability. From the master panel and the comparison at the site, we can see there is the film integrity is intact. So, not just in theory, but in reality as well, we can see the Jotun Super Durable series, performing very well on all the 3 aspects on which it has to perform, which is the gloss, color, and the durability aspects. Taking one notch higher on the durability is the Jotun Durasol series. This is an AMA 2605 compliant product, as we saw in the previous slides. This is the best in the class, as we can say, and it provides long-lasting beauty, ultimate in durability, and the best in sustainability. AMA 2605 products currently which are used in the market are the liquid PVDF systems. So we thought it would be good to put up some points of similarities and dissimilarities between Jotun Durasol and the PVDF systems. So I like your PVDF systems, AMA 2605 compliant Jotun Durasol. It is a fluoropolymer resin. Both these systems use fluoropolymer or a fluorocarbon system. That's where the similarity ends. After that, if you see it is a single coat system. Durasol is a single coat system, whereas the liquid PVDF systems are either 2-coat or 3-coat systems. In a single coat system itself, you get 60 to 80 microns, whereas in a PVDF system, you get about 45 microns or 30 microns, depending upon whether it's a 3-coat or a 2-coat system. It's a low VOC and an efficient application. It's a single coat system, thereby the application process is also fast. The baking temperatures are low, 200 degrees Celsius 10 minutes as compared to 240 degrees Celsius 10 minutes. So sustainability wise also, it's a much better system as compared to the liquid PVDF systems. Last but not the least, we offer 30 years guarantee for these products as compared to liquid PVDF systems, which offer 20 to 25 years. And when we talk about guarantees, what are the 3 parameters that we were talking about? I would repeat, it is the color retention, the gloss retention, and the film integrity or the durability. So when we talk about guarantees, whether it is 15 years, 25 years, or 30 years, we offer 15, 25, and 30 years for these particular products for all the parameters alike. That is gloss, color, and film integrity, all are guaranteed for the respective number of years. how do we ensure that the powder that we are supplying to the applicator is ensured is coated in the right way, and how the guarantees are ensured? Basically, we have the Jotun approved applicator program. This is where we basically see the best out of the rest. We have millions of applicators across the globe and more than 100 applicators in India. But how do we know which one are the best? So Jotun has an approved applicator program by which we audit the applicators for their systems, for the pre-treatment systems that they have, for the guns that they're using for powder coating spray. Apart from that, the curing oven, whether they have a lab setup, whether they have a powder storage system, which is a completely AC controlled system. All these systems are basically audited for. And not but this, but we also ensure that some of the panels are sent for long-term testing, for ASSD testing, as we say, to Dubai. Once they are cleared, then only they are offered the approved applicator program. This gives us as well as the developers and the fabricators a peace of mind that what product you're getting is a complete guaranteed product. Today for Jotun Durasol, we have about 7 approved applicators in India. And for Super Durable, we have about 26 applicators in India. When we talk about, these were all finishes on aluminium. We also have powder coating protection systems on steel. When we talk about steel, we have to first select the environment, whether it is, what is the corrosion environments in which the steel structure is going to come up. Say, for example, is it a C4, C5 environment? Based on the environment, we select the durability that you're looking at, whether you're looking at a 5-year anti-corrosion guarantee system or a 10-year anti-corrosion guarantee system. And based on that, we select the final coating system. The coating system comprises of a 2-coat system. It has a primer coat, which is considered to be the heart of the protection for a steel structure. And secondly, you have the top coat, the Jotun Facade or the Super Durable series products, which we had earlier seen for aluminium. The same top coat can be used on the steel as well, but below the above the primer system. So what it gives is that it gives the protection through the primer, and it gives you immense amount of color options through the top coat. So since we said that the primer is the heart of the system, there are multiple types of primers which are available, which are zinc-free and zinc-rich. So Primex Protect and Primex Extend are the 2 primers which can be used on steel to enhance the protection on the steel and thereby give you guarantees. We spoke about the durability aspect. Now we will quickly go through the aesthetics that a powder coating can offer on the aluminium. There can be many finishes that are possible. Some of the major finishes that are very prevalent in the market are listed here. One is metallics. Second is Sahara finish or the fine texture or the coarse texture finish. Then you have the woodspiration, which is the wood coating finish or the wood-like effect on the aluminium. And last but not the least, the cool shades, which is the next in the terms of sustainability that we are all looking at. So metallics, this is gaining a lot of traction. Most of the projects that we see, the premium projects that we see, are getting specified with metallic colors, and they lend a certain elegance to the project that we say. A unique distinction. It stands out completely as compared to the solid shades that we are looking at. It's also it's more and more prominent in the sense that when the metallic finishes are used, it's much more easier to maintain, and more effectively it offers better protection. The Sahara collection or the fine texture or the coarse texture finish, when we say it is a fine texture finish which is had on the aluminium substrate. When you do that, it helps in slightly concealing the imperfections of the aluminium in a better way. Any dye wells or imperfections of the substrate can be concealed through these kinds of finishes in a way, not very heavy, but very lighter ones can be definitely concealed. It is much more better in dirt pickup resistance. It picks up lesser dirt as compared to smoother finishes. Scratch and mar resistance is better in case of these kinds of fine texture finishes, and it is better in wear and tear as well. Many of the projects are getting specified. Some of the shades which are very commonly used in these kinds of in these are the Shuko greys. You would have heard about the Shuko grey. It is a fine texture finish or the Sahara finish that we are talking about. Woodspiration. These are the kinds of finish which gives you a wood-like effect on the aluminium. And generally there are 2 technologies which basically by which you can get wood effect on aluminium. One is powder on powder, and the second is powder plus a sublimation film. So in India, there is no powder on powder technology where both where two powders are used in order to bring about the wood effect. Basically what is used in India is the powder plus film. So here, as manufacturers, we provide the base film to the applicators. The applicators procure the films from major suppliers like Memphis, etc. And then they do the sublimation process to ensure that you get a wood-like effect on the aluminium. So they can be used in both interiors as well as exteriors. These are mainly prominent in many private residences or very niche areas within a commercial complex or kind of projects. But this is also can be used in the exteriors in countries like Middle East. You have Dubai Opera kind of projects where the complete exteriors have been done with wood finishes. The cool shade collections, as I spoke about earlier, I mean, it is the next in terms of sustainability. What it helps in doing is that it helps when you are having it basically is a cool pigment which is added to your normal shades. With the normal shades which you are using, when you add a cool pigment, you get a protection from the heat transfer, which happens from outside to inside is restricted. And since there is lesser reflection of heat onto the surroundings, the heat island effect is also prevented. So we do not have any projects in India yet using, but I have heard from some of the consultants here that there is a growing trend in sustainability and more is required in terms of doing cool shades. So cool shades can be definitely helpful in those situations. The sustainability aspect, just continuing with that, powder basically complies with all the standards that are major standards which are available in the industry. And since LEED is one of the most popular standards, we thought that we can just highlight the paints and coatings part, what they can contribute. About 8 points can be contributed through paints and coating solutions. One of the points which talks about is the environmental product declaration. We have the most extensive collection of EPDs across the globe. And we will be more than happy to share it with any of the consultants who are inquiring for it, because this basically is the cradle to grave analysis that we talk about, where what is the kind of raw materials which is used and what is the kind of the end product that you're getting and how they are used and how they are disposed. So we have these EPD certificates which can be shared. Some of the projects, and sustainability starts at home. So basically, this is our project. This is our head office in Norway, and we are a LEED Platinum certified project. Not just that, in terms of the raw materials that we use, we do not use any chromium, cadmium, etc., or any carcinogenic material in our products. We are REACH compliant. So all these aspects ensures that we are the best in terms of sustainability that we can talk about. Some of the references, quickly, I'll just take them around. I know I have overshot, but I need just 1 second more. So, Forum Serendipity, super durable projects which we have done. So, basically the Common Central Secretariat that we have done, where we have supplied a super durable series. Oberoi Reality Elysian, Mumbai, where we are supplying our powders, super durable powders. Carle Hub 5, Bangalore, where we are supplying our powders. Siemens Healthineers, we had one of our presenters from Eller and talking about this project. It is our powders which is going for these project. Then Trilite Pangatram, Hyderabad, Alekia Homes, some of the projects which we are currently doing. Mumbai Airport has been standing good for a long time. ONGC office also. And some of the Durasol projects, Durasol has picked up a lot of traction, as I said, and we have been very happy to do a few projects, which includes the Olympia Park Residency. This is the first Durasol project. Noida Airport has been done with Durasol. The roofing, the ITC Green Center currently is being executed with Durasol in Bangalore. Microsoft Data Center in Hyderabad. My Homes Grava Business Park, which is currently being executed with Durasol. Aluplex is the vendor for that. And Foxconn, we have recently completed, and many good high-rises in Bangalore are also using the product. One of them is here. Thank you very much. Thank you very much.
Thank you, Deepak. Let's give a round of applause now to welcome Malvinder Singh from Kurale.
Thank you very much for the introduction. Very good afternoon. Myself is Malvinder, and today I'm here to talk about advances and new developments in structural and sustainable interiors for laminated glass. Okay, so For those who don't know what is laminated glass, this is a very simple illustrative sketch. Basically, you have 2 layers of the glass, and in between there's a polymer, which is generally the PVB interlayer. But it's not always the case. Not all the interlayers are PVB, and what's really inside the 2 layers of the glass can really have a big impact on the performance of the glass. And at Kudare, we manufactured a variety of interlayers. So on the left, we have the structural interlayers, and on the right, we have the non-structural interlayers, and in the middle, we have the sustainability as the new topic, which we are going to address. We have introduced or launched a low-carbon PVB interlayer, which is Tryzybowicz R3. So basically, in structural segment, we have the Extra Strip Pro, and in sustainability, we have a low-carbon interlayer, Tryzybowicz R3. So starting with the structural interlayers, what are structural interlayers? So as you can see from these pictures, so when the glass is not acting just like a glazing element, but it is acting, bearing some loads, so we call those as structural elements. So Sentry Glass is the hero product in our portfolio, which is the best structural interlayer you have. And we heard from Sushant Goel that Sentry Glass is the choice of the architects and facade consultants, especially the Apple projects all over the world. And then we have introduced Tryzybowicz Extra Strip Pro as a new structural interlayer, especially for climates where we have temperature controlled environment where temperatures are not exceeding 30 degrees centigrade. So if there are some structural engineers in this room, they can understand this graph pretty well. We have the best structural interlayer, which is Sentry Glass at the top, with its Young's modulus always very high compared to other interlayers in all temperature ranges. And then we have the deep red color, which is the representing the Tryzybowicz Extra Strip Pro. And then we have other strip PVB from other manufacturers. And then at the bottom, we have the PVB interlayer. So clearly, the red line is always having an edge over the other strip PVB interlayers. Now we know the Young's modulus is better for Sentry Glass and Extra Strip Pro interlayer. So what do we do with that? So as structural engineers, they can do the FEM analysis, like for this glass weaving application, which is supported only at the bottom edge. So we can do the FEM analysis for the line loads and see its behavior. So this table is summarizing the deflections and the stress values between Extra Strip Pro, which is also called ES Pro. Comparison is with the 1.52 other strip PVB interlayers. So if we take the Extra Strip Pro as the base, the deflection values and the stress values, they are higher by 13% and 22%. Yeah. So this highlights that the Extra Strip Pro has got a better performance compared to the competition. And then there is another important parameter which is related to the structural interlayers is the post-breakage strength of the interlayer. So what do? We do this 4-point bend test where we intentionally break the glass and impose a live load on the center of the glass and then see its behavior. So what you see on the top is the deflection is increasing with the passage of the time. On the top, we have the Tryzybowicz Extra Strip Pro, and at the bottom, we have the other strip PVB. So clearly, there is a stark difference between the post-breakage strength of the two interlayers. And also, we can draw the graph between the deflection values and the versus the time. So here, there is a clear big difference. So the Extra Strip Pro almost took 10,000 seconds compared to 100 seconds for the other strip PVB. So we call this as creep behavior, which is very, very important for structural engineers, especially for overhead applications where the deflections can increase with respect to time. And then what we did is, what you saw earlier was the software simulation. And now this is an actual test done on the glass balustrade. So we did the line load test. So here we see the deflections are quite less compared to the other strip PVB in case of excessive interlayer. And then another important test, which is also related to the post-breakage strength. So we break the cantilever glass balustrade and impose a point load onto the glass to see how much load it can sustain before it can be made to completely collapse. So the collapse load in case of Extra Strip Pro laminate was almost double than what it was for the other strip PVB manufactured from the competition. Another important aspect is the edge stability, especially when the glass railings are exposed to the environment. So here we did these salt spray test for 5,000 hours. So clearly you can see the edges on the for the extra strip row, they are almost as clear as they were before the start of the test. Whereas in other strip PVB, you can see some fogginess developing at the corner of the glass. Also, in terms of visual appearance, if you see the laminate which is put at the bottom, this is blending very well with the appearance of the natural appearance of the glass edges. So this is more acceptable to the architects, because when the edges are in a very close visual range to the human eye, they have got more acceptability. And then we can also summarize the structural applications here, the structural interlayers. So we can look at this table from the right. So like good, better, and the best, because Sentry Glass is still, the big daddy of all structural engineers if we compare all the parameters. So it has got a very high performance in terms of all the parameters that have been listed over here. Okay, then moving quickly to the next topic. So I'm sure there must be some RCB fans in this room. So congratulations to all of them for winning. RCB has lifted the trophy for the first time. But now we are living in the age of deep fake news, and also it can be very challenging for even the die-hard fans of Virat Kohli to identify which one is original. And unfortunately, we are also badly affected because of the fake counterfeit products which are being sold in the market. So it's important when you write specifications, it's a humble request for architects and facade consultants present in this room that you don't write SGP, because SGP is basically a fake product which is being pushed by some Chinese companies into the market, and the real name or the authentic name of the product is only Sentry Glass. And we have taken some measures to address this issue. We have launched the Quality Network of Laminators program, and also we are working on blockchain technology. This will be introduced very soon. So just in the interest of time, you can just walk down to our booth. We have a booth outside. We can have more discussions about this. So Sentry Glass is a product which has been recognized all over the world because of its high performance. It has got all the global certifications, which are very tough to get, as certification in the US, DIBT approval in Germany. Yeah. So if you end up using a fake or counterfeit product in your project, things can go horribly wrong. These are some of the pictures where a fake product has been used in one of the projects. High haze can be seen in these glass fins. And in this project, the interlayer developed some cracks for some unknown reasons. And this is a close-up of those defects which have been observed in the interlayer. Also, if you do this swing back test, so the glass really is expected to stay, it shouldn't collapse like a piece of cloth. And so just after the impact, it is just having no post-breakage strength at all, offering no resistance to the swing back. Then I quickly jump to the next topic, which is the next big mega trend, which is catching up very fast. And we being a very environmental friendly company, we have committed to reduce our carbon footprints by 50%. By 30% by 2030, and by 2050 we will go carbon neutral. And following this trend, we are voluntarily declaring all the carbon footprints that we are emitting from our different manufacturing facilities. And we are proud to say that we have got the lowest carbon footprint, as we have launched the Tryzybowicz R3, which is the low carbon PVB. And also, if you compare PVB versus Sentry Glass, so there is one more reason why to go with Sentry Glass instead of PVB, because this is generating a less number of carbon footprints. So here we make a comparison between, like if you use the PVB laminate construction, let's say it's 8 plus seat 1.52 PVB, so it is generating around 55 kgs of carbon dioxide. And if you just simply replace the PVB with structural interlayer Sentry Glass, because of its high stiffness, you can down gauge the glass, and this will help you bring down the carbon footprint by 24%. And then, so now some of the glass companies, they have also launched their low carbon glass. So if low carbon glass and low carbon PVB, they are used. So from 27.5 kg of carbon dioxide, it is possible to reduce the carbon footprints by almost by 43%, because low carbon glass with low carbon PVB will have a carbon footprint of just 15.5 kg of carbon dioxide. So this is my last slide. And then I would just like to summarize. So standard PVB is not a structural interlayer, and Century Glass outperforms all the interlayers that are available in the market. And Tryzybowicz Extra Strip Pro, which has been recently launched, it has an edge over the competition, as we saw in the graph, because of its high Young's modulus. It simply outperforms in the various ranges of temperature. And Kurare is the sole manufacturer of Century Glass interlayers, so please be aware of the knockoff products which are being sold in the market. Low carbon interlayer, Tryzybowicz R3, it is when used in combination with low iron glasses, it can help you bring down the carbon footprints by almost 44%. Yeah. I know we had a constraint of time, so we have a booth outside. So me and my colleague Sumit Banerjee, we are outside. So if you have any questions and more discussion you would like to have, so you are more than welcome. And thank you. Thank you very much.
Thank you, Manvinder. Ladies and gentlemen, we have just one more session before our tea and coffee break. Let's welcome on stage Jean-Paul Hochtier, Global Strategic Marketing Director from Dow.
Ladies and gentlemen, good afternoon and also happy Friday. So my name is Jean-Paul Hochtier. I'm a Strategic Market Director at Dow. I'm based in Zurich. Very happy to be back in Bangalore. I really like the vibes of the city. I also like the climate. And during 10-15 minutes, I hope to give you that you will learn something. And I want to give you the latest insights, news, trends on the world of silicon. As you may know, probably you know that Dow is a leading material science chemical company in the world. You can see our size. We provide in the construction sector solutions for residential building, commercial building, infrastructure. From the acquisition of the Dow Corning franchise, we are also leading suppliers for silicon. And I can say that R&D innovation is one of the cultural elements of the company. We have a sizable and increasing presence in India, as you see, with our Dow India Technology Center. What I will go through this presentation is give you a few of the trends that we see on the market. I will also share some examples about things that we do related to product innovation, but also the sustainability aspects. And I hope again that you will learn something. So silicon sealant, actually we trace back formulation in the late 60s. So actually we do have 7 decades of experience with that product in the application. You will see that yes, we are a committed supplier. So more than 80% of the high-rise building are trusting Dow silicon as a structural attachment. We are the only one proposing a carbon-neutral silicon for facade. And of course, we continue to develop the product line. What you will see more and more now from us is not only technology on silicon, but we are offering a wider range of products, including organic. So I like this slide because it shows a little bit how we have impacted positively the skyline together with you, our clients. I will just mention here that the first structural glazing four-sided, 1971 in Michigan, North America, so pretty harsh climate. The building is still there, it's operating, and our teams time to time are going there and test the product. So this is a testimony of the durability of this technology in the application. Of course, I also like this slide. This is the latest skyline from the council on tall building and urban habitat. As you can see as well, Dow has been on the tall building more than 80% of the market share. What I want to underline here is that this is good, but we are giving the same products, same process, same care for all the 5,000 projects we review each and every year. This is called quality bond. So what we want to provide is the same level of quality for each square meter or square foot of facade that is made by silicone, whatever the size of our project. So where do we see some of the trends? So glazing needs to be smart. Sometimes you need to have privacy. You need to have security related to the signal. Sometimes you want the signal to communicate because you want to have a better communication. We continue to see requirements on efficiency, on building tightness, cooling or heating. There is still a lot to do on built-in photovoltaic. I think there are emerging technology, but we are still not there. Of course, doing it on a vertical, it's a challenge, but the opportunity is big. A lot of requests related to sustainability, and basically it's about circularity, how you get back the product to the manufacturing, as well as the carbon footprint, embedded, but also operational. I think more and more scarcity of qualified laborers, the advantage of prefab and modular system, and as it was mentioned also today, the urban environments is moving from this mixed use, and together the solution, the architecture is also moving. For this, we have developed a digital tool. I hope you have the time to QR code it. Building Science Connect. So it's a digital interface. You can, in a click, see what type of solution is available at Dow, because we want it to be easy. We have a lot to offer. You can select the new and existing. You can also select where your building is, so that you are able to specify the products that is currently used or qualified in that particular country. So Building Science Connect, we try to simplify the life of our customers. Over the next few slides, I will give you a little bit of an insight about what we are doing at Dow. From a leading material innovation point of view, as I said earlier, we are enlarging now our products, not only silicone, but silicone modified and organic. I will choose 3 examples. On the left side for silicone, we continue to upgrade our flagship product, that's Dowsil 983. This is really the reference in the market. We improve it for performance on the job, but also on the process. Very important to have a seamless process. Dowsil 993 Repair Kit, this is a new product. So it's actually a portable solution. So it brings fast cure silicone structural glazing on the job site. Why? Mock-up, repair, but also a little bit of small size commercial glazing job. So quite easy. And we continue to drive advancement in developing products related to crystal clear bonding and durable assembly. And this is due to minimizing the amount of material. Also, that technology is clear. And we're actually working in partnership with a few companies, including the companies that presented today. On the organic side, this is the right side, I want to mention EPDM membrane. This is compatible with the proofing solutions. Silicone hybrid 789P. This is sealing, but you can overpaint, loader pickup, and low staining. And last but not least, an interesting product, which is taking good traction from the market, Dowsil 50 Plus. It's a waterborne acrylic to protect the module assembly for transportation and installation. So on the engineering technical support side, I choose to take the example of the raising use of cold-banded glass. And I can proudly say, because I'm not in that department, that our TSND guys are good there. They are the Formula One. So if you need any advice on how to use silicone in cold-banded glass, contact us. Those are the guys that knows. And you know that cold-banded glass is it's a good technique because for relatively low cost, it offers already quite good aesthetics. And it can be bended in 2 ways, as explained in the middle. And of course, it will depend whether this bending is applied on the job or in the factory. And in the factory, it cannot be applied before or after silicone. So those are the three criteria that our team is considering in order to give you the recommendation on the silicone bites. I'm including in the presentation a few references so that you know the latest communication on this technique was given at the last GPD conference in Midland. So cold banded glass, this is a trend. It's actually cost effective. It's a new area in the science of silicone structural glazing, and we are on it. As I said earlier, we are the only companies providing carbon neutral silicone system. And on this slide, you can see the process to make silicone. One of the big contributors for carbon is the silicone metals. And because of the silicone metal, because the fact that we are integrated upstream, we are making the silicone metal ourselves. We do that in Brazil. We use green energy. We also use responsible low carbon feedstock. And based on that, we are working according to PAS 2060. This is a standard that controls everything. And we are able to provide insets that are therefore proposed to decarbonize the products that we supply to this industry. And for instance, we are glad to mention that collaboration we have with Glass Wall. We already retired about 220 tons for 4 projects with Glass Wall. I would like to thank their visionary. And of course, silicone is not a big element compared to aluminum and glass, but still every step counts. What is also more important is silicone structural glazing is using less aluminum, right? So that it was mentioned before. So because of the silicone, we actually lower the embedded carbon for a project, including as well on the operational side. I want also to mention the arrow in the middle here, which is my next 2 slides, which is 2 projects that we have with clients which are related to circularity. And I thought it was a good thing to share that with you because it's a trend that we see globally. The first one is the work that we do with Citibank, where the idea here is to basically recycle 2 floors of the full renovation project of Citibank. And here we have worked with Permastiliza Scaldable to qualify a manufacturing process that is viable and which is able to take old glazing. You keep the aluminum, you have a special process to remove a part of the silicone, and then you can rebond that with a modern glazing system, as you can see on the right. The difficulty of this one, actually the technology is proven. The difficulty is really on the manufacturing process. So I would like to thank Permastiliza and Scaldable for the cooperation here. This is also a very interesting project. It's in Zurich. We do it with Lüchinger Meyer. And the client here, which is a public client, was there, okay, can we actually recycle glass? Okay, this is 30 years old building, so same for the glass. The glass does not meet, of course, the modern requirements on fire or impact. So finally, it all ended up by the development of a special silicone coating that is colored according to an aesthetic that you need, and which is with a metallic mesh applied on the back of the glass. So in these instances, then about a third of the glass were able to be reused, reprocessed for a very high efficient use on the spandrel part of the building, as you can see on the slide. And of course, the interesting aspects here is that through this project, we work with the client to understand this full carbon footprint, right? So you can see the potential advantage of this technology. It's of course for the clients that are concerned about the reuse, the carbon footprint. it has, of course, a significant cost advantage if you can reuse about a third of the glass. So we are very happy about the project. We have 2 more. Of course, the Swiss market is a good market for us because they are very conscious. But I believe that even in market like this, not saying that we are not conscious, that the trend will actually come very quickly. And again, you guys are working with leading clients around the world. And I know that all of you receive, requirements for the big brands whenever they want to install a building. I think the building that was presented for Siemens is a very good example. So I hope I give you some trends on this low carbon footprint and the circularity trends that we are seeing globally. For us, it's important that we continue to work with our client. And as I said, R&D is very important. We have R&D capability in India. So please come to us. This is my last slide. I would like to, again, give a little bit more in detail. We have 1,500 direct employees in India and a few hundreds in indirect. We have manufacturing, engineering. More important for me is we also have R&D and manufacturing, right? So for any of the questions that you may have on this presentation or on cold-bended glass or the durability of silicone, the warranty that we are giving, the system warranty, please come to our booth or contact any of our team members. And on that words, I thank you very much.
Thank you, Jean-Paul. Welcome back, ladies and gentlemen. Let's welcome our next speaker, Pradeep from Kinlong.
So, good afternoon, everybody. Myself, Pradeep. I'm representing Kinlong and I work as a design manager there. So, today I'll be talking about how we can look a facade a little bit different way. And before that, for those who don't know about the Kinlong, I'd like to introduce Kinlong through a short video. We have a 2-minute video.
Welcome to Kinlong, a global leader in architectural hardware. With decades of expertise, Kinlong has redefined the construction industry with innovative solutions and world-class craftsmanship. From urban high-rises to modern commercial spaces, Kinlong hardware is trusted for its quality, reliability, and unmatched performance. With bespoke solutions tailored to project-specific needs, from sourcing raw materials to delivering the final product, every step is guided by an unwavering commitment to precision, durability, and excellence. Our advanced manufacturing facilities combine precision engineering with cutting-edge technology to produce hardware of exceptional quality. Quality is the foundation of everything we do. At the core of our innovation is our expert design team, transforming ideas into reality with detailed 2D and 3D drawings. Our solutions have been instrumental in transforming skylines and contributing to iconic projects. In our advanced laboratories, we conduct rigorous testing on every product. From wind load simulations to corrosion resistance and structural durability, we guarantee our hardware meets and exceeds the highest international standards, delivering safety and reliability that architects and builders trust. Using the latest design tools and software, they ensure seamless integration of our hardware into modern architectural projects, addressing both functional needs and aesthetic aspirations. Kinlong's diverse product range includes doors, windows, facades, railings, spiders, cables, and glass fittings, among other hardware solutions. Each product is meticulously engineered to blend style with strength, creating structures that are both functional and visually striking. With a strong focus on sustainability, we are committed to supporting India's growth with solutions that respect the environment and build a better future. Kinlong, redefining architectural hardware. Excellence you can trust, performance you can rely on.
So that was a small introduction about our diversified hardware manufacturers, whatever we do. And then coming back to the topic, this is our office and warehouse setup, which is located in India. Then coming back to the topic, so today I'll be talking about the facade element, which we can look at a bit different way. That is architectural steel facade, what we call. So we all believe that facade is a kind of a skin or like cladding which we do, and it also has certain aspects to be considered while designing all these things, and to make it more aesthetically appealing. That is where when we feel metal comes into the picture, and that is why we are using metal structure as a supporting element to the facade here. And so whenever I just want to give you a comparison between the conventional glazing system what we have. So most of the facades, the aluminum glazed facades, what we see is having a repetitive grids, and then most of the times when we are cutting down the cost, we will have to compromise on certain aspects when we are working on aluminum, but that doesn't happen with the steel structure facades. So I'll be discussing more about it. And this is one image where you can see supporting structure is of steel which is made, not aluminum, and we can manufacture this particular product in different grades of steels, that is Q235, Q355, and when it comes to SS, it is 316 and 304. And we also give a warranty of 30 years, up to 30 years, because it depends on various coatings what we use. And the system is also fire rated and PMU tested as well. So an advantage when we use metal here is we'll be able to achieve a slimmer section and more sharper edges, because these sheets are all laser cut, welded together and formed based on the project requirements. And here is a few advantages of going on with metal structure. So we'll be able to manufacture this with a wide variety of colors, and if it goes with stainless steel, we'll be able to manufacture with different finishes like mirror satin and then a wild green. And those prototypes, what you see are how the vertical mullions and the horizontals are being fixed for the facade. And at the bottom, we have various available sections which can be used for different projects as per the requirement. And these are few accessories we supply along with the steel profiles, so that we can be a one-point supplier, and you don't have to go with different vendors for different accessories. So this is just one nodal detail, and how we can make all the visible, especially the visible elements, make it go hidden inside the profile. So whenever this facade is installed, it have more clear and then hidden accessories. So these are different profile types, what we can use it for the facade and glazing systems. And this is one prototype where we have kept it in our stall also. Like if somebody is interested in knowing deep about these products, like you can join us at our booth, and then we'll have more conversation on that. So in this picture, you can see the outside view of a facade and the inside view. This is just a toggle system. And we also have a system where we can use a cover cap or pressure plate, what we call. On the back hand side, you can see there is just a clear lines which is cleanly defined, and no visible hardware like screws, fasteners, or splice joints. And this is our welding machine. See, basically this machine is of marine grade welded. First time we are using in our industry for facade hardware manufacturing. And the limitation of this particular welding machine is somewhere close to 22 meters. And since we are, that tells like we'll be able to manufacture a single mullion of length, probably maximum 22 meters. But due to the limitations during transportation, we'll be allowed to ship approximately 11 meters, one single length without splice joints. And since the laser cutting technology is used, there is no sharp burst or any undulation in the weldings. And to talk about the installation, I'll be just going on with the project on how we did the installation. It is just a simple installation where top and bottom bracket will be installed at the side after the survey, and then a vertical mullions goes in and all the related accessories will be fixed. And for a contractor, it is just an easy job to bring the glass, fix it into the facade, and then fasten few screws and apply the silicone joint. It is that easy and simple. And this slide is a small comparison of aluminum facade and then the stainless steel or steel facade, where we have used a material of 355. for an example, if you take up a facade of span of 10 meters height and then 2 kb of wind load, and then where we have a glass width of 2 meter, each panel width of 2 meter. If at all, if you're going with steel, our cross-sectional size of the box section, what we use is going to be 216 to 18 to 12 on 8 at 12 mm and 8 mm of the wall thickness. And if at all, if we are going with the same thing with aluminium, the section size is going to be almost double, like I say, 400 into 120. So here we'll be able to optimize the section size. That is one advantage, because we will not be going with the bulkier section. If at all, if you have to go with aluminium, it's going to be a bulkier one, and it is not so easy to extend the 400 mm depth profile. That is why an premium alternative what we can look at is at aluminium, stainless steel facade, which is also cost optimized. You can see the costings on the screen. That is, if at all, if you are doing with aluminium, it will be 1060 USD per meter per piece, and then if it is with stainless steel, it will be 960 USD. And one more advantage with this particular system is every project, these mullions are going to be customized based on the structural requirement. It is not that we follow a few specialized profile sections from our catalog. It doesn't work that way. So that is why we have no MOQ. So every project we can customize, be it a small or big or medium scale. And then, as I told, the maximum span is of 18 meters. And we have a liberty of designing it in any type of supporting structure what we can think of. So I have few project cases which I want to show you, which is done mostly abroad. So this is National Cyber Security and Talent and Innovation Base, which is in Shanghai. Here the project is installed with the vertical mullion, which is made up of stainless steel and mirror finish. And this is one project which we have done in here. Then I just want to take you through the projects which we have done, various photos. And these are noted details. In this particular project, what happened is we had a challenge in the curvature at the bottom of the area. So we proposed 2 models, and then the entire unit was manufactured as a unit from our factory, and then it was supplied to the site. So it made installation much easier and more accurate. And this is how we work for different projects. Like when we get an inquiry, so we propose multiple options, and then the nodal details, the corner joinery, the water seepage, drainage, and all these things will be considered. And a small mock-up, which I showed in the earlier slide, a 3D mock-up will be sent out to the client for the approval. And then later, it will be, the manufactured products will be sent to the site, so that there will be no trial and error method which we follow usually in the site. So it will be easy to install. This is another project where we had a joint where we had to use silicone to cover it up. And this slides, it will show you like how we do the packaging and all. Even the packaging will be pre-planned. If at all, if you see the first photo in the middle, you can see the internal insert is made up of Q235 material, but then the outer covering, you can see here at the bottom picture, this is a 5 mm thickness of stainless steel, because the client wanted to have a stainless steel finish on the facade. So to optimize the cost, we have used a steel insert and then the stainless steel covering on the side, and the entire panel was manufactured as a grid and sent out to the site. So these are various projects. Like I told, we'll be supplying those kind of sample mock-up for the approval before we execute the actual project to the site to see what are the challenges. Because even before supplying it to the site, we want to understand what are the challenges the client is going to face during the installation. To make it more easy, we do a mock-up at our factory. And the last project which we have recently done, it was with the help of the architecture from Architectural Dialogue. So with them we worked out, and then this is for a developer called Bashium in Chennai. This is the Sales Experience Center, which is recently completed. I think the photo is still not clear. It is still under construction. Here and there are small works are going on. So the longest span in this facade is around 11 meters, and this is one project we have recently executed. So that is all about architectural steel facade. If you have to know anything more about this product, we are there and my team is there at the stall. You can come and connect with us. Thank you so much.
Thank you, Pradeep. Let's put our hands together and welcome Dr. Anup Nayak from Urban Frame.
Good evening, everyone. Thank you for having me here. It's an honor here. It's an honor to be here today and to be speaking on a subject that is far more than, I would say, surface deep or skin deep. And the facade, I think, often mistaken as the building's decorative skin, is for me personally is actually, there is a performative element in architecture, and I believe that's what it does. But it goes beyond that. I feel that the narrative today, which I want to place in front of you all, is that it is not just a boundary. Sometimes you misunderstand it for just a skin, but for me, I believe it is a threshold. And it's a threshold between what I call as the private and the public, between the built and the environmental, between the perception and the experience. So that's where today our conversation will lie around. And I've broken it down into 6 dimensions of conversation. I feel that it's important for us to see it in light of these 6 dimensions. The first one is filtering. Then we'll look at what the cultural signaling it gives you. We'll look at what the emotional response facades have. We'll also look at technology. I'm sure a lot of it has been spoken about today. But the idea, it was important to set the narrative on that basis. There's a dimension of ethics. I feel most often we forget that. There is a dimension of it which comes from the domain of its urban interaction, and I feel that is really critical when we start placing these objects or a product in public space. With that said, let me take you to the first dimension, that is facade as filters. And the idea is to look at it as a transitional member, as a membrane. So what happens in this process is that in extremely climate-sensitive geographies, the facade has a process of being a membrane, but it has a different narrative. I think it has the proposition to breathe, it has the proposition to respond, and I think it works as a filter which kind of connects climate-sensitive geographies. So that's the first key indicator for us. Now, what it lies in the conversation today is that it doesn't divide, but it actually mediates. And most often when you look at conversations of what architecture and space does, I feel that's very, very critical. Whether it is low-tech or whether it's high-tech, I think porosity is the key intention. Now here, if you start looking at a project done by Studio Mumbai, this is their project called the Almeida House. It's very interesting in how the architects have actually looked at the conversation of the space, its narrative in actually looking at as a membrane, and how it starts mediating. So eventually, the layered bamboo screens, if you start looking at here, works like a filter, which kind of works for humidity. Sometimes it takes in the humidity in some cases, and there is this ability for us to be locally rooted. And I feel sometimes in this universal sweep, we kind of miss that localness in the piece of what this threshold works. It also comes from another point. If you take this institute degree one day in Khanna, this is done by architects Pierre Sarai and Gilbert. So what happens here, though, is even if it's in a very strong urban space, it has a very powerful statement. But what it does, it actually picks from the local context of how the mashrabiyas were used, right? And this is what is the response. So sometimes it could be tech-driven, but actually it responds to the localness of the place. I feel that that conversation of what facade does becomes very, very important. In this case, the diaphragms work as which control lighting, so it becomes sensitive to that. So there is an active dimension to what it does. Now, I would leave this as questions for you, not that I have answers, but I thought I'll leave this as probing questions to you. Is in the age obsessed with transparency, and that's what we're seeing all the while. I'm saying from the morning to now, we've actually picked up on this whole notion of transparency and transparency. The question is, what do we choose to filter and why? I think those are fundamental questions for us. For me personally, filtering is not hiding. It's actually the idea of curating experiences. So that's the first dimension. Let me go to the next dimension. This is when facade as a cultural interface. And this happens from a point that facades, I believe, are the cultural canvases. Facades tell us who we are, where we come from, and what do we want the world to see. So I think that's the dilemma what the facade has. They carry tradition, I believe. They carry pride. They also carry dissent. They also carry aspiration. So in many ways, it kind of plays multiple roles from where it comes from. With this said, I'm sure a lot of you know this building, and I'm sure a lot of you also don't know why this was done. Right? It's interesting, when Frank Lloyd Wright was assigned this job, he said that he wanted to move away from, he wanted to look at this as a rebellion to how museums were done. So the manifesto of the project was to look at it being a rebellion to the normal projects of what museums were done. So you understand how it moves, right? So facade, no more, it's not talking one side of it, it's talking other things, but there is a very clear-cut manifesto in that process. Similarly, this is the Kanazawa library. It's very interesting here. I'm saying it might be very simplistic in what it feels, but it goes back to a very minimalistic point of view from where it talks about these small circular windows actually come from the Japanese paper patterns. So you see the cultural relevance and its rootedness, right? So it's not actually whitewashed in that sense, but it comes and connects you back at the bottommost point of being connected. But this leads us to actually a probing question. And so the question is that what happens when the facade is stripped of its culture, left to be just another curtain, glass curtain? For me, it just becomes a mute wall in a noisy city. And I think that's what is really alarming of where we are heading towards. Facades tell us, for us, who we are, where we come from, and it actually elaborates clear-cut stories. So most often we don't hear these stories, right? We only hear it as technical, tectonic membranes. So I feel that storytelling becomes really, really critical. Now we go to the third dimension. That's a psychological and emotional boundary. And most often we ask why. And it has this whole dimension of human anticipation. And I believe that that is your first encounter, right? Even before you experience anything else, that is your clear-cut first encounter. And this influences how you behave, what you feel, and the way you belong and where you belong, even before you step inside. And that is what the emotional boundary is. Sometimes it actually overwhelms you. Sometimes it actually roots you very strongly. And I'm sure that you have experienced this, that you felt some different emotion as you navigated through these buildings. So there is that conversation. It is an experience. It's very difficult to explain it because I'm sure each one of you will manifest that experience quite differently. Now, if you take this building, the Thermovals in Switzerland by Peter Zumthor, what is the elevation story, right? What is the facade story in this, right? But it comes from how beautifully it is rooted in its context. And you see the hill slopes, the heavy stone facade, and the way it merges with the alpine slopes is the sense of continuity, is what makes it grounded and what makes it timeless. Now, with that said, I'm sure a lot of you know this. It's the Jewish Museum, it was a competition, and Daniel Lipskin and his company and his associates won this competition. And it came from the idea of oppression and being hurt. But I think it's a very clear-cut articulation of the architect to actually look at a zinc-clad facade, which had a lot of the jagged slashed edges. You would see that running right through the crisscross of the building. It starts from the facade, goes into the plans, and navigates itself further. But this is about, it evokes this idea of rupture, it evokes the idea of trauma and memory. I think that's the story which this project will tell. Now, with that said, the probing thought here is that what if the facade was treated like a screen, more like a psychologist? So imagine now you have to start looking at designing facades, believing that you're a psychologist, right? So that's the challenge you will anyway have. For me, it is personally an architectural handshake, and I think that's where all the emotions of a project start talking to us. Then we get into this where facade actually works like a technological threshold. A lot of conversations have happened around the technological threshold today, but for me, I believe that these are intelligent membranes. They respond, they emote, they perform, they contain the architecture, and they co-author its performance in real time. So there is a real-time dimension to it. So this means that technology actually drives human experience. And I think we are at that cusp of high innovation nowadays for us to take a step back and see that does it actually respond with empathy, right? So I think that's a key function for us today. This is the Al Bahar Towers done in Abu Dhabi. Here, you'll see that, again, the traditional mashrabiyah. So you'll see how the connotation from the earlier project to now, the idea of the mashrabiyah itself is modified and reimagined as a dynamic facade. So that's the beauty of this, that there is a possibility of high interpretation. And it reduces, and surprisingly, and I think through conversation, through researchers, it actually has reduced the solar gain by as much as 50%, or reduced the solar gain, by as much as 50%. So what was old, what was modified, what was actually reinterpreted today is what drives this whole aspect of the membrane as a facade, as a technological threshold. This is another project done by Enric Roos, that's the media TIC in Berlin. This is, they've used the ETF pillows in this project, and that constantly kind of modulates the light coming into the building. A very simple, dynamic design, but actually kind of creates a human interface completely different inside. It actually is responsive at real time. So it's constantly working with you on real time. Now, the question again for us is that if the facade has become a machine, what does it make an architect, right? I'm sure, I don't know how many architects are here, but for all the designers at heart, are you a choreographer? Are you a coder? Who are you in this process? For me, and I believe that you're still a poet at heart, and I think that's what is critical. But we must not forget that we're all driving human experience in this process. So for us, it is about how we respond with clear-cut empathy. Now let me go to the next dimension. That is the ethical boundary. A lot of conversations have happened. I think this is a subject matter on its own. But I think it is important for us to raise this question today of the ethical boundaries here. For me personally, because all this notion of climate change and what's happening around, I think there is an ethical decision which we need to take when we start looking at facade. What material you're using, where does it come from, and what is the embodied carbon it carries. Now, if you take this project, it is the Anandaloy building. I think probably as rooted as what you can get. And hats off to Anna Heringer for actually piecing this architecture together. Yeah, it looks like if you go to rural Bangladesh, you'll find similar architecture. But what it meant from an ethical standpoint was to start looking at the idea of inclusion. And this was inclusion especially with women with disabilities. This whole project was done with women with disabilities. And for me, this is just not a building. I think it is an act of empowerment. I think where do we do this in architecture today? I think this is the response which we require to actually start looking at high inclusion, dignity, and local scale. I think this is what becomes very, very critical. This is another project done as a pavilion. And for me, this is quite a freaky project because it actually draws you back into the simplicity of rootedness. This is a living hi-fi pavilion done by David Benjamin. Here it was made completely of biobricks. The idea of this and on stalks, and it actually completely decomposes itself. So what the principle of this facade was to return back to earth. So that was how fundamentally it was looked at. Because as in today we say give life, give life, give life. But this spoke about an antithesis of saying, please return back to earth, return back to earth, and return back to earth. I think that's where this dilemma of ethical boundaries lie. Now, I did mention that the idea of how much carbon it embodies, all of that is fine. But I think for us to be looking at, in this world which is completely greenwashing, I think it's important for us to be honest, sustainable, and just as local as possible. Now, the last one, it is on urban narrators. And this is where all our projects will finally lie, right? We can't. It's not like doing some project where you can put it in your back pocket and walk away. But these all lie in the domain of the urban. And this is theatrical. For me, the city's experience lies in what architecture holds, right? It's what the facades were. It's the choreography of life. And I believe that the pieces of architecture we leave or the facades we work on are participants in the city's theatre. So for us to look at that side of what facade does in urban narrative becomes important. A lot of you would have experienced this. These are the poles of Ahmedabad. But what happens here is that the community takes up the stage. The facade actually blends with what is happening around. And this becomes part of the everyday theatre. And that's what adds to the dynamic of it becoming the urban narrator. Now, with that said, this is another project in Paris, Rio du Rivoli. And in this, you can see that the urban classical form, the sense of continuity, and the visual rhythm was very, very theatrical. And what happens was that the facades then become part of the civic context, right? It becomes part of their contract. It becomes part of their daily engagement. It's part of what it offers to the city as scale and elegance. Now, the probing question again to all of you all is that if you mute the city's facades, and what remains? But tomorrow you will not be arguing out why Dubai, Abu Dhabi, Singapore, Beijing, Shanghai, Noida, Bangalore, name it, they all start looking the same. So, if they're becoming the facade of the city, it frames the streets, it actually sets the tone and guides us as an act of public space making, and not necessarily the act of actually making a facade. So I think that's how it starts becoming very, very relevant. Going back, facade, I believe, is the beginning for more than one reason. It is not the end, and I believe that it is a complete beginning. It is its first breath. It's where ideas confront with reality. It also goes back to, as architects, and the responsibility is to what to reveal, what to protect, and how to care. And I would leave this thought with you that as designers, as citizens, as thinkers, we no longer ask, how does it look? But every contract we work, I'm sure a lot of architects say, give me wow. I'm saying, I'm sure a lot of you would have heard this over and over again. But I feel that there's another question for us to ask here. What does it let in? What does it keep out? What story does it really tell you? And what gets to stand at the threshold? And I'll just leave this with you that I believe that the facade is not where architecture ends, but where architecture actually begins. Thank you so much for the patient listening, and hope it has been good enough to provoke you all, even if it's the end of the show. Thank you.
That was a very introspective and meaningful presentation of what a building really says to its user, its human connection, the inclusion of local skill. I think it's left us with something to think about, some emotional anticipation of what we are really trying to achieve in our built environment and whether our buildings interact well with the public space. I would now like to welcome Kushagra Ashwati, Head of Engineering at Stuco, and all the esteemed panel.
Okay, I would like to welcome the stellar panelists for this facade event. May I please call upon Mr. Kumar BS, Project Director, Evermark Facade, to come on the stage. Ms. Hana Raghunath, Head Design, Space Matrix, to come on the stage. Ms. Charanya Prem Kumar, Associate Principal and Director, Vernacular Associates, to come on the stage. Mr. Nishant HH, Director, Design and Operations, ADM Design. Ms. Amuda, Director, Turner and Townsend. And lastly, Ms. Neha Murthy, Sustainability Associate with MACD Bird. So today's discussion is on the facade technology and future of smart buildings in India. And in this panel, we will delve into the intricacies of the facade technology, the route from where we came from, and we will explore the future of the smart buildings in India. And we'll try to trace the journey from pre-design phase through design, execution, post-design, and culminating into look at the future trends. So that's the thought process. Please take a seat. So with this introduction into the facade technology and the future of smart buildings in India, I have divided into three parts, the entire panel, entire session. First, we will be discussing majorly on the pre-design stage, to design stage, right? And then we will speak about post-design, which is basically the execution and post-execution stage. And the third part will be the future trends that we see, okay? So the first question is primarily to the architects in the panel here. We already saw in the previous presentation, and it was very thought-provoking. It somehow goes in the same direction, where we are talking about how passive design strategies play pivotal and multifaceted role in shaping future buildings and facades here in India. Maybe I'll start off with you. You are close to me.
The passive design strategies are very crucial in any project, for that matter. So it creates a platform for the mood of the project per se. And it starts off with your zoning and your building orientation and your building envelope design, or even your landscaping, for the matter, to create a kind of a microclimate. So it sets the mood to actually use all our natural energy sources. So when it comes to our envelope design, so we decide on the sun path and what daylight we need and which orientation it's going to suit us best. So keeping that in mind, we kind of make the project more effective by not tapping out artificial sources and having our natural energy sources to feed into the project. So that is the basic of any kind of a project or thing. So that's where the passive strategies come in.
Okay. Any thoughts from you?
Should I?
Yeah.
Okay. So we work closely with architects. So it's great to see many architects who focus on passive strategies. So once we focus on these passive strategies, half our work is done. So this building facade is the envelope, and like Mr. Anup just mentioned, it's the threshold, which is not just a boundary, and it has two functions, and both are slightly contradictory. One is we need to protect the indoor from the outside environment which may become harsh at certain points of time, and also we need to let the inside interact with the outside. So there are two things that you're trying to do. So this passive strategies like orientation, like she rightly mentioned, is very, very important. And also how much of the glazing are we really putting on the facade? Is it proportionate to the amount of facade that we're actually creating? How are we shading and cutting down the heat which may overheat the building inside? So all of these are important parameters. And just by these, passive strategies, we can actually bring down the energy consumption of the building by 30 to 50%, which is a great thing. And I think all architects should definitely look into passive strategies.
Nishant, your point of view?
By Mike.
Yeah.
Passive strategies and the facade design go hand in hand with each other. So passive strategies kind of set the stage for the facade to come in, and they have to kind of play together. So, for example, there's no point in me putting a lot of glazing coming in from the west when I know it's going to be heating up my building, and then trying to solve that problem at the facade level. What I need to do is to solve it at the passive design stage itself, in the basic planning itself, get the stage right, and then the facade comes and they all kind of work together and make the building a lot more sustainable. So absolutely important to for the facade and the planning and all the passive strategies to go hand in hand with each other.
Fair enough.
Yeah. Hi, this is Nandakumar, facade consultant. I'm the only consultant here in this panel, I think. So the architects basically sets the tone for like when we start the design. Mainly we are talking about the passive technologies and the passive approach what we take. And as a consultant, so we are looking more into the engineering part of the project. So nowadays the projects are getting more and more complicated. The projects are huge and all that. So we work with the architects, and nowadays there are lead consultants also who are coming for the project in the initial stages. And so the inputs are given for as you told, the orientation of the building, different material use on the facade, mainly the green facades, the pins and the orientation to cut the heat, and all these things are there. And so we as a facade consultant, we have to accept that and design the engineering part of it. And I feel it's very important in today's buildings because the buildings, so also we have to look at the maintenance point of view. So we think so that also. So the passive technologies which are used in the buildings cuts the heat mainly, and it's a kind of a give and take. So you give more of a solid surface, you lose on light. So we will have to balance both. So it has to be designed hand in hand with the architects, lead consultants, and the facade consultants.
Right. Susanna, any thoughts?
So we moved from poetry from Anup's side straight to brass tacks. I believe very strongly in passive design principles for a building, and I would just like to say one thing which I quote Deepa from EDS Solutions, who said that in this era of designing for the planet and with healthy buildings being like one of the most biggest priorities that we need to set, a passive building makes a user active, and an active building makes the user passive. I think I rest my case.
Okay. Anyway, Muda, I mean, if you have something to add here, because we have spoken a lot about, this same topic here.
Just one thing, just on a user perspective, I think we will be agnostic of sitting near the windows, but because of the passive architecture that's coming in and facade elements coming in, now everybody is willing to or wishing to sit close to the windows. Probably that's also getting into the wellness of the user.
But I mean, that's a different perspective from a user, and I appreciate it, really. Okay. The next question also goes in a similar line. It's not really into passive design strategy, but it's being connected to the, from the local context and the heritage. So is contextual harmony still relevant in a new age futuristic facade, where architectural expression and in material aesthetics, they have different definitions now. So how do you see, the new age futuristic facades? Are they really connected, or they should be connected with the local context and the heritage?
So contextual architecture is very subjective. So first, it is defined by the typology of the building, and then the user perspective of it, predominantly the client. So if it's a public building or an administrative building, contextual architecture will make total sense. It's more receptive because of the culture and the heritage, and it's more welcome in the society, and it doesn't jar with anybody's mindset. But in reality, when you see contextual architecture, I will not be able to apply it to large scale. Like as in if it is not a public building and it's a very for example, a builder-oriented product. So it involves a lot more nuances, wherein the material has to be tweaked. So that's something where architects, I feel, should be conscious enough and bring in certain elements, like how Anup had put in, he bring in certain frills and elements and not lose the culture and heritage of the projects per se. This is my take on it.
Okay. Any thoughts? I mean, I will not go, in a sequence. I will just keep it.
I think responding to the regional context and having contextual architecture is absolutely important. Otherwise, we have buildings which look the same across the world. And then what really sets the tone different? How do we identify a building in Bangalore and say a building in Delhi or building in Goa? How is it different? So I think it's absolutely important that we respond to the local context. Now, it could be done in various ways, and that's the expression of the architect. But then, say a large office building will require a lot of glass surface because you want the light to come in. But then there could be a second skin which responds to the local context. The materials that we use can respond. So there are different ways of doing it. But yes, we should be responding to the local context. It has to be done that way.
So what I have seen, the trend is like we had this traditional buildings, and last couple of decades there were only glass buildings. So when there is a new commercial building coming up, it was mostly done with glass. But last, I think, at least last 4-5 years, there are different materials tried, and which gives a look of the traditional buildings. And also, you can't do the construction as it was done 30-40 years ago. So there are you don't have that skill sets also now. So new machineries are there to install these new materials, which complements and gives a look the look and feel of the traditional building. So that's a good thing.
I think it's important to understand what is the context that we are talking about, right? I mean, context is a highly nuanced subject. It's not, if I may say, when coming from where my background is, when at Infosys Infrastructure, when we designed certain office buildings or in Tier 2 cities or something like that, one of the points was that, hey, this building had to look aspirational. It's not that we achieved everywhere. I mean, of course, we had our own a very tricky adolescent stage, as I say, where our buildings did look very strange and weird. But one of the main points was that buildings had to look aspirational in the way of saying that if there was any new upcoming, one of their first jobs kind of thing, they had to look something which looked a little beyond what their regular or what their immediate surroundings was. So our buildings did look slightly futuristic. Our buildings did look something which did ape the West. But that set the context because that was important to achieve that. Okay, and when it was an identity of a campus coming in the 80s and 90s, where companies were opening these large, campuses of IT, it made sense at that point of time. Of course, much can be deliberated, much can be spoken about as to why did we have to ape the West. But that was the context at that point of time. Did it make complete sense? Perhaps not. We did err at certain stages. But when we are talking about context, it really is important as to how we define that context as. It's a highly nuanced subject. Sometimes as architects, we try to do our best. We succeed. Sometimes we don't. I think Anup showed a lot of cases where we did succeed.
Actually.
But I do believe there's hope to achieve that, and a little more introspection will help there.
Certainly. Okay. Any point of view? Yeah.
I just want to add a point there. I think context is nothing but the climate. So the reason why all buildings are looking the same everywhere all over the world is because we are ignoring the climate. I think it's very important that we design for where the building is sited. And respect all of the environmental parameters that are around that building or that environment. So the kind of materials we choose and all of this is depends totally on the context, to source locally. And I think to sum it up, where that debate always keeps coming up, should function follow the form or form follow the function? I think Charles Correa said it beautifully, architect Charles Correa, that form should follow the climate. And I think that says what context really means to a building.
That's beautiful, because my next question is in a similar line. And I completely agree. I mean, both the passive design strategy and, this contextual harmony has to be there. That will make the buildings unique to a certain region, having this similar kind of climatic region. So I'll just go to the next question where, what will be the key drivers, for the smart facade technologies in India's rapidly developing urban landscape. And here, it's the same thought I want, you have to think about the energy demands. You have to think about the urbanization, how government initiatives and desire for sustainable buildings. What are really the key factors that you see? Yeah.
So I think the first thing is the key driver is the end user. So, for example, end user, if there is a very big investment bank or company like Google or somebody occupies a building, so they have certain strategies for their green requirements or leads. So that drives the design basically, and also the budget. So that's the most important thing.
So you mean to say specifications and cost?
Specifications and cost, yeah. Okay. Specification based on the user requirement and the cost. I think these are the two key drivers from my point of view. But I think
that's what even I see when it comes to me, because that's the only two things that I get to see: the specification and the cost. And of course, the design is by the architects. But yes, I mean, it's very true. I hope that all these aspects of energy demands and how the urban, how actually it will affect the urban climate, and how it is complying to the government regulations and the new policies that the government is implementing, and how sustainable buildings that we want. So these should be the key driving factors when we are thinking about a smart, futuristic, buildings in this urban landscape. I'm not talking about the tier 2 cities where stories will be a little different, right? Tier 1 cities, they have a different challenge, they have a different energy demand as compared to a tier 2 or tier 3 city. So we are still not there in tier 2 and tier 3, but the time has come to really think about, tier 1 development, the urbanization which is happening, right?
To add to that, traditionally we were always sustainable. I think somewhere along the way we just went off track. And now there is a big drive to start getting sustainable and come back to the roots and basics again. And that drive is coming from a lot of end users driving it. There is a lot more awareness today in people. And I think everyone is aware of it, and probably media is also responsible for that. In a way, the government is also pushing for it. They want to be completely net zero by 2070. So the policies will shape up the buildings that we are designing.
Yeah.
Kushaka, apart from policies, apart from where we are with respect to embodied carbon, where we are with respect to what the country is achieving in whether it is 2070, 2030, and so on and so forth, what we were discussing previously. I think it's important as a designer, what is it that we are putting first, prioritizing. And one of the main things is that it's high time we design, keeping the user, of course, human-centric design is important, but then for human comfort, but then how far can we go is always a question. And I think a blend of planet-centric design decisions and human-centric design decisions are very, very important. And it's a blend, I believe. And there is we're already quite late for the 1.5 degree thing, right? I mean, so it's not really a question of form follows function, whether a design needs to look futuristic, not futuristic. Let's put that apart. I mean, I think we just so far off into this mess that we have to take certain decisions as to what are the materials that's going in. Take a little more time into seeing what is that embodied carbon of every material that's going in. Is our facade systems good for assembly and disassembly? Is recycling the only thing that we are looking at, or can we do something better? I think these are far more important questions, I believe, right now.
Yeah, I completely agree with you. I mean, the end user has to use the building, right? Person is spending 90% of time inside a building. Even now we are inside a building, right?
I mean, that
in office.
We're an indoor species, right?
Yes, and only 10% I would say walk in a park or maybe in a car. I don't know. I mean, that's.
I think user experience is what defines if the project is successful or not successful.
Yes, I agree. I agree completely. Yeah.
I just want to add to Nandakumar's point, because he touched upon budget. This is my favorite subject. Exactly what happens is we do have a budget to start with, be it whatever client it is, whether the client has a high investment or a low investment or whatever investment is. We do have a budget, but what ends up and what affects most of the architects, end of it is the value engineering, because we are not within the cost, we are not able to meet the numbers. So can we do value engineering, and then the specifications get cut. So I think it's very important we keep that in mind as well while we do the facade.
It's
normally so when we work with the developers, I can tell because there is no developer in this panel. So they have a fixed cost, like per square feet on my like leasable area. This is my facade cost. So what happens for they would have done an exercise on a particular building, and they would be like last 10 years they would be following the same thing. Nowadays you have a different shape of the building, so different requirements. Now, so like for example, the LEED requirements have gone up, the sustainability requirements have gone up, but still that cost is like per square feet, this is my spend. So we will have to place the facade within that cost range. So that becomes more difficult.
And what is the rough number that comes to your mind?
So it depends.
It depends on how many ticks I have to, offer.
Yeah.
How many points, how many lead scores.
What their value or their lease value is at.
But I think if the will is there, definitely the cost is something that the end user wants to take care of. Like we have the largest smart glass installation in Bangalore, the Google campus.
Yeah.
Is the world's largest smart glass installation. So we have it right here in India.
Yeah.
If the will is there and the drive is there, the cost will also be taken care of.
No, that is, yeah. So that is where I think we need to get the balance between how we do a efficient facade design, and we are which may cost a little more, but we are able to achieve a payback by energy savings. Your consumption bills are much lower. You are cutting it down by, let's say, 30 to 50% in a few years, 5 to 10 years. Then I think they will definitely go for the extra investment.
Yeah, I agree. I think the narration is very important when you choose a particular facade material or what kind of facade you're talking about. It's never really about cost per square feet of that particular time, but it's important to put in a narrative saying that, look, if you choose ABCD kind of a system, in your operations, this is how it's going to be. I mean, there is, of course, with simulation right now, and at this stage, we can definitely come up and say that these are the kind of savings that this kind of facade will give, and this is the kind of savings that the other kind of facade can give, depending on what you choose and what you pick. This is something out of experience that this makes a lot of difference to an occupier or to a builder or to a corporate client. It definitely makes a big difference. I think that narration is important, that as architects or as designers, we leave our willful ignorance and then actually move on to educate ourselves to do that. It's really important, I think.
So, valid point, absolutely valid point. It made me think that this multidisciplinary approach for a successful building or futuristic building. So, I mean, you think that a better collaboration between the architects, consultant, MEP engineers, and so on is going to address to this issue of cost and aesthetics and everything.
Yeah, absolutely. See, a systemic approach towards buildings will definitely yield better usage, right? And a better usage means better returns or ROI in the longer distance. Co-creation or collaboration between not just architects and engineers, that's like an absolute mandatory thing, but then even between a user and say a material manufacturer can yield great results. I can give you a small example. While I was at Infosys, Infosys had this co-creation kind of a module with Govind class, and then that collaboration resulted in such great products because it was about always talking about the performance. The criteria was always about performance. It was not about cost, it was not about it can be anything, ROI or whatever it was. It was about if this facade system, the whole system, can give me an A kind of a performance. So what came out was fantastic. The kind of glasses that came out with respect to VLTs, to the heat, the kind of coatings that they came up with, and it is quite evident in the performative indexes of the different buildings that Infosys currently has. I think another interesting point was on-site filling of argon gas in the DGU systems that was there. Also, on-site making of these DGU systems in some of the buildings it did work. Of course, factory made is preferred, but in certain situations that did help. So I believe that this kind of working together beyond boundaries always will result in better outcomes.
So it depends on the project as well, because so I can give you. We are working on two different projects. The one project is developed by the developer. So he is going to build the project and he is going to lease it to some other company. So he is not investing on the power or the electricity and the HVAC and all that. So it's ultimately taken over by the end user, the occupier basically. So there, the question of this spending more and ROI, so he really doesn't think about it. So we are working on one more project where he is also a developer. So he is made so he is prepared to, like he is telling that I will spend on the HVAC and the power and everything. So he is voluntarily asking us okay, what are the things which we have to consider to make it more sustainable? Like, okay, can we use the argon filling in the glass, or can we do some other materials? Can we do films or all this? So there's the two different things. So when there is a responsibility of like that ROI, the returns, when he thinks about that, so then it becomes more sustainable. Otherwise, normally what happens when we do a building, there is no occupier, so the builder doesn't know who is going to occupy, what is his, like where he is going to end up, so with whom. At that point of time, he is not that much looking into this aspect. True. The savings of the
what will also drive it is the end user requirement, because if the end users and the corporates today are driving the whole change towards being more sustainable and having a more energy efficient building, then all the developers will have to kind of comply to that. And if the whole market is demanding that, then if someone is not complying, this building is not going to get leased. So eventually it is going to become that ball game.
Right. So normally, so where I see this change might happen is, so where we have this like when this mainly the brokers who lease the buildings, like the IPs. So they are coming and they are doing the brokerage between the developer and the end user. So they should have a kind of guideline that, okay, these are the mandatory requirements to which, okay, this is like a grade A plus building, so these are the things. So you will have to follow this. So then that sets the requirement for all the builders to scale up their sustainability requirement. So I feel that will help.
Correct. The similar line, what I have also seen is when it is primarily built to own, then everyone spends money because they are owning it and they will maybe have an office there, or maybe they will live there, whatever. Then it comes built to lease, specifications goes a little down, cost goes down. And when it comes to build to sell, nobody is bothered.
Yeah.
Nobody is bothered. So that's how it is, the end user mentality, you also mentioned. Exactly. That's how the thinking goes. So maybe we have to change that.
So maybe there can be certain solutions which are approachable and accessible, which can help in retrofits, right? So perhaps the builder or somebody who starts building doesn't really think about the ROI of it and is not bothered about passive designs. But can your facade, a very basic level of facade, can it allow for retrofits? So that as a user, can I use them? Can I install them at a later stage? I think it's a good question. I don't have an answer.
We have solutions. Yeah? Yes, of course we have solutions. I'm not
accessible to and affordable ones.
We have also know that we have to spend a lot to have a very efficient facade.
Yeah, but
so if your basics of the planning is right, and your orientation of the buildings are right, you don't really have to go do that extra spend on the facade to kind of achieve all those parameters. If your basics are right, we are not building glass boxes and then trying to maybe shade them.
Yeah.
So definitely the cost can be brought down. So it starts with the planning. It starts with the materials. It has to be like, it cannot be like a very blatant use of glass. It has to be a lot more solid. and respond to the geography that we are designing in, the facade cost can definitely be brought down.
Right, yeah. So that goes to the next question. The similar thought, just carry the same thought. I mean, the simulation tools and the modeling tools that is available now. Okay, it's a very good point, Susanna, that is retrofit possible going in the future, but will it really help? Even if there is a retrofit, so can we simulate something now, show it to the builder, and then say this is the benefit that you might get? You know, as of now, if there are budget constraints, don't opt. But yes, I mean, can you think of this also going forward?
So there are some builders who are building to sell, who, when we know that they don't have a budget for it, and we do reach out to the marketing team, and this comes up with screening elements. So these screening elements are pre-designed with the modulation, especially for, where the light ingress is more and the heat intake is more. And we give them options. And these are actually submitted with their design agreements, as in their sale agreements.
Okay.
And we try to do that. Some builders take it well, some builders don't. So it's already started. It's just how I think as designers, we need to start putting things together, taking that extra step, considering we have a lot of building modulation and we have a lot of simulation models to be done. So yes, has been a start. At least from my front, we've seen that. And I'm sure we should all take it up further.
Good. Interesting. That's really interesting.
I think simulations are really helpful. All the software tools that are available. Because if we need to validate why we're really going for a particular facade design or the entire assembly, the way we want to propose it, these simulations help us validate the data. How is it really going to perform? And I'm able to actually look at numbers. And like Susanna was saying, we have multiple options to compare and see which will really work for me. How much performance versus how much cost. So simulations are really helpful. And I think we have great tools nowadays which help us, simulate various things like daylight, heat ingress, energy consumption, and everything can be simulated and put forth to the client to actually take a decision. It's very helpful in the decision-making process.
Right.
So to add to that, the simulations, of course, will help us in the design. So I think we need to also encourage the energy audits. So after the building is occupied, so once in say 2 years or 3 years once, there are energy auditors who are certified, so they come and do the complete audit and compare with what was originally designed and what is the actual results. So that actually help to improve the design for the future buildings.
Correct. So primarily the tool is used, what you mentioned rightly, Sneha. It's for predicting. You need some prediction, and then you can optimize it, right? And then third and last point is validation, which will further help us to improve the same cycle. You can better predict, you can better optimize, you can better validate, and the cycle goes on. So
I think today with also smarter facades coming in, that whole process is getting shrunken because it's giving us constant real-time data. So that energy audit is happening on an everyday basis.
Yeah, so the digital twins that we see. Yes. The sensors which is available, they are giving real-time data. And we are able
it's a real-time data and that helps you design and it's also predictive about maintenance of the facade and the systems as well.
Because when you do the analysis, there are few assumptions. So those assumptions are right or wrong, so you will be able to find out in the audits.
Correct. That's what even at my level also I can see that digital transformation that is happening. It has at least started. Of course, in tier 1 cities, it will take really long time to reach tier 2 and tier 3 cities. But yes, I can see it.
Bridge the whole design thought process to the analysis which is happening later. It just becomes very real time and on an everyday basis it's giving you that data.
Right. So we are left with 11 minutes and we have a lot of things more to discuss. Then I'll quickly jump into some execution stage or the post-execution stage. So we have seen that there has been a lot of crunches, in the sense like the planning was not so effective and we had labor shortage issues and we have on-site issues, and then again we have to speed up really fast for the execution, and we end up actually contributing more to the carbon to the building just because of this mess up somewhere happened because of labor shortage or some planning issues. How do you see, and how can we curtail it? How can we have some new methods to, reduce these issues?
What comes to my mind very quickly is two things. One is having a mechanized erection on site, and the second one can be a prefab panels coming in, right? In terms of labor shortage. But facade, as we're all aware, the facade is mostly a labor limited area or a function activity wherein we use more of mechanized equipments and tools in order to do the complete execution on site. So keeping this in mind, I could suggest that when we are able to have the facade, connected with the structural, the building, the base building structural activities, when you link that and then also link the schedule to it, you can optimize the logistics. And when the base building is getting constructed, you can have the facade also going in parallel and optimize the usage of cranes or usage of equipments on site. That with that optimization, we can also see the progress on site with if we are ending up with labor shortage, right? This is one thing. The other one is about the prefab materials that we can bring in from directly from the industry. I mean, from manufacturing. And there as well, we should think of a little bit more of having the panel sizes, which is long and wide, so that we can have, instead of thinking about 2 floors, we can think about 3 or 4 floors of a panel, and so that the progress is more, the timeline.
The speed is higher.
The speed is high, and you don't have labor to do it, and you will have the equipments to do the erection on site. So this can be done only when you have the glass panes that size, and we need to think about having such large sizes of glass or the glass panes. This will also help in the carbon loss. If you're not having any wastages, this will help in wastages, avoiding wastages, and also have manufacturing effectiveness. So these are certain things that we can do to bring in efficiencies in terms of progress at site when you have an issue in terms of labor shortage or any such mitigation that we need to do on site.
So, as a consultant, we are also doing the facade PMC for many projects. I think most of the projects we take along with the PMC. So we insist on that because this is one of the critical thing in the right now because of the labor shortage and there are too many the projects actually, and there are too less contractors or the skilled people now. So one thing is the good thing is most of the facade which are above like 5-6 floors and above. So we are going with the fully unitized system, which is more or less like your prefabricated panels.
Correct.
So in the site you don't put scaffoldings and all that. So you erect with the floor cranes. And earlier it was only glass we were doing that. Now we can integrate any material into it is just basically you'll have to design it properly and do it.
Yeah, you can use any infill.
Yeah, so that is helping us a lot, the fully unitized facade system. And even the contractors are preferring that because the rate of installation is very high, the speed of installation, and it requires less labor, and also the quality also can be much better because everything is done in the factory. The going forward, I think the future is like combining not only the facade, it's even the structural elements along with the facade. So I think that there are few buildings like Intel, if you see the Intel SRR 3 and 4. So they did in Bangalore, I think in India it was the first time. So they did the complete assembly, including the slab, columns, beams, everything, along with the facade. And it was a top-down construction. So they did it very fast with a very less manpower. Of course, the cost of doing that is high, but that's only 1 or 2 projects they've done. So it is like when a lot of projects come in, I think obviously the cost will be optimized. And also when you see the time, so now time is cost. When you see the time, so you will have to calculate the cost versus the time, and you will have to see what is the value in that. I think the future is that you will have to integrate your facade panels with the precast facade, and you will have to use the machineries to install this. And there are only few companies who can do that. 1 or 2 maybe in India. So that has to increase. So if that has to increase, then proper training has to be provided, and investments, whatever commercial, the big companies has to come forward. So that will mitigate this, whatever the current issues of labor and the unskilled people coming into this industry, that will be mitigated.
Like the Intel building example that you gave, it had a very different installation philosophy of the facade, which was primarily top-down construction.
Yes.
And it was very difficult to visualize first and then implement it, but it came out pretty well.
Yes.
It's actually a landmark in the installation of facade. Really nicely done.
And I also feel that I think that not many buildings are done across the world in such a way. And this was a success story.
Yes.
And I think since Intel wanted to repeat that in other European countries as well.
Yeah.
So ultimately, so what I mean is, like in India, you can do anything, and you can set an example for the other parts of the world.
Other countries.
So it's just that you will have to make up your mind and do it.
Right.
We have the skills.
Correct. That way we have to appreciate Elifit also, because they were the ones who actually did it. Okay, so one quick question on the post-execution side. So, I mean, there are a lot of advanced technologies that we come across, on a daily basis. Do you think these advanced technologies like drones, robotic sensors, they will actually help us in kind of building maintenance for the future facades?
So it's not really tested. See, it might have been done in the Western world. So the environment is completely different there. So the dust factors and the kind of the cleaning required there is completely different from what is required here. So that I think we'll have to dig in more into that, and we'll have to. It's like a trial and error. We will have to do it, or it has to be customized for our requirements. So we can't just copy that and paste it here. It won't work. That's my view. And still we are in a very basic thing, like you see 99% of the buildings are still cleaned with Spiderman.
Yeah.
And
the conventional way. Yeah.
Even I've seen buildings they have done, they've invested a lot of money on the gondolas and automatic the rails and all that. But the labors and the cleaning is still happening on those buildings also. It's happening with the Spiderman.
Okay.
Just to add to the point, probably we need to also do the life cycle costing, but it is all in theory, I would say, because it's not time tested, as Nandakumar is also saying. It's not time tested, but on paper, yeah, we do have savings. We do have, the sustainable things give a lot of savings in terms of operations. The IoT that is coming in, the sensor glasses that is coming in is giving wellness also to the employees, and secondly, it is also giving the savings, right? It is all in paper, but we have to try and test it. Only after test, probably a lot of the adoption to it may happen.
I just disagree on that part. There is actually quite a bit of data that is available with respect, of course, large corporations perhaps, but even in the Indian context, there is data that is available from user cases. Accessible or not, that's questionable right now. I don't think so. Every of these data is accessible, but when asked from industry professionals like you, I'm sure the data is available to see. And sorry to harp on this again, but then companies like Infosys also put up their whole data in terms of, and I'm sure companies like ITC and so on and so forth in India have a lot of this data, which is even put across in their ESG document. So yeah, so it's there.
When we are working on the cost, we do work the life cycle costing in order to test and try something that we have not done. We do that, but user data is more kind of a data security and things like that.
Not accessible.
It's not accessible. It is probably has to be analyzed internally on a good note, and we'll have to see how.
That's my feeling also. It will never come to the outside world because those are very sensitive data, which they will not reveal it outside. Maybe internally they will be utilizing it to model it better, so that whenever they are redoing or repeating the same stuff, they will use that data, but it will never come out. I don't think so it will come out. Yeah.
More internal, and it is more of used by that particular developer or the client.
If the intent is there, I mean, I'm sure it's not far off from an RTI.
Yes, I mean transparency.
So, I would like to say that if the intent is there to get some information, one can get it.
I would love you and me to go and convince them to get the data out so that we will also get some benefit out of it. Okay, so anyway, it's time up, but one quick question for the audience. On the future trend, because I had multiple things in my mind to be spoken about, smart cities. How do you see, facades, futuristic facades for smart cities? Maybe we can touch that topic, futuristic facade for smart cities, and what kind of materials that you can think of for those futuristic buildings, futuristic facade.
Yeah.
Just random thoughts.
So, I mean, the random
there is nothing right or wrong.
What I would like to do is probably put sustainable buildings in terms of, recyclable material, plant-based material, or, upscale material. First, sustainability first. Second would be energy efficiency in terms of, high efficiency glass, insulated metal panels and things like that. And lastly, I would also want to integrate, building technology into this, like dynamic facades and sorts. Mm-hmm. So I see the future of building facades to having an integration of all this, holding on to the past, as well as, moving towards the future in a very calculated and open-minded way.
Future ready for me would be, I really would like to see a facade system which would work, which is resilient, which would definitely work in both air-conditioned spaces where the grid is working, as well as when there is no electricity, but you still have to be inside a building and then it still works. I mean, of course, in the commercial sector, not really in the residential, but something that can work both ways, a ventilated facade or something that allows air to come in as well as keep certain stresses away. I mean, I would definitely like to see that more.
Double skin strategy.
What's also important that I feel is that we are building today, but what happens to all these buildings after the life cycle of the building is over? So we have to be conscious about the fact that the materials that we are using have to be somewhere recyclable in the future, because otherwise we are just mindlessly building, and what happens to it when the life cycle of the building is over? That's a big question mark today.
Right.
I think that's important to kind of ponder and think in those directions as well.
That's what we need to think right now.
Yes.
To address this issue after 30 years.
Yes.
Yes. Correct. Any last thoughts?
Since you touched upon smart cities, I think generally smart cities that I have been connected with are mostly on an infra side. Correct. And building the best infra for the user or for the common people. That's what it is. And also it was like building some marketplace, the social places like schools, marketplaces, uplifting and upgrading them. Of course, use of sustainable materials and use of biodegradable materials were part of it, yes. But I think we need to evolve a lot in order to get the smart cities, get the facade into the smart cities that I feel. Probably we can have more discussions on.
Yes, of course, I would love to, but These people, they hate me. That's
Just
why.
one small last thing. So there is a lot of work done on the Griha. You see, the Griha is developed by the government of central government, and there's a lot of data, a lot of things done in that, and we have done a couple of projects for the Griha rating as well, and I think it is more Indianized and a lot of like energy savings thing, and that star ratings and all that.
Yeah.
So I think if you simply implement that as a mandatory thing, a lot of, at least if not 100%, I think 70 to 80% of the things what we are talking about, sustainability, energy savings and all will be done, and automatically it will be achieved.
True. That will be in the direction of net zero by 2070 or at least 75%.
It's like a Bible for all these things.
Right. Okay.
Yeah.
Last point.
Yes. So when we look at buildings and cities, so like Anup sir was mentioning, we can't look at a building isolated. Ultimately, we are all, contributing to something called the global warming, and we need to be mindful of it right now. And we know there is a predicted 2 degree, 1.5 degree rise. And if we are, wary of it now and try to take measures to mitigate that, we'll also be cutting down on this urban heat island effect, because the kind of materials we use are emitting a lot of heat into the environment. So we need to cut that down as well. So in terms of long-term goals, I think buildings should be more responsible and not just, thinking about what's happening within our building, but also be mindful of how we are contributing to the larger environment. It's very important.
True. Thank you, everyone. I would like to wrap up this discussion. It was really a really good discussion. Different people from a different background with a different mindset. My blockage is open now because I had some certain bias to a couple of things, which is very clear to me now. I hope, unfortunately, we cannot take any questions. But if there is any question, we can still be around and we can still have a short discussion. Okay, so thank you, ladies and gentlemen, for being so patient. I really appreciate it. Thank you.
Thank you very much.